Hey Q, how's it going? Moop moop. We are chilling on a Friday. Tomatoes here. Yeah, we're not working too hard on a Friday, guys. We're gonna maybe. And there's Pesta. How's it going? We're gonna play some video games, do some Linux. Just see where we end up today. We'll pull up some stuff. I also have what do I have to do here today? Hold on. Linux group. I was gonna check. I was really just about to check something, and now I don't remember what it was. Oh, book. I published the last version of the book that's going to come out for quite some time yesterday. So here's the current book format, and we will probably play with it here as we kind of go. We'll start in Linux today. Big Book of Prologue Labs by me, and we'll be doing that here in a little bit. And we'll start with the philosophy of learning Linux. We'll talk about some of that stuff, but we'll get there in a little bit. We're probably going to play some games today and stuff too. We're going to probably, just do the normal Friday thing, which is not work too hard. I told you guys that we're here last night. The wife is gone in scrapbooking retreat, so I got a little bit of time hanging out, doing some stuff. I have until Monday before my next college class starts for teaching 3 classes next quarter. In fact, one of the things I need to do is go through my college stuff and make sure that it's all up to date. So I'm teaching a Network 260 course. I've got a bunch of docs, but I didn't just need to touch them, make sure they look like what I expect them to. So I'll probably do that a little bit. And then I've got a new class that I'm teaching, and I want to make sure that I've got everything organized for that one as well. So I'll probably do that as we kind of get into this. The other thing that I was planning on doing is I got a project in Linux that I got to get working. Hey, how's it going, Twisted Seed? I got a project in Linux for my home lab that I want to get built, and I kind of planned on doing it this weekend before I'm going out of town next week on a Friday, going to Mexico for like a week, and I just want to make sure I have kind of all that stuff done. I'm really glad the book's done, so that's all kind of done. We're going to go through it. We're going to look for any, glaring errors, any of that kind of stuff that I might want to fix before I maybe think about publishing it one more time. VPN to my home lab from Mexico. Q, I don't know if you know this, but I can get into my home lab from anywhere in the world. I can actually jump in and, I can do anything I need. My SSH, my external SSH connection, I can get in it from anywhere. So yeah, I can connect if I need to, which is nice. I can also pull up anything I need to from like my home lab, and like all my documents. So even if I don't have documents with me on this machine, I can SSH over, pull them down, and then do whatever I want. Like if I want one of my jiu-jitsu videos or something, catch me on the. I will be in Cancun actually. It's funny. All right. So here's what I'm gonna do. I'm gonna start out. I'm just gonna be playing some video games while we start. So I have not played some Brotato in a while. Put some Brotato on when we're hanging out. We'll see if anybody shows up. See if anybody asks us any serious Linux questions, and see how that kind of goes. Wait, there's a DLC for this? Wait a minute. What do you mean there's a DLC? There's more things we could play with Brotato? Down in the deep sea? With more monsters? Oh, no. We might have to play that. Hold on. Chainsaws? Oh, hell. Alright. You guys might have noticed I jumped over to the Just Chatting channel, so we're hanging out. Twisted Seed, I already was trying to stay away from HashiCorp, so that seems pretty par for the course that they would be sold to IBM. $35 a share, right? And it was something like 6.8 or 6.9 billion and then IBM bought them with cash on hand. The interesting thing is when IBM bought Red Hat for 28 billion. I just read this the other day again. I got the page right here in my notes. When they closed 34 billion. One of the things, and I was at the keynote that year, and IBM pointed out, they're like, yeah, we bought this, and they technically are a software company that doesn't own any of the software. I don't know if you guys knew that. Red Hat doesn't really own, well, they don't own anything anymore. They're owned by IBM, but Red Hat didn't own any of the software. They just were a pipeline. They were like a sausage maker that took all of the software and sausaged it up and brought it in. They didn't own any of the software. Yeah, okay, Red Hat owns like Ansible and that kind of stuff. That's not what I mean. What I mean is the operating system and everything that they did, they had copyright to it, but all of the stuff that came down from different pipelines and stuff. Red Hat made all of its money off of licensing and support. That was it. So when IBM bought them, that was a big major thing. So I just linked that for people that wanted that. That was actually from some of my notes for this was I use these in my college class. Those are my APA citations for some stuff. Anyways, while we're waiting for people to show up and kind of hang out, I'm gonna play me some Brotato, and you guys can vote. Not vote. You guys can bet or bid or predict. And let's see. Start a prediction. Will I beat round 20 of Brotato? Yes or no? I'll give you guys 5 minutes on that one. And so you guys know, I don't beat round 20 very often. But I'm going to play on my favorite character, which is the Doctor. And you guys can bid or bet or vote or whatever you want on that. Oops. What do you guys think? And you guys can predict with points. All right. We'll see how I do. I won't get in any trouble on this character until at least level 10. So use your points wisely there. And if anybody's got any Linux questions, let me know. We will do Linux. We'll be messing with that stuff too. How's it going, Bearded Dragon? It's Friday, so we mess around on Fridays, right? We don't work too hard. Oh gosh, it's been a while since I played this. We'll take attack speed. And I need this, and I want this, and I want that, and I want that. All right. On to the next one. Once more again, onto the breach. We'll see how we do here. Yeah, they did buy HashiCorp. They announced it 2 days ago, yesterday. Somebody help me out. I think it was yesterday. I posted that in my discussion group as well for college, because that's important. We were doing mergers and acquisitions, and that's definitely an acquisition. That's definitely big for them to do. That do I have that one? I don't think I have that one linked, but we're going to take harvesting because it's still early. I do want that, but I'll get it later. We want glasses. All right. Yeah, my only problem, I think I told you guys this before, my only problem with OpenTofu was that it's still using that HCL HashiCorp language, which means that it's still beholden at some level to HashiCorp. Now, I guess they could just not use any new versions of the language, but I think that that's going to start to cause some problems, some divergence. Also, this game's kind of choppy. I don't normally have... This game's not normally nearly this choppy, so I wonder if something's going on. Maybe I got too many other things going on my other screens. All right, we're going to take this one because this guy heals fast. And that's fine, that's fine. Take crit, take another gun, take that stuff. Save another gun. Good. All right. You guys can still vote, I think, for a few seconds. Am I going to make it to the end or am I going to die? That's your... You guys can vote. Also, again, real choppy right now. I don't know how this game can even drop to any kind of low frame rate. Like, we're not doing anything on my computer right now. Barely doing any visuals even here. So, oh well. Anyways. We'll get to it. I haven't tried, I've like looked at Pulumi, but I have not tried Pulumi much. Like, I haven't used it professionally. I've been using a lot of Ansible at work though lately. I mean, I always use a lot of Ansible, but even more than normal. Alright. I want damage. Armor only works for half on this guy, so I don't want armor. It's just not worth it. Take that. Take more of that. Garbage. Garbage all around. And Robodom will be messing around with Linux as we go. We're just kind of hanging out for right now. Just, you know, Friday afternoon. What's our time at? Yeah, it's not even 4 yet, so we're just hanging out. Not even 4 for me yet. I got all night because the wife is out of town, so it's this or sit here by myself and do stuff. And I get a lot done when I'm by myself, but it's probably better to just hang out, see what's kind of going on with everything. Normally on Fridays I get chased off here when the wife gets home because I gotta go do date night. But she's out of town, so I can do whatever I want. So we did finish the book up yesterday. I mentioned that earlier. So the book is, we're going to go over it a little bit here. We're going to talk about philosophy of learning Linux, how you can use this book if you want to, people that want to. If not, you can just hang out with me and do it right here. But some people want to do it offline and kind of go into it. And then we'll do some of the labs kind of as we make it through the night. Also, I really want to get one of my pieces of monitoring built. So soon I'll get in there. We'll take regeneration because this guy gets double regen. We'll take harvesting because he gets a lot with that. And take damage. And another gun. And you know what? Even though it's wave 6, we'll take the weird ghost so we get more hit points. And I really want all of these things, so I'm going to take all of them. You don't get any penalty for storing things, right? So it doesn't hurt you any. Yeah. Robodom, I haven't played this in a while, but I figured I'd get on here and play a little bit today, kind of hang out, talk shop, see what kind of systems work we've got going on, see if anybody wants to talk about anything interesting. You guys know we've got a Discord. You can hang out down there, talk shop with the other engineers and stuff, see what's going on. Actually, one of our guys, Pico, he posted a pretty interesting little problem that he found in Ansible, so that's something that's kind of interesting. I just saw Robodom. There is a new DLC. I was looking at it, but I didn't download it. We could go buy it, maybe. I mean, me and the wife always joke around. There's a scene. Anybody here ever seen The Rundown with The Rock and Sean William Scott, who played Stifler, and then what's his name's in it too? Christopher Walken. And there's a scene where he's getting chased out of town at the end because he's kind of been like running the mine and nobody likes him, and he yells at the people and he's like, "I was good to you people. You had nothing before I came here. Now you got a little coin in your pocket." And then they like shoot him and he leaves town. He falls over dead. Anyways, me and the wife, we always joke around about like, "I got a little coin in my pocket." So you know, I got a little coin in my pocket. I could buy a DLC that's probably $10. You know, I can get away with that. But anyways, we'll see. All right, we don't want to let those things. If we can avoid it, we do not want those things to pop, those little eggs, because if you guys haven't played this, the eggs, they got about maybe 3 to 5 times the amount of hit points as a normal enemy. So you really don't want to let those eggs pop if you can avoid it. They're not problematic as little eggs, but if you let them turn into big enemies, they're a lot more troublesome. So I'm gonna try to keep them popped. They show up typically 2 at a time somewhere on the screen, so I'm really just looking for them the whole time. That's all I'm doing on this wave. Right now, I'll let one pop, but because it doesn't matter right at the end. But for the most part, you do not want to let them turn into creatures. Robodom, that was not Dwayne The Rock's first movie. No, he was around way before that. I'm pretty sure. Well, he was definitely around before that, but I don't think that was his first movie. I do really like at the beginning of that movie though. He's standing in the bathroom and he's like calling the guy and he's like, "I don't want to do this right now." They've got a legitimate chance to repeat, and at first you think he's like kind of pussing out a little bit because they're all big football players, but really he doesn't want to injure his football team that plays for, you know, his I forget who they play for, if they were Titans or something. I don't remember the story, but the point is, he goes in and he ends up kicking all their asses, and basically that ends their next season because he breaks the quarterback's hand, he beats up all the players, and you know, busts their knees and all that stuff. They're going to be out. It's kind of funny, but yeah, that's a rock for you. That's definitely one of his earlier movies though, but I definitely saw him. No, his first movie was He was the Scorpion King in the second Mummy movie, I think. Yeah, that was his first movie. But before that, he was WWE. Robodom, you're making me think about things I don't normally think about. Yeah, he was in that other movie first. All right, look, it's starting to get a little hairy here. You guys can see. Not too much trouble yet, but let's see. How'd the voting go? I need to look at my predictions real quick. Hold on. How'd the voting go? You guys think I'm gonna do it? Well, somebody thinks I'm gonna do it. All right, we'll see. Berserker Gummy we want. Compass we don't want. Garbage. Hit points are fine. More guns. Blindfold for more crit. Another medical gun. More experience. That's good. This is one of the harder levels if you don't have, and I don't have the thing I need. If you don't have the thing that gives you penetration, so either the bandana or I think it's called like a funny bullet or something like that, special bullet. Either one of those gives you penetration over the enemies, and if you don't have that, these guys, see how they're just like kind of piling up on me? If I had those other things, the rounds would be going through and doing damage at about 50%, but I would still be really messing these groups of people up, these little or aliens or whatever the hell they are. So, all right. Anyways, we'll do a little more Linux here in a few, guys. I just have to get the bet out of the way now, because now I've made the bet. All right. And I thought I saw, yeah, one of these little guys. I need to kill him. Those loot goblins will always have a little crate, and the crate always comes to you, so you don't have to pick it up. It was good, Robodom. The day was good. I've been working all day. I've got more work to do, and I also need to keep an eye on. I'm the on-call, and we have something that's not alerting properly. One of our many alerts isn't written into like a codified alert, so I have to keep an eye on the system. So I'm kind of doing that over my shoulder here. Missiles are good, but they're not. These things are all okay. I really want. All right. Let's see how we do. Level 10. Well, I beat level 20. That was the prediction earlier, right? And some of you guys have lost your points so many times trusting and believing in me, but one of these days I'll pass. No, I'm just kidding. I beat this pretty regularly, but I'd still say it's only about 50-50 though, because you do got to get good items and you got to pick right. And this is my highest percentage of finished character though, right here, for sure. All right. One more damage than I wanted to take. Okay. Alright. Bunch of points to lose. That's fine. Alright, we want range damage. Armor is nice, but not important on this guy again. He only gets half. We want all those things. No. I do like this, but yeah, alright. We got a boss in the next level. We got a little mini boss, so we just got to make it through these guys for this round. Oh, that takes a lot of damage. I don't want to get hit too often by those guys. Which also shows me I only have 50 hit points, which is not a lot of hit points for right now. I'd like to be a little higher by this point. We'll see. Thank you for the follow. Hopefully this stuff's useful to you. Although we're not really doing anything too useful right now, but normally we're doing a lot of Linux stuff. We're just messing around for right now. We'll get into some systems work here shortly. And that's also why I dropped down the just chatting channel, because then I can chat all I want and play video games and do whatever. I don't have to worry about. Plus, I have other games to play besides Brotato, so we'll do whichever one's interesting to us. Alright, well that's way more damage than I want to take. Alright. Robodom, they follow you, so it's simpler than it looks. They mostly just follow you. So if you kind of know how they move, it makes it a little easier to deal with them. I want this, but I'm going to take it on the next level because I got a boss coming up, so I don't want to get extra enemies on a level with a boss. So, oh, we always look like baby geckos. Baby geckos give you 20% chance, so if you can get 5 of them, you get 100% chance of all your items floating to you, which is awesome. And then also they give you plus 10 range, so the baby geckos are really good. There's also a thing that's called like Sidif Q's Relic or something like that. I don't know exactly what they're saying, but I forget it. Maybe it's Sidic's Relic, but it does this as one item, and it just gives you, everything floats to you, so you don't have to run around and pick up your experience anymore. All right, let's see what boss we got. Okay, this is one of the harder bosses to beat, as far as he just, oh, see, he can beat you pretty quickly if you're not paying attention. But if you are paying attention and you're doing pretty good on the other stuff, he's not the worst boss there is. But he does change the way he attacks halfway through. So you gotta, jeez, gotta watch how he attacks. Going. All right, enough playing around with this fucking guy. He's very much a hassle, though. All right, get out of here. Die, you little asshole. Die, 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 die. I'm just kidding. All right. Die. He needs to die. Whoa, don't die. Son of a... Alright, sorry guys. Alright, so some of you guys are getting prediction, choose outcome. I did not beat 20 rounds of Brotato, guys. Alright. Let's, as our penance, 1, let's check on Ranger Dog. He's doing good. Just fed him, so he's pretty happy. And 2, let's go to Killer Coda. If anybody wants to do the first lab, we will do the first lab, and I'll read a little bit about kind of like what's going on. Lost your points refund. I like it. Did I drop down? Am I not one? Oh, I am. Okay, I'm still number 6. I don't know how they do that, like what the rhyme or reason is of that. But we're gonna go to the Linux labs, which are here. Labs, right? There's all our labs. But the specific lab that we're gonna start with is this one. So I'm gonna pin the lab for you guys. Pin this lab. Leave it up there until we unpin it for the stream. And here's our philosophy. So here's the Linux users group. This is the book here, but our philosophy of learning Linux. The professional Linux users group is a group of engineers focused on taking hobbyists and turn them into professional enterprise administrators and engineers with Linux tooling, right? So I want to make you guys understand this and be able to do it professionally, right? To that end, the goal is as much time hands-on the keyboard. We want you immersed in the execution and analysis of output of as many commands as you can possibly use. So I just want to drop you in a Linux system and make you do Linux. That's the goal of this group. That's the goal of me streaming. Well, I guess the goal of me streaming right now is to have something to do, because I could have just been sitting here by myself, but I decided to hop on here, right? And then the goal is to do many simple things well. You guys will hear me say that all the time. Like when you watch me do Linux or Ansible, all the stuff that I put in the Ansible labs and all the stuff I do in the Linux lab is literally what I do all day. I don't have some deeper knowledge. I don't have some, eldritch horror level knowledge of how the chaos and the entropy of the systems work that make it work better for me. I do stupid simple things all the time, and people act like I'm casting spells. And I tell you guys all the time, it's just doing the basics well that kind of keep you in a job. So. All right. Complex systems are built of many small, simple steps. We'll prove that in the Ansible labs as we build the systems from individual tasks that become larger playbooks. Yeah. The man pages, yes. All right, so here's the ways that I say you could use this book and do these labs. You could just go through. Look, here it goes. The book is designed to help facilitate enterprise Linux knowledge and system experience while executing the Prolog labs that are found on Killer Coda. There's Killer Coda right there. Killer Coda is free if you don't know. You can get in there and you can do these labs with me. There are 3 general ways you could go through this book. You could do these as 10-minute labs in the morning. Just execute the commands as fast as you can. Just click next, done. And you would learn something, I think. You would, beneficial for, if you're a systems administrator already or you've seen this and you've been in the command line, you could probably blow through these labs quick. But then I also say you could do this in 30 minutes. You could go through labs, thinking through the questions, writing out the answers that reinforce what you're learning. I'm a big fan, guys, of having Notepad++ open and writing things out, or taking the commands that you find that are useful and throwing them in Notepad++. When I do stuff for work, and even when you guys see me do stuff here, I will constantly be pulling stuff out over here as I'm doing it. This was actually my tests when I was setting up the UFW labs, right? These were, I grab my commands out as I built the thing and I did all the commands, and then I go grab them and I hold on to them, and then I can filter these down, and all you guys see is the completed work, and you're like, oh, he built that off the top of it. No, I fucking didn't. You guys watched me fumble around here for 2 hours building this stuff, the guys that were around. We don't build stuff perfectly every time. That's why I say you document and you plan and you document, and there's some hacking in between there, and that is the overarching idea of systems administration engineering, right? So anyways, that's a 30-minute lab. And then 60-minute labs, go through the labs, thinking through the questions and writing out the answers to reinforce what you're learning. And then spend some time in the digging deeper sections to solidify what you learned. Journal out the topics for yourself to ensure you have understanding. This approach will be best for the academic and scholarly focused users who want to better understand the why of the system they're dealing with, right? So with every one of these labs, there's the 10 minutes that we can blow through it, but then there's also I can go spend all this other time, and I can go spin off into all these other things, and that's the goal. That's what I want you guys thinking about. I got this little rollerball mouse that has a ball on the top, so I can use my fingers on it, and just the last couple weeks, it's been getting like something on the ball. I don't know how it's getting something on the ball, but then I have to keep like peeling it off and throwing it away. I don't know what they are. They're like little, I don't know, for lack of a better term, they seem like they're like, I don't know if you ever like dropped a cornflake on the floor and then it's like hardened, like a little, I don't know. Anyways, so I don't know. They're really weird. They've been on this thing. It's weird. I just picked one off, whatever the hell it is. I don't know. But anyway, so 60-minute labs, spend more time, that kind of stuff. But the point of this book is to get you doing something, right? So here's the Linux lab guidelines. 01 through 99 are the labs on the general command line and system checking type stuff. Then there's labs on configuring services and monitoring tooling. And then there's labs on Linux security topics. So these are the labs that are in over here. So if you just looked at the generic page, these are all the labs right here. And I gave this, for people with the book, I gave this so that you could go in here and you could take this and you could check them off as you went, right? Maybe if you had done whatever. Drop a few cornflakes. Yeah, you know how they're soft because they were in milk and then they harden on the floor and they're all weird. It's kind of what these feel like. I got to kind of like pick them up. I would call them boogers, except I don't know how they're getting on that thing. And you might say, well, Scott, are you picking your nose? Not any more than normal. Not any more than it should have started in the last 2 weeks. I've had this thing for months, right? All right, anyways. So let's do this. This is our lab for system checking. And here's a lab link, which will take you to the system page, right? And the first task is, by the way, I'm doing task condition standard. Does anybody know where I got task condition standard from? Has anybody ever seen that? I bet in a room full of 20-something people, somebody besides me has seen task condition or standard. Task condition standard. There's a very common methodology for teaching that. Does anybody know where it's from? I think, is Beard Dragon around still? All right. So the task. Determine the operating system values of a running Linux OS. I'm getting dropped onto a Linux system. I can guess that it's Ubuntu, but this could be lying to me. I don't know that it's Ubuntu. So what's going on? We're going to execute the commands and evaluate the output of a running Linux system. So never been on a Linux box before. Here we go. Our condition is given a bash prompt, complete in the allotted 60-minute times. Twisted Seed is from the Army. Military does this. Military does task condition standard for all trainings. That's the way the Army does it. I think the Army and the Marines do that. For sure all the combat arms do, because they, that's about as deep as you get anybody's attention. And then the standard is to work through the lab at a pace that matches your learning goals. So 10, 50, yeah, control byte. Sir, yes, sir. You guys heard my joke about the sergeant comes out and he yells, I need 2 volunteers. And somebody says, for what, sergeant? And he looks over and he goes, now I need 1 volunteer. That's why you never speak up in the military, right? You just, because you're volunteering if you say anything. All right. So over here, here's the lab, right? Here's what we're doing. You are a new system administrator at a company. You've been tasked with finding out information about a set of servers that has little to no documentation on it. Now, full stop. How many of you guys think that's probably something that happens a lot? Like, I don't know, none of us have been on those servers before, or we're a brand new team and we've, like, everybody else has left, or, I mean, guys, that's probably pretty common. So, whether we give that last handful lab, fun lab of verification, but yeah, control byte. You could try to fix it if you want with some pull requests. I cannot. I just left it as been true, which always works, and that's broken too. So I don't know what's going on with that control byte. A few weeks ago on stream, I gave that thing some trouble. Is there a way to easily prototype? Oh, for the lab? No, it's really just to run it. However, did you know that you could... Well, I was going to say technically you could run your own. And you can run labs that aren't visible to other people. It's because UFW, we're setting it to default denying the lab, but there are some ports open that it needs. Yeah, I guess. Yeah, you know what? That's exactly it. I didn't even think about that. We block off the 40,200, which is the check. Oh. You know what? That's exactly what it is. I said that's some bullshit port. That's how their administrator comes in and checks the labs. I can almost guarantee you that's it. So you know what we'll do? We'll fix that lab later, maybe later today or sometime this weekend. We'll fix that lab and we'll allow it, but only for the local network. That'd be a cool little one to do. So we'll show how we can allow that, but only for the local network. And then I bet that fixes it right there. That's good looking out, because I had been kind of beating my head like, why the hell does this not work? I know we can SSH, but that system comes in on that. It's even called the KC terminal. So that's their killer coded terminal. Oh, hold on. My wife just messaged me. Tomorrow I'm going to get a sweatshirt from the coffee shop. And I'm going to be like, what? I give her a hard time. Yeah, you can get a $20 sweatshirt. She is in, so we live in Phoenix, right? And Phoenix has been getting up in the high 90s. But today it only got to like 77. So I messaged her and I said, hey, well, to my wife Julie, I said, hey, it's only 77 here. And she sent me a thing back. It's like 50 there. So it's really cold for her, and it's colder at night because she's up like 2 hours out of the city. She's in a place called Payson. If any of you guys know where Payson is in the Phoenix, it's up to the northeast of us, yeah. But it's up in the mountains a little bit. There's some elevation to it, and it's cold up there right now. And I told her, I was like, enjoy it, because this is the last cold you're gonna get. When she comes back here, it's gonna be it hit 100 here for 10 minutes the other day, and that was like on like April 20th or something, like somewhere around the 420 time. It hit 100 degrees here already. Brutal. Just brutal. All right. So let's do this lab. You're gonna figure out some stuff about systems. Okay. Anyways, she said one of her friends. Anyways, my wife. You find yourself at the command prompt and need to find out what type of systems you're on, right? So we got to figure out some information. What's the release and version of the system? What's the kernel? How long has the system been up? And what's its kernel called as the grub, which is the Grand Unified Bootloader, right? Yeah. When grub or grub 2 came up, how did it boot the kernel? And then there's a bunch of solutions that'll help you out if you get stuck. So what are some of the things we want to know about a system? So if you're just doing this for the first time, you come down here and you can actually literally click and it'll drop the commands in there for you. I think, and this is me having done this for a long time, I think there's some value in typing out things at the command line. I think that there's some value in understanding like how these kind of things work. But let's look at what this first thing is. We did cat etc splat release. Splat is shift 8 or an asterisk, as some people like to call it. You'll hear old systems guys call it splat. That command showed everything that was in etc release, and that asterisk said any of the files that are in here. I can do an ls-l. And that would tell me that there's an etc lsb-release, and then there's an etc os-release, but that's a link over to user lib os release. So there's these two files here that can tell me about what's going on in the system. There's this user lib OS release, and then there's also this etc lsb dash release. But I just like to do this because on most modern Linux systems, this is going to find something. On most all modern ones in the last 20 years, this is going to tell you something when you do that command right there. Yeah, of course you could do OS, you could do there's a whole bunch of them. In fact, let me show you like the old CentOS systems. We'll do an ls-l etc splat release. Look at all these ones. There's etc OS release, etc Red Hat dash release, etc system dash release, and they just link back to the CentOS release, which is here, and then this one points to that other one. So there's really only two files here, and then two that are links back to that file, right? So that's how you would read that. But over here, what do I know about this system? I'm on an Ubuntu system, so that's going to tell me the types of package managers I'm going to use. That would also inform if I had some kind of problem and I had to go to the Google and or DuckDuckGo, whatever tools you want, and you're going to go out on Internet Safari and read about some stuff. That's going to determine what you put in there. Here's the distribution release, 20.04. And then I see down here 20.04.5 LTS, long-term support. So that tells me LTS almost universally in the OS space. And it's funny, I originally heard this from Ubuntu many years ago, back on maybe version 9. LTS tends to mean, long-term support tends to mean 10 years of support. Doesn't always mean that, and they can change their focus later. But typically on a release roadmap, LTS versions are long-term support for 10 years. What does that mean? That means for 10 years you get security, bug fix, and errata. Those are your major ones. Security, which is security based on vulnerabilities that come out and are introduced into through the repos. There is so that security. Bug fix is just errors and things that people put in, and then errata are I believe that just means non-system things that are anything else, right? It doesn't fall into system security or bug fixes. Errata is like everything else. Those are like the big three that we typically see. But it gives us some information here. It gives us it's all key value pairs, so we could parse this down if we needed to, like to the version or just like the Ubuntu type. There's all these things here. But then we do a uname-r, and that gives us the kernel version. So this is the kernel version that the system's running on. And I can also do a DMI dmessage, and I'm going to pipe that through a head. Dmessage, pipe it through head, and I'll see how my system started. This is how, when the kernel got called, this is exactly the way that the kernel got called, what the kernel is, the command line boot as the system was started, all of these things. Yeah, thanks that WMW. Hopefully this stuff's useful. But yeah, this is like the goal is to get you guys doing this, and most anybody that watches me for more than 10 seconds is probably in the Linux space as a hobbyist or even as a pro. And my goal is to show you guys that aren't pros yet, you can go do this stuff professionally. You can go make good money at this. All you got to do is understand these basics, and then the other skills will come kind of as we go, right? Okay. So, we do that. We do an uptime. What's uptime do? Uptime tells me how long the server's been up. 1 hour and 33 minutes. Yeah. Thanks for that, Psi Gamma. My goal is just to show you guys the simplicity of this, right? Like I show you guys simple things, and then those look complex over time, but it's all simple, right? Our load average is the 1, the 5, and the 15-minute load average, right, of our systems. And we can spin that up. In fact, in some labs, we do spin this up to get that kind of stuff. So there we go. And I see a bunch of information here. I'm constantly showing you guys this same line right here. You can find as just a single individual line if you want. You can cat proc CPU, CMD line, right? Command line, and that will tell me how the system was booted. And sometimes, if I want to check a bunch of servers, I want to make sure that they're all the same version of the server. They were all booted the same exact way. Because I find that if things are built as one-offs or people have deployed them separately or done different things, what tends to happen is you see it immediately. You see it at like these early things, and then it kind of blows up later and gets further and further away from, whatever baseline you have. So I always look at stuff like this, and if things are different here, I know that it wasn't from my boot scripts and my, kickstarts and those kind of things that I do. So we've looked at all that. And then over here, we're asking, I'm asking extra stuff for you to think about. What useful information do you see from the Etsy release? Why might you need to look at this information? So as you look at that, I mean, you go start reading a Stack Overflow article on some problem that you have, and you're like, this is awesome. It's a Apache 2 Linux on an Ubuntu 2204 release. This is awesome. But then you realize it's 2204, which was a release of an OS 2 years later than this one. And even with patches, this one is not a 2204 system. It's a 2004 system, even if you've patched it. It's never going to be that other system. Well, I mean, I guess you can do some other stuff to muck around with it. But for the most part, it's always going to be this older version. And what that means is you're looking at the wrong type of paper. You're looking at the wrong article online, So maybe it gets you to the right answer, but more often than not, it's not going to help you. Especially if you're looking for driver information or module stuff, it's going to be, specific to that kernel. So that's kind of an important thing. Cat Etsy Splat Release tells you the version of the OS. I said, what information do you see with the kernel and uname-r? Look up semantic versions and see why this might be important. So uname-r, we see a major version of 5, a minor version of 4, and a patch version of 0-131. They coming out with 2404. Yeah, 2404 should be out soon. Yeah, should be. But look at this real quick. How about semantic versioning? semver.org. Whoops, .org. If you've never been there. This will tell you a lot of stuff that you might need to know about semantic versioning. And semantic versioning is the same in the systems world, in the software engineering world, in the security world. We're all using this same versioning, so you don't lose anything. I try to show you guys when there's things that you don't lose anything by studying. You're like, Scott, I'm going to go in and be a Linux engineer for a few years and I'm going to pivot over to security. I'm like, good, learn this. And you're like, okay, well, is that super useful? And I go, yeah, that's super useful. And then another one that I don't care where you're at that always matters is like your HTTP codes, right? I don't care where you're at. You should know. Let's see if they have. I like the Wikipedia pages. You should know your status codes. If you say, Scott, I don't even know what you're talking about, I say, well, as a well-rounded systems engineer who interfaces with your networking teams and your storage teams, and I've got to pull information down to answer questions about how my servers are being built and what they're interacting with and all these kind of things, I should understand these codes at a high level. I'm not telling you have to memorize every one of these codes right here. Look, it's all the 200 codes, and I know the difference between a 204 and a 205, but nope, don't care. What I think you need to know is a high-level understanding that, like, a 400 error is your side of this stuff, and a 500 error is their side of the stuff. So if you see a 404, that means you went to an address that wasn't there. And when you see a 500, that means maybe you were going to the right place, but something else was wrong on the server side. So understand client and server errors is tremendously important for where the error came from. Redirection, very important. Was I trying to land somewhere and somebody moved me over here, and in a, maybe there's a warning that I never read because I'm doing it as an API call, but I start noticing a bunch of 300s showing up in one of my systems and one of my logs or something. Well, I know that something's changing and being deprecated, and I probably need to go review it, because at some point, sometime in the future, maybe 2 months, 3 months down the road, that's no longer going to redirect. That's just going to be broken. Can I show you guys something cool? I think this still works. Let me go to this server right here. I'm just going to grab this here and pull this out. This is my Grafana at home. This is Ranger Dog, right? And this is one of my favorite things. I'm going to just go to let's go to Grafana and just do something bullshitty. It's one of my favorite error codes right here ever. Have you guys seen this before? By the way, WWMW, if you want, throw that in the Discord, and Robodom can post it if you need to, or I can post it. This is one of my favorite errors ever. Look at that. Can you guys see that? I love it. One of my favorite things that I've ever seen right here. If you can't see that well, hold on real quick. I'll throw this in the Discord for you guys. But this is, hold on. This is a very common, and what it shows is it's a 404 error. So check this out, guys. It's a 404 error, and it says chances that you were on the page that you were looking for then, back then, it was 100%, but now you're at 0%. So this is their way of telling you you're not on the right page. This is a page that doesn't exist. This is the 400 error, the 404 error of a Grafana page, a Grafana web server. I think it's hilarious. Back then you were sure, but now you're sure you weren't. Chances that you're on the page you were looking for is the area under the curve. I think it's hilarious. One of my favorite little error messages. I'm gonna post it in the Discord real quick. I haven't done that in a while. It's been a while since I posted that up in the Discord, but hold on. It's gonna say, hold on. Let's call it DevOps. Never forget Grafana 404 page. Boom, there you go. So if anybody wants that, that's so funny to me. That may not amuse everybody else as much as it amuses me, but that's pretty good right there. I've seen that many times now, so it's not as laugh out loud. But the first time I saw it, I was cracking up. All right. So, anyways, again, lots of stuff, lots of things to learn, lots of things that we can go do from these labs, and we're spending a little more time with this. This is like a real, like full 30-minute lab. And I said, why might you care about uptime? What information is shown in the last three numbers? Why is that important? Well, if I do uptime, and I get to this server and I see it's only been up an hour and 41 minutes and something just started, or some error just started, it's probably due to that reboot. But if I get to a server and something hasn't, like it's up 200 days, which sometimes happens, I've seen things up way longer than that. But let's say 200 days. It didn't get patched last time. Well, I don't suspect then that a service got restarted as the box rebooted. But the next thing I do, the exact next thing I do is last pipe it through more, and I see who's logged into this box. And I see if users were in there or whatever. So anyways, that's there. Robodom, he might have posted in the Discord. Let's go see what's in the Discord. Somebody, you guys can post things down in Discord sometimes, and then I will. I can pull them up. Wait until you make it. GitHub being cringe. What did GitHub do? GitHub's charging people? Interesting. All right. So anyways, there's all that. You hit check, it'll go on. It says, now let's dig a little deeper. Do each command and think of the output that you're looking at. You may need to run them multiple times if needed to compare the output. So we're going to look at what's going on in the system. So this first one is a VM stat. And I say, oh, what information do you see from cat-proc command line? I see how the server started. Why might this be important if you're running a fleet of servers? Well, it's easy to see how servers are different if you're just checking that one way that they booted up. So when looking at system usage, is this system under high load? Why or why not? The system's not under high load at all. Very, very low load. Let's see, what is this thing? This will be my risky click of the day, guys. Hold on. Normally, you got to put these things in the Discord, but let's see. That's pretty accurate. That's a good way to do it. However you guys remember it. But yeah, I've seen this one. This is pretty good. Hold on. Here you go. Go away. You effed up. I effed up. You should know at a high level how those codes work, because you will be. I do not care what you're doing. Software engineer down in a basement somewhere. Linux engineer or storage engineer down in the basement, you will be dealing with those error codes in some way. I don't know exactly how you're going to be doing it, but I guarantee you're going to be looking at web pages or hitting APIs or feeding out APIs, and people are going to be giving you messages about things, and you're going to have to take it to your vendor if that's not something you do. But you will be dealing with those codes in some way in your career. So it's the same thing I tell people with networking. You got to know at least enough networking to get your systems on it, because nobody runs Linux servers just to sit there and run Linux servers. Everybody runs them to connect them and talk to other devices and run applications and all that good stuff. All right, so then I say, what user is running the majority of the processes on the system? Why might the networking errors be useful to see if you're troubleshooting a connection on another system? Well, let's look at these. So here's the VM stat. VM stat 1.5 will give me 5 iterations, 1 every second, of information on the system. It's a little hard to see because I've got the screen scrunched down, but it gives us a bunch of information about what's going on. And I do have a page that shows, let me pull it up here. I do have a Linux Systems Administration that talks about what VM stat is showing you. Where's my VM stat? That's IO stat, that's PID stat, that's MP stat. There's VM stat. So this is how VM stat works if you're not super familiar. Alright. Control by, what'd you say? Speaking of which, do you have any very lightweight monitoring solutions for web server running on edge system like Raspberry Pi? Very lightweight monitoring solution for web server. I actually just put something on a server today that was super lightweight that you might want to use. If you're talking control by just one server, let me show you guys something that came up today at work. I actually put this on a couple of our boxes. This is very, very lightweight, at least for what I did with it on the box. The boxes I have are kind of beefy, but this was pretty lightweight to me. Let's go back in here real quick. By the way, so R is the number of processes running on a kernel. The greater the CPU count is saturation. So if this is higher than the number of CPUs you have, it's high. Single node monitor there and such. Okay, perfect. Let me show you one. This is actually really good. We set this up earlier. Let me go back over here. There's a tool called apt install. Let's see if I don't know about Ubuntu, but I did it on Red Hat. Net. What the hell was that tool called? Hold on. I gotta get on my other system real quick. Ah, there it is. Let's see if we can get it over here. Net data. Let's see. Yep, it's there. All right. So it's net data, and watch what I can do with it. This is pretty cool. Because I set this up at work earlier today. While that's installing, in the lab it says read the manual for PS and what other information can you see, and then search your favorite browser, take an Internet Safari. What are the common releases of Linux OSs? What's a long-term support version of an OS, and what does it mean? So go find that stuff. All right, here, CD to etc net data, right? And in here, we've got this netdata.conf. There's a few things in here that I need to change. I don't want to bind it to only, if you leave the bind socket to IP 127.0.0.1, that's only going to work from this machine. Actually, you know, I'm going to leave that on so you can see. Watch this. So systemctl status netdata.conf. Netdata, right? And I see it running, but watch this. When I go ss-ntulp, then I'm going to see, I got to make that bigger, sorry. I'm going to see my net data. And make this smaller, sorry guys. Too much bullshits. Make that smaller too. Alright, where's my net data? See how it's only listening to 127.0.0.1 on port. That's that's a funny port number, but I'm going to take that bind off so now anybody can connect. So watch this. We're going to change this. We're going to take off the bind socket so it's going to listen to any. Whoops. Right, quit. I'm going to restart the net data service. And then I'm going to status it. Boom, it's there. I'm going to ss-ntulp it. And now that's listening to anybody. That's the any for IPv4. So now watch this. Because you wanted something lightweight that'll run right on that box. Watch this real quick. I go here. I say traffic ports. I've only got this one node right here. But I'm going to connect to it on port 19999. And I hit it. And it should drop me immediately into the net data for that box. So control byte, if you want something pretty lightweight, by the way, if that looks like Grafana to you, you're right, it's Grafana. And if you want to see like the disk information or the user, in fact, I thought about this after I did it today. I'm like, I'm probably going to make a lab with this. Look at all this cool little stuff. And it just keeps track of all the bullshit on your system, right? I can come up here, I can say disks, I can say memory, I can do the whole system overview. see how the system's doing. So, yeah, did you see the one thing I changed, Control Byte, for anybody that was watching, the only thing I had to change is, see right here, earlier it was bound to only the 127.0.0.1. Yeah, well, so you know, Control Byte, if you ever need me, just message me on Discord, right? Like, I'll help you with any of this stuff. But originally this was only bound to the local host, so nobody besides the local host was going to be able to see it. So we went in and we edited it, and we took off that bind, and by default then it'll work on all hosts. Any host can listen to it. But if you want to lock it down, you can lock it down to just your network. You can play with that, right? So anyways, the point is, here's our little dashboard, little system overview dashboard of, you know, little Ubuntu box with, you know, whatever's going on. That's the super simplest little dashboard. By the way, this dashboard is Grafana based. You say, how do you know that? Watch this. I can come over here and go to users, click on users, and when I look at users, one of the pieces of data, one of the users, so this is all the user information, CPU time of the users, whatever they're doing, and it's different on this one than it was on Red Hat, but this dashboard was called Grafana. It was the user, but also if you go here and you go to network interfaces, I mean, that's, when you look at network interfaces, that's fucking Grafana dashboard under the hood right there, right? It's the same thing. Have it running a container already and it's promising, just never heard of them before a few days ago. Good. Well, Control Byte, I only heard about this earlier today, and I set this up on a couple systems at work to monitor stuff, but it's only because I was asked to. But yeah, there's our everything. If you got a firewall on, yeah, there's a lot of good stuff going on here. Like, you could spend a lot of time in here, but one of those rules starts to become true over time as you look at this, is that too much information becomes noise. As a systems engineer, as a systems administrator, one of my goals, especially because I control tens of thousands of machines now. Some of my roles have changed recently. I used to always tell you guys thousands, now it's tens of thousands. And the most important thing is getting the precision of just the information. It's like the old police officer saying, just the facts, ma'am. Just give me the facts. I don't need all these other things. I need just the facts. And it's about being able to drill in and be as precise as you need to be on whatever systems you're on, right? Look at Ranger Dog down there. Still breathing. It's important. He got food a little while ago, so he's pretty happy. All right. So anyways, that's most of that lab, right? That's kind of what we did there. I show you some other stuff. I make you look at, one of the things I make you do on this is I say, is this system under heavy load? And I give you this command that says ps-ef, and it gives you all of the processes that are running on this box. It's got process ID 1 with a parent process ID of 0, and then it walks you down through all the process IDs of everything going on the server. Then this one right here, this little diddle, is just taking a ps-ef, so it's that command above. It's capturing all of standard out, and it's holding it. It's like that. It's that little. You guys ever see like a little otter when they give it stones, and it goes like this, and it holds all the little stones, and it's like this is mine. And it like hugs it, and it touches it. It touches it to make sure it's still there. That's what this does. This catches the output before it can come to the screen, and then I say filter it through this, and this little thing here is going to say, you know what? Each of these, and the field delimiter that I did not define by default is a space, but it's greedy. It wants all the spaces. So this becomes column 1, this becomes column 2, this becomes column 3, 4, 5, 6, 7, and 8. But actually some of these have a 9 and a 10. That's problematic. But anyways, we come over here, we just wanted 1. And I said, now take all those, sort them so they're all by each other. It'll be alphabetical. And then do a unique with a count. So slam them down into 1. So Damon had 1. Message had 5. Net data, this new one that's never been on this box before, has, it's Control Byte. It's no problem. That's what I'm here for, right? It's this or playing Brotato and other video games, right? So net data is here. Root is 115. That's a lot. Syslog systemd UUID. That's a lot. And this UID up here was actually just the header that I didn't bother stripping out, right? But really quickly, you can look at this box and go, that thing's even if I knew nothing else about these processes, which I don't from this box is basically damn asleep. I do my uptime again. This box is basically asleep. Not doing nothing. And then I have that other cool tool now, right? That I can put in here. And this other little cool tool is on port 19, right? And then I see, again, if I knew nothing else about this box, it's basically asleep. Not really much going on here, right? Yeah, Rob, it's pretty wild, crazy Friday. Although, my plan this week is probably to go through all the Linux stuff, all the Ansible stuff, do all those things out of the book. We'll walk through the book, do all the pieces, and then, if anybody wants the book, they can buy the book, but if not, they can just hang out with me and do the stuff. After that, it will be, what am I thinking here? I'm definitely going to I want to get this stuff set up in my lab where every time I get a fail to ban, it goes and it puts it on a geo dashboard, and I know how to do it. Actually, I have some of the stuff in my notes over here. I was looking up the format the other day, so I know it's got to be name, latitude, longitude, but maybe there's some other fields that I can add, so I'm going to play with that. But I'm going to get that pipeline all built this weekend, and I have a plan to kind of draw it out in here, and I will be kind of drawing it out. And once I have everything drawn out, it'll be a lot better. All right. So anyways, I think that's a pretty cool little dashboard thing. And that's super lightweight, so there you go. All right. We did all that stuff. Get this out of the way. And this was our observability. Tells us what's free and then how much swap in and swap out we have. In most systems, you want that to be 0. You don't want to be swapping. In any modern Linux in the last maybe 15 years, I have tried to keep my swap at 0. Because what is swap? Swap is writing out to a physical disk, typically. And even if it's a really fast physical disk, it's got to go across the bus. And that's, at best, 1/100th the speed of RAM. At best, a disk is 1/100th the speed of RAM. And that RAM is even 1/10 the speed of L1 and L2 cache against the CPU, right? So RAM is even undesirable. But the point is, you don't want any swap. And some systems, we actually trade some of our swap out and turn them into a device. And then, even if you do swap, you're just swapping against a RAM disk. We don't want you swapping at all in the Linux world, if we can avoid it. And then there's some other stuff that talks about the breakdown of CPU time. How much are the system uses here of the system, if the kernel is using the system time, that's kernel, is the user using some of the time here, and that's what all these different pieces are, right? And you might say, well, Scott, is that high or is that low, what you're looking at there? And I say, well, it's relative. This is one of these things where we want to, if I wanted to tell you if this system was high or low, I would go to the system and I would run vmstat1 like this, and every 1 second it would give me output. And then I would just watch it, and I'd be like, well, it's actually got a lot free, so I feel like that's pretty good. Okay, it's got a good amount free. But does this drop often? Does it spike down and come back up? Are there times throughout the day that, and then very quickly you would say, well, Scott, that's not very good for it. And I'd say, you're right. This is why we go do our visualization tools. Because then with our visualization tool, even that little simple one we just added with net data, I can see what's going on inside the system historically. And then I can start to see these things. And I can see, oh yeah, on Friday, when kids get out of school, they all jump on our game servers and spin up a bunch of video games. And that's the highest load. Did you guys know, like, Friday afternoon and Saturday nights are like the highest load average for a lot of game companies? That's when they have to spin up their servers in the cloud. So much so that that's actually a question that, well, that's an idea of a question that could be asked as a Solutions Architect Pro. If you don't believe me, go take the Solutions Architect Pro test. It's very similar. Yeah, like right now, people are out playing games. People are doing stuff. All right, fucking Ranger. Anyway, so let's look at this, and that's my digging deep. So that's a little bit about the lab. And then the next one's going to be about kernel and packages. So we'll do kernel and packages part next. Do we get to the end of this lab? Go watch PidStat, see what PidStat's doing. Telling us what kind of processes are running across the kernel at that slice of time. IOStat will show you the devices and the CPU, and they're not really being used much. And then the check, we go in and we do a little bit more networking, and we look at like the errors on the network. So here's all the interfaces, all the traffic. And then we can just look at the good traffic and the bad traffic here. So here's the good traffic up here, and here's the failure traffic. So here's good traffic. Here's here's good traffic. So anything here is good. Anything down here is failures and retransmits and shorter, like I think these are attempts, and you can go read what they all are. But the point is, these are your failure ones. You do not want any here, and these are your good ones. This is the good data: active, passive interface, and information that's flowing correctly. That's all fine. These are your errors and your runts and your other bullshit that can happen in a network, right? Different types of traffic that come in that the kernel can't handle, right? So we are looking at both TCP and errored TCP, right? And SAR. So if we man SAR, we should be able to see ETCP. There's ETCP, and then here's what all of those things mean, right? So sometimes you gotta, sometimes you gotta go spend some time looking at the stuff. Here's our transmit errors, bunch of stuff here. Lots of information, guys. I often tell you guys, I only dig into stuff like this when what I want doesn't work, or when some simple use case doesn't work. And then when the simple use case doesn't work, then I spend some time in here and I look for, you know, I go to man-sar and I go error, and I go look for, here's my transmit errors, there's my receive errors, there's my transmit carrier errors, and then here's my transmit frame alignment errors, and then there's my first in, first out overrun errors, so things aren't getting out of the queue as fast as they're coming in, buffer overruns on when I'm sending stuff and I can't get it through fast enough, and then here's some of those other errors that we were seeing, right? But the point is, I can look through real quick and find things. I don't have to memorize everything, guys, but I do have to be willing to read. If you're not willing to read, I don't know what to tell you, but it's probably the best thing I can tell you is don't be an engineer, because literally I read all day, every day. I mean, these thick glasses, right? Like, I mean, you got to read every day. That's like, you're gonna be reading all the time, unless you just know everything. And I've met a few people as engineers in my life that they just know everything, and they don't have to. Yeah, they don't have to read anything ever again. They just know it. But for the rest of us, we need to go look it up, right? And that's the way to do it. All right. So that lab's almost done. We spent some time in there. All right, I'm gonna play another round of Brotato. So here's the deal. I'm gonna give you guys another chance to bid. Leith, page not found. Leith, you should be able to. Oh shoot, I think that thing refreshed because I don't see my chat anymore over there. But I'm gonna get rid of this, and let's get rid of that. Unpin. And you guys can predict. Start a prediction. Will I beat round? I'm gonna say round 15 for this one of Brotato. So that's the prediction this time, guys. Don't get tricked. It's will I beat round 15 this time? So last time you guys saw me die, I think on 12. Oh yeah, that stupid freaking boss. Anyways, so now you get to see if I'm gonna beat 15. Also, again, this is still kind of choppy. I don't know if it's because I got the PowerPoint behind it or what. Take attack speed. Take an ugly tooth. Take that. I want this. Alright. Go to level 2. Oh. My guy shot at the one that was quite far away. Not the one that was right next to me. Oh well. Doesn't matter. You can take hits on this guy because he heals very fast. Alright. So you guys are deciding if you think you can go bet channel points, right? People love gambling. So bet your channel points if I'm going to beat round 15 this time. I didn't do round 20. I did round 15. So let's see. You guys can use your channel points, right? I mean, nobody's using channel points for nothing else. You might as well use them for something fun like that. Here's regeneration. That's good. Get another gun. Take that for harvesting. And nothing. Alright. Alright. Got to see if we can beat round 15. Then I'll let you guys decide if you think I'm going to beat round 20. Alright. Let you guys go make those decisions. I also don't have very many guns. Typically by level 3 you've got like 5 guns or something. So I'm very low on my guns right now. I'm getting I always talk about it like getting forced to the outside. I'm not getting nearly as many kills as I would like. So also, I added, for some of you guys that care, I added a few new, there you go, yeah, that one popped up. I added a few new of these little guys, and I think I have another one. Where's that one? Is that, no, I've had that one, had that one. Had that one. That's my new one. Who's heard me reference Saitama before? Who's Saitama? Who knows? Somebody here knows. Somebody's gonna admit to being a nerd. Somebody doesn't mind if people know that they know who Saitama is. Who is that? He's a hero for fun, but who knows who he is? Who knows what his other name is? How do most people outside of his universe know him? People in his universe think he's just an idiot, but outside of his universe, we know him as some other thing. One Punch Man, yep. One Punch Man. He's like, I've made a terrible mistake, and then he forgot that the sale was today and not next. He thought it was Friday, not Saturday. I love that show. It was a great. I love tongue-in-cheek humor. I love stuff that just doesn't really fit the kind of norm, and that show was full of it. That show was so. It never really broke the third wall, but it just did not give an F whether or not you wanted it to be serious or not. It was not a serious show. It was great. And the main conflict of the character is literally nobody could even make him like throw a serious punch. Even messing around, he never is even challenged once. So pretty good. Hope they do another season. The manga is pretty good. Seen the manga out through the King of the Monsters, so I've seen how that all works out, which is kind of the one that they threw up in season 2. If anybody cares, maybe you don't, but the point is, the reason I always reference this is when people ask me why I got on. I've been a college professor for a long time. I've been an engineer for a long time. Why did I get on and start streaming and doing this? It's because I just wanted to be a hero for fun, right? Like I wanted to tell people about system stuff. So I've always had that reference, but I've never made it into never made it onto my stream before now. So anyways, all right, let's get all that stuff. Nothing useful there, but I do have this. I also got a ghost, so the ghost gives me 3 hit points, but I start with only 1. So yeah. And Chicken, did you get raided the other day? Because I was hanging out and I went back in there and you had like 45 people watching you, and I was like, that's pretty good. That's a lot of people for Chicken. For in general, that's a good amount. So, hey, you were just playing your hack and slash type. Looked like a feudal Japan, but I could be wrong. I don't know what the game was. But those guys are super annoying because if you're shooting them, they shoot little slow-moving projectiles. But if you are doing melee, they didn't do anything. They just fly around and get their asses kicked. They don't do anything if you melee them. So they're kind of an annoying those little flying guys are super annoying. If you melee them, they don't do anything except float around. If you shoot them, they shoot those stupid little slow-moving balls everywhere that just kind of propagate the whole screen with a mess. Kind of annoying. Oh, one of your friends raided? Nice. Nice. I don't want any of that crap. Attack speed's fine. Damage is fine. We'll take another one of these. Take that. Take that. Take that. More of that. And more harvesting. We want harvesting high because that's useful. Wave 7 is the first wave where we start getting those weird little eggs. So we need to basically stay on the move all over the map looking for those eggs. I'm not even worried about picking things up. I'll go back and pick things up, but the most important thing is that I don't let the eggs pop because they just make your life harder for this level. And if you don't have enough DPS by the time you get to this level to take out the eggs, they'll overrun you on this level. It's kind of a hassle. But if you're doing like me, I'm doing fine. I've got plenty of damage. So I can let one, if you guys want to see one, I'll let one pop. It doesn't really matter. It doesn't matter with the last 10 seconds, but that's what they look like. And you'll see they have a lot more hit points than when I just beat the egg up. Which kind of makes sense. Alright, good. Don't want it. Ranged crit. These little bags, they give me materials when I pick up any crates, but they slow me down a little bit, but they're still really good. More hit points. Well, more regen. More damage, more damage. We'll do the ghost again. And we'll do ranged more damage. Alright, so this level is the first one where the big guys start showing up, the big chargers. They are not very dangerous as long as you don't let them gang up on you. This is also one of those levels, it's kind of like a DPS race. It tells you if you're building enough to do enough damage to go on. Because if you get overwhelmed on this level, you won't be making it very much farther. So we're doing good. We're keeping the screen clear. That's important. Alright. We're doing that. Do some more Linux here in a little bit. It's Friday afternoon, guys. I don't work super hard on my Friday afternoons, right? We just hang out. I do have more systems. I'm going to be building systems for work all weekend. So while I'm here doing stuff, I'm still building stuff over on the other screen. And I have a whole test environment that I got to finish standing up before my vacation starts next Friday. So I want to get it done. If I can get it done this weekend and get the test environment stood up with all the patches involved and all the updates to it, the reason that'll be super useful then is because there's two purposes to my patching in the test environment. One is to get my process down, because my process, after I do this, I have to do it to 12, you know, if my test environment is 4 generations of nodes across like 8 nodes, but 2, 2, 2, and 2, and it might be 1, 2, 2, and 2. Anyways, I think I only have one of the oldest generation of nodes, but that's not a big deal. There's not very many of them. I need to test my deployment method so that when we go to do it against all the nodes, it works. That's one thing I have to do. And the other thing I have to do is give that test environment, once it's built, to our other team. We've got a sister team that does all of the software stuff and interacting with the researchers on our cluster, and they will test it. They will make sure things work the way that they expect and all that kind of stuff. So that's something that I'm working on this weekend, even though I'm kind of hanging out. The wife's out of town, and I'm just kind of chilling around. This is a really good one. As you get your range damage higher, this keeps doing more and more damage, but anytime you kill a monster, he sends out a bullet that hits one of his buddies. So this can actually cause chain reactions that kill everything. The problem is it gives you minus 50 range, which is a huge range down. But as you get more and more range, that becomes more palatable in the system, like grabbing this and getting more range will make that better. Okay, wave 9, this one's going to suck again because I don't have nearly as much, I don't have any of that penetration again, so this is going to kind of be one of those like more rough levels than it should be, but I'll do fine. Alright. This level with this guy is like super easy if you have either the bandana or the strange bullet. That's what it's called, strange bullet. Because you out damage these things so bad that basically the screen just stays clear and you just collect loot the whole time. So as it is, I'm having to kind of dodge and run around a little more than normal. So what can you do? What can you do? You always want to go for trees because they can give you crates. Crates give you extra things. Armor's fine. Speed's good. Range damage good. Take that. Take that. Take that. And another gun. But I have to group my guns up to be able to take it. And then we'll take more harvesting and less armor because that'll give us more in between each round. So, alright. How'd that prediction come out? You guys thought I'd beat 15 rounds, huh? Nobody bet against me? Alright, well. I wonder what happens if it is no. Do the points just go to nobody? I don't know what happens there. All right. Here we go. Let's see how we do. It's 5 more levels, and then we'll see. We'll see how I do. Just a few more levels. You might notice my damage is way higher than it was the last time as far as that little extra bullet. It does a tremendous amount of just clearance on the screen. Always want that. You always want that extra clearing because this level really will pile up on you if you let it. All those, good. We don't want the beanie. We do want range damage. We do want more damage. And range damage, I guess. More damage. Another gun. Another gun. Tentacle will give us more crit and it can heal us. That's fine. And then another gun. And we've got our first boss. By the way, it's 3 bosses this run. It tells you, when you first go to the shop, it tells you. We'll take more regen too. And then let's see how we do. Let's see what boss this is. This is probably the worst boss I could have gotten on wave 11. Because this boss is called Mother. And you're going to see why here in about 2 seconds right now. What's going to happen is it's just going to start making a whole bunch of enemies. And it's very difficult now to get in there and actually do damage on the boss. It's good in some ways because I can just farm a lot of stuff, and I have a really good item for this boss, which is that little strange bullet, or that bullet, baby with a beard. However, it is yeah. You see, I'm not even getting close to damaging the boss because I have to stay around the outside. I can't go in the middle. So, well, that means I'm not going to get the. When you kill the bosses, you automatically get a red epic item. I'm not going to be able to get that one from this boss. So that's unfortunate, but that's not an ending. That's not a run ender or anything. It's just annoying. That boss is one of the most annoying ones. If I have a bandana that shoots through things, it kills them like immediately. Take more hit points. More damage. Take that. Take the gun. Take the gecko. Big arms. We want big arms for range. And then we want the medical gun because it'll give me another one of the epic guns. So we got 2 epic guns. That's the highest damage we can get. And we're almost to 15. So, also, yeah, we are on YouTube. I don't really care so much about the YouTube side, but you know, sometimes people wander in there and hang out. Not super often. Let's see if anybody's in there right now. Yeah, did you something? Narayan is on there, so hopefully this stuff's useful to you guys, even though we're just playing around right now. Yeah, YouTube's good for the archives, I guess. Yeah. Although I don't, you know, I really don't care as much about that. But all right, we'll do this. We'll get through wave 20 because I think I'm going to crush it, and then we'll move on. Also, we'll do. I've got some other games that are similar. I find most of the games I play are similar to Brotato, but I got some other games we could play too, and we do some gambling on them to see how we think I'm going to do. So, finish this up. There we go. Collecting all the loots. I want to kill that guy. Always kill that guy. It's good for the archives. Sometimes I shift on this guy. When I beat level 20, I go over for the dynamite. But we won't do that right now. So attack speed. We'll do harvesting. Oh, vigilante ring. This is huge. Plus 3% damage every level. So I've got 7 more levels, so that's huge. We'll take the medical gun, so now we've got more of those. We'll take more range and attack speed. And then we'll get ready for the gun again. Alright, we're doing pretty good. We're definitely going to beat level 15, but then we should be able to clear the bosses and beat the game. The thing about Brotato is I always play it into the upper levels, so then we can bet on whether or not you guys think I'll get to level 30 if I beat level 20. And I'll let you guys bet if you think I'm going to beat level 40. I've never beat level 50, just so you know. They changed this game up because it used to be you could min-max, and you could get this thing called a piggy bank, and you just save your money, and then the interest of it would climb so high that you could always just buy whatever you wanted. But they changed it so the piggy bank no longer gives you anything after level 20, and your harvesting, which could be really high, depreciates at 10% each level after wave 20. So that's a hassle. It's very hard to get very far after the later levels anymore. And then the enemies really scale out of control after level 30. So you're hitting them for 2,000 and I'm not even killing them with an individual hit, and it's kind of wild. So all right, that more damage. Don't need any of that stuff. Do want a better gun, more crit, take it, and a better gun and more range and range damage because we want to get our range up as high as we can, and then we go. All right, these guys are annoying. When you kill the little guy that's crawling there, he turns into 3 of these other guys, and what they do is they run to the back of the screen and just start shooting these little balls all over the place. They are super annoying. Those little balls just, I don't even think they're like actually at you. They just kind of go across the screen, and if you let there be maybe like 20 or 30 of them, it's just completely unmanageable to move anymore because there's too many of them everywhere. I don't want to say there's no rhyme or reason to it, but they just shoot across your path, and they will cause you a lot of problems the more of them that are there. You can already see how they're really annoying, but there'll be 50 of them on the screen at any given time, and that's a real hassle. I do think there's a calculation that they're doing where they're crossing my path, but I kind of move erratically, so I don't know that that's true. But I do suspect that's true, that those things are being thrown in front of my path. All right, this is one of my favorite things. It nullifies 1 hit of damage. It's huge, especially for this guy. So, silver bullet's really good, plus 25% damage against bosses and elites. So we want that. Although we won't have it in time for this next elite, which is kind of sad. And we want that stuff. Yep, because that'll stack on top of that one. All right, let's see what boss we got. This boss is one of the harder ones, but he's less hard on this level than he would have been on level 15. If you guys recall, on level 15, or on level 11 rather, he beat me because there were so many other guys. There we go. He's dead. That's a guaranteed red. Oh, by the way, yeah, we're gonna beat 15. So there we go. That's it. Then we just gotta beat level 18 and then 20. The final bosses are super easy if you've been playing this as long as I have. There's like literally no challenge to them. There's a pattern. You run the pattern and you win. Yeah, we'll do a new prediction after this wave, yeah. Actually, maybe we'll go do the lab and then we'll come back. And then, yeah, that'll be fun. That'll be good. Because most people probably don't really care about the game too much, but they want the Linux. And the Linux is important for me too, because Linux is good for you. Put hair on your chest and all that good stuff. Well, if you want that kind of stuff, I guess. Alright, Octopus. Take away some of my crit, which I like high crit, but it'll give me HP regen and lifesteal. I kind of want that. Lure is huge, because it'll give me more regen, and then 2 of those little loot goblins are going to come, so I want that. And we're going to take damage. And then luck is really good, but in the later levels it's better, so we'll take all this stuff. That's fine. Ah, sharp bullet. This is going to cause my bullets to pierce 1 additional time, but they're going to not be at 50%. They're going to only be at 30% additional damage, but it's still a tremendous upgrade in damage. You'll see how much damage I do as they're like hitting the guys behind. It's pretty big. Maybe with a beard. Now, see, that's doing 37 damage, and I'm going to have 2 bullets coming out of guys soon. So that's huge. Take that. All right. So we did 15. I'll do the prediction, which, whoops, choose the outcome. Yes, I did beat round 15. And then I'm going to set it for We'll do another one, and the prediction of this one will be, will I beat round 20 of Brotato? And you got 5 minutes to decide on that one for anybody that wants to do that prediction. All right, but before we get back to Brotato, let's do the next lab. So the next lab is going to be Linux kernel stuff, right? And we will go in here. Here's the lab link for people that want it. I'm not going to pin it. I think people that want to do it will do it, and people that don't want to do it will not do it. But there you go. And it's also, they're linked in the book, so people that use the book. And the task is to learn Linux commands, understand package management. That's what the goal is. Condition, given a bash prompt. That's bash. How well do I know? There's my shell. Didn't bash. Given a bash prompt, complete in the allotted 60-minute time. Oh, what else? How else might I know? I can do ID and see that I'm root. I can grep root from etc pass wd, and yeah, there's my root user has been bashed as his primary shell. There's this shell. Okay, good. All right. So the standard of this one is execute and understand the commands, understand the command output for kernels and packages. That's what we're going to do. So you're a new system administrator at a company. You've been tasked with finding out information about a set of servers that has very little to no documentation on it. Now, I mentioned this earlier, guys, but excuse me, that is a very common thing to have happen to you right there. Very common. I still have this happen right now. Like, you know, like I still get told, hey, Scott, will you go find out about those servers? Sure. I'll do the same thing that I'm doing right here. There's no difference. All right. You guys are predicting, right? Will I beat Brotato? Somebody's got to vote no. You guys aren't using those channel points for nothing else. I mean, nobody's doing ranger checks, right? Wait, is the other lab? Okay. I'm just making sure. All right. So check kernel and package info on the system, so we'll find out what's going on there. Echo the number of kernel versions that are stored on the system into root kernel. Everybody still believes me? No, somebody's definitely voting against me. What? All right. Well. Echo the number of kernel versions that are stored into root kernel, and then find, whoops, where'd it go? Find the specified version. Find specific versions of the software that the security team has been asking about, specifically the SSH server and client. This is a very common type of things that I might have to go do. And in Red Hat, it's different than it is if you're doing, Red Hat's way different than if you're doing Ubuntu, but it's still just a package manager and still just checking a database of all the packages on your system. That's all of it. You guys have more time to vote. Maybe I'll vote no. No, I'm not allowed to vote. You can't vote on a prediction you make. Also, Robodom, did you know you can start predictions? I don't know if you knew that, Robodom, but if I'm doing stuff, you have the power as a moderator to start predictions. You didn't know. But if you ever start a prediction, you can't predict in it. That's a rule. Yeah. Moderators can always start predictions. Yeah, you can play with the prediction stuff if you want. But these guys have to vote on this one. Give you way too much power. You can actually, I think you can actually say what the outcome of a prediction was too. I'm not sure though. All right. So let's go look at our solution. How do we see all of the information about this kernel? uname-a. But uname-a to me is almost too much. uname-r is just the right amount of information for me. That's typically what I want to see. And what is uname-r? That's my kernel version. That's what's going on inside of this Linux system. That's the kernel that I would look up if I had, you know, if I did a dmesg dmessage, and then I grepped for like eth, and that's my Ethernet adapter, right? This virt.io net is the module, and then I did like an ls mod for, right, virt.io net. There's my virt.io net, and it's net failover has that as a dependency. So if I tried to remove virt.io.net right now, it wouldn't work for me because it's a dependency. This net failover needs it, so I actually can't remove this kernel module. This is a kernel module. This is how you go. If you never use lsmod, it'll list all the modules in your kernel, right? lsmod, just like that. lsmod, word count -l. It would give me 76 kernel modules roughly. I don't want to go look at them, but that's how I would find what's going on. My Ethernet in my system. Look at my home lab, right? dmessage, grep-i eth. Here's all my Ethernet stuff. It's Zen NetFront. That's my Ethernet driver. Maybe I look for, if I know the interface name or something, ETH0 or ENO, if I have ENO, and then it'll tell me if I have one of those. So what's my thing? Yeah, it's ETH0, right? So ETH0, if it was in dmessage, it would be there. ls mod grep-i for maybe net. There's my net type stuff, and maybe ETH, if there's an Ethernet type stuff. But there's all my information, right? And Zen NetFront. Let's look for Zen. Yeah, there's my Zen NetFront. And if I pull that module out, my freaking network stops working, right? Like, there's all this stuff. You guys have a tremendous amount of power inside of Linux. You can do rm mod. You can do mod probe-e to remove things. You can also add things. You can add modules into a running kernel. Did you guys know that? Like, as you're adding certain hardware, HCA cards and stuff like that, sometimes you have to add the modules later, and then you have to set those kernel modules to come up as the box boots, so that the card will be accepted, and then the interface can come up, and then you can start the system. And that's all dependency chains. And these are things you have to know when you work in big high-performance compute systems, because it's not just about doing that on one system. It's about doing that on, 1,000 or 10,000 systems, and they all have to be the same. Everything has to work. We'll go troubleshoot things, of course, but for the most part, we want everything to just work, guys. We don't want to be troubleshooting. Also, Paul, wait a minute. Paul Hartle came by and resubscribed, and I didn't even see it. An hour ago. Paul, if you're still around, I apologize. I did not even see that, man. So I apologize. Yeah, Paul's one of my buddies. I haven't seen him in a while. I see stuff from him on Facebook and stuff, but I haven't seen him in person for a bit. Okay. You're still here? Yeah, I missed it. Sorry, but thanks for the resubscription. Thanks for the Prime. I always tell you guys, if you use Prime, you could use it anywhere, so I appreciate it if you use it here. That's always good. But, I tell people all the time, follows are free. Use your Prime where you want. I don't need to be anybody's favorite streamer. I just want to be somebody that kind of hangs out and shows you guys you can do this stuff. All right. So, real quick, here's the answer to that question of how many kernels we have. We did an ls boot VM, and the VM is the name of the VM kernel, the VM Linux, is the name of the kernel in our system. But, hold on a second. Why am I telling you to echo 1 into root kernel? That's the answer. Well, let's do the same command again, and let's put a -L on it, and it may demystify some things for you. The kernel, the default VM Linux kernel, points to this one. And the VM Linux.old also points to this one. And then the actual kernel is just sitting right there. But Paul's resub didn't show up. That's weird. I don't know. I just looked down and saw it, and I'm like, all right, Paul resub. That's good. Right here. Oh, you know what? It's very possible Paul did it and didn't hit the button, because if you don't hit the button, I don't think it does the alert. Like, if you don't say it in the channel, I don't think it shows up. I'm not 100% sure of that, but I'm pretty sure. Yeah, Paul, I think you get like a little option to hit a button, and if you don't do it, it doesn't do it. But Dymax78, hopefully this stuff's useful to you. Also, if 78 is your birth year, you're 3 years older than me. But it's not always somebody's birth year, but maybe he's the 78th person to pick that name. That's also very possible. All right. So we echoed 1 into root kernel because there's only one kernel here. And then I think I say over here, what version of the kernel are you on? Well, we saw that it's the 5.4.0-131. And I said, how many kernels do you have, and why are the other outputs not considered kernels? Well, because they're links to the one kernel. And approximately how many packages do you have on the system? So that, by the way, is always read in engineering as approximate. So if you've ever seen a tilde, and you've been like, why is that person doing a tilde before things? They're saying approximately. I don't have the real numbers, but approximately this. I looked out over the crowd, and approximately 60% of the people were looking at me. That's always what that means. In engineering, that is a common approximation thing. And I know not everybody knows that, so I say it. Because there was a day when I didn't know that. So I'm telling it to you guys so that you're not sitting in a meeting going, oh yeah, till day 25. That's exactly till day 20. No, they're saying approximately this many. That's always what that means. All right. But what version? So how many packages do we have? So we might run this dpackage-l with a word count, and it tells me 726. But then maybe I run that dpackage and I just say head, and I see the first 10 lines, and I realize that like the first 5 lines aren't even real. They're just sitting there. Or I could do NL, number line, and number line will count them all up for me. It's hard to see because of how squished down I have it. But there we go, and we can do a number line with a head. And I can see that the first 5 lines are just BS. They're not even real. And why that matters then is approximately how many versions are on the system. Well, should be something around 719-ish, right? And then if I go dpackage-l, so they say what version of SSH client and server are you running on the system? Why might this be important to know? So you run this. Well, we want to know the versions because versions are tied to CVEs, common vulnerabilities and exploits, right? And our CVEs, maybe if we're watching alerts and stuff like that and we're keeping track of all of our inventory, it'll let us know when there's vulnerabilities in our packages. And you say, well, how do you do that? Isn't there so many things over here in the CVSS database and isn't there so many things over here in the system? And I say, yeah, that's why there's a value add for vendors like Qualys and Tenable that will scan your systems as a privileged user and look at stuff and tell you what things have been popping up over in that CVSS and CVE database. By the way, that I've showed you guys this before. I talked about this last night. NIST CVE database. You can go look at all the vulnerabilities that are published, just like anybody else can. You do not even need an API key. However, with an API key, you can hit this. Look, here's all the information. Here's the statuses. Here's the workflow of it. You can read about that if you want. But hold on. Where's the actual API right here? Here's the database. I'll link this one to you guys here. Come on. It's like this thing's getting doxed or something. We'll go here. Here's the new 2.0 APIs. By the way, for the APIs, you do not need, better yet, Shark, how's it going? You guys do not need an API an API key to call this. Although you're rate limited if you don't have one. If you do have an API key, you're rate limited still, but your requests are just queued up and they will eventually come back. For that to work, you're going to have asynchronous calls and you're going to have to be able to wait and have your timeout set right. They talk about it all in here. I was reading it the other day. That's why I know. Getting doxed. Oh, maybe I was saying they're getting DOSed. DOSS or DOS. Yeah, DOSed. Anyway, so you guys can look at that if you want. Spend time in that. I think that stuff's valuable, right? And then so we finished that lab. So what's the client? OpenSSH client. Server is OpenSSH server, and the versioning you would want to know because that is something that security wants to know. That's something that you need to keep for your own baselining and knowing how much and how you're updating your system. So I said, look into you learning at Linux, or look at you learning Linux. You looked at the kernel and packages. And we got through that pretty quick. It only took us about 12 minutes even with me talking. But then you go and you dig deeper. And here's your digging deeper. In the enterprise, you may find yourself having to put in tickets for hardware or software implementations with different vendors. That's true. You may have that in your career, especially when you're first getting there. The first questions will always be asked are, what are the OS and kernel versions of the system? 100% of the time. That's the first question that will always be asked. So you need to know those two things off the bat. You might as well just grab those and throw those in any ticket you give to any vendor for any Linux or Unix style system ever. That is 100% the first thing they're going to ask. And you know why? Because they want to be able to say this. That's not us. Why are you sending Red Hat and Ubuntu system? And you go, oh, damn it. Or they want to say, hey, that version of Ubuntu is outside of support. And you go, But it's not. So then you go and show them. They probably won't run into that often. But one that will come up is you'll be trying to set up like an HBA, which is a hardware bus adapter, or an HCA, which is a a host card adapter for a system, and you'll be trying to install like an InfiniBand driver for this, and it won't work. And then they will be like, well, do you have our compatibility matrix? And you're like, I didn't even know what a compatibility matrix, I didn't even know what that is. And then what they do is they show you that for versions of the kernel that are 5.4.0-147 and earlier, you can't run this version of it. And you're like, I didn't even know that. I just went to the web page and grabbed the newest one. They're like, look at this. The version you have is the one that was supported for last year. So you can use that one, but soon, get your system running for sure, but soon you're going to want to update to the newer one. And that's what the standard thing that all support always says is you really need to update this to the new one. And you're like, I'm in a high performance compute system. We're locked in. We're not doing that for another year. Your other option then to get your stuff limping along is to use the older one. And then this is where defense in depth comes in, because there's definitely vulnerabilities. There's definitely problems with that were fixed out, and bugs and that kind of stuff. But you accept that to get a working system, and then you work forward as whatever. So very common type of thing. So it says right here, the first question that will always be asked is what OS and kernel version on system. It's probably in the ticketing system. So you just need to know how to get this, right? And if you say, you don't really do that much, I've literally done this 40 times today on servers, right? Like, even though I know my cluster pretty well, I still check just to make sure I'm on the right stuff. All right, what are the software versions you're using? Understand this will help you greatly supporting enterprise Linux. Yeah, you got to make sure you're on the right versions of stuff. We can loop over things in Ansible and pull individual things and then do decisions based on what version of the kernel is on a box, right? And we show that in the Ansible labs. I said go out to your favorite search browser and take an Internet Safari to read the types of Linux kernels that are available and which ones map to common OSs you have used. Why might knowing this be useful to you? So, CentOS 5. Still on 3.10. Did I say CentOS 5? CentOS 7. CentOS 7. Red Hat 6 was 2.6 for the kernel version. Now we're on 3.10. I have other stuff in my environment. I have stuff in my environment that is... So if we go to... What do I have here? I don't think OpenSUSE is still around. I think that one got blown away. Yeah, OpenSUSE was gone. I don't think, yeah, Alma Linux is gone too. Anyways, if I had some of these, I still have some of them. We'll go to Blue 3 real quick. I think Blue 3's up. Alright. That is Ubuntu 2204. And then if we do a uname-r, I think it's 5.15. That's newer than this, which is 5.4. But it makes sense because it's 2204. Right? The newer, this is a much newer version of Ubuntu. But it's on the same major version and a different minor version. Right? Alright, so we do that, we look at that, and that's that lab. Alright, so next one will be checking disk information. We'll do that one here in a little bit. But how'd you guys vote? Where'd our vote go? Anybody vote against me? Nobody voted against me. Alright, well, we're going to see if I can beat round 20. Alright, let's go. We're back to Brotatoing. And guys, I got a bunch of other games on here too that I can play. But Brotato was the first one. I figured I'd start with that. Get some Brotato in. Robedom, you haven't been saving all your money for a free ProLug shirt? We've been talking about it, guys. If any of you are out in California, probably next year, when the next Scale conference comes up, I'll see if they'll let me come out and talk. And if they will let me come out and talk, then we'll make up shirts for everybody that's going. The ProLug shirts with we'll have a little QR code on the front. If anybody clicks on it, if anybody takes a picture of it, it'll just send them into our Discord. Like, it won't even ask them, it'll just try to download Discord. It'll be pretty funny. That's actually what happens if you get a link to Discord. It just puts you right in Discord on the browser. Tries to get you to download the software. So, funny to me, but anyways, all right, Tyler, he's good in some cases, but not in this one. You get baby with a beard, get the acid for more. We want the baby geckos, we want the scar, and garbage, all garbage. All right, one more level and then we got a boss. By the way, when you guys see the blue in the top left, that means I haven't been hit yet for the level, because that's my little tardigrade or whatever the hell they're called. I don't know if it's tardigrade or tardigrade. That's gonna bug me. Tardigrade, yeah. Right, and that little guy, he, I get one free hit before it even starts taking my life. So, there, nullified. I got hit finally. So. All right, we'll see how we go here. I suspect we'll easily beat level 20, but we will. We'll see. There's always a chance something will get me before then, but it's less likely. The more of these little damage, these extra damage things that I get, that's less likely that I'll be taken out by anything. But because there's nothing that can spike this guy's damage that hard before he just runs away and heals. This guy heals really fast. I'll take dodge. Take dodge. Minigun's really good, but not on this guy. Alright, more medical guns. And we're almost maxed. Take the glass cannon for more damage. That for more damage. And it's good. Alright, we got a boss. What's our boss? This boss is one of the more challenging ones, but he's not really a problem. He's one of the first three. There were 3 bosses originally, and he's one of the ones that, like, I think I could beat the earliest of all the bosses. He was always not really a problem. So, and if it looked like I was just basically playing the Matador, that's pretty much it. You just move out of the way, and his little things are spaced out, and you just kill him. Pretty straightforward. Also, Robodom, if you're still around, you know what I had for lunch since the wife was gone? I haven't had Hungry Howie's pizza in a long time. I have pizza with jalapenos on it. Because my wife won't eat jalapenos or mushrooms, so when she's gone, I will eat both jalapenos and mushrooms. When she's gone, when she's out of town. She's actually buying a sweater. That's when she texted me earlier, and you guys were like, what's he doing on his phone? She, you never heard of Hungry Howie's? I think that's a pretty big chain, Robodom. Oh, I don't think it's as far over as California. By the way, this is the worst. This is the worst thing you can get out of a red item. That is a garbage item for me, because I don't have explosions. But anyways, we'll take range. We want to get rid of that. We'll take that. Take that. Take that. We do want the luck. We'll take the luck. And then there's the relic. So now, once I get this one, I no longer have to pick things up. Everything will just fly to me on the screen. So that's actually one of the better items in the game, because it's the lazy relic. You no longer have to go pick things up once you have that. Like literally everything on the screen will just fly to me. They have really good cheesy bread there, Robodom, and I'm actually kind of looking forward to it because I ate as much as I could for lunch, but now I get to have it cold for dinner. And I'm one of those guys. I like cold pizza. I do not like pizza. By the way, I have family members who love pizza that's been sitting out for 6 hours. I think that's absolutely abhorrent. But if it's been cold and put in the fridge, I love it. I do not love it if it's been sitting on the table for 6 hours. I absolutely abhor that. But I have family members who love that stuff. My wife's one of them. She'll eat stuff right off the counter like 6 hours later, and I'm like, there's no way that's healthy. like that dip has been out. Oh, sure, covered, but still just like it's warm now. No. So anyways, yeah, I will eat my pizza cold, but I won't eat it room temperature for 6 hours. I know I have brothers of mine, so I have 4 brothers. If you guys don't know, my brothers will eat pizza the next day that's been left out all night, and I will not do that. But I can't do it. Crit chance. Lazy relic. That relic's so fun because then you don't have to pick stuff up anymore. All right. So here's the strategy about the garbage. Here's the strategy about the bosses. When you fight on level 20, there is a new DLC out. Fisherman, we were looking at it earlier. I thought it was out. I thought the DLC was out today. Is it not? Update coming. Oh, it's update this summer. No, no, it's not out yet. I thought that said it was out. The announcement was April 10th. I see. I see. So, all right. Give me 1 second, guys. I need to grab some water bottles. I'm frying in here. They just advertised it nice. Hold on, guys. I'm getting water bottles. I'll be right back. I'm going to take a break real quick. We are also fishermen, by the way. We are also doing a little bit of actual Linux stuff. Don't think we're not doing some Linux stuff. We've done a few. I'll be right back. So here's the strategy on the bosses. Here's the strategy on the bosses, guys. All right, hold on a back. All right. So the bosses have Scott B. 1969. I was in the Army infantry. I was a expert in combat infantryman. So I kicked off Iraq in 2003. I came back at the end of 03 and became an engineer. So been engineering about 21 years. But yeah, I was a 11 Bravo. I was an infantryman. Here's how we're gonna fight this boss, guys. There's the boss when you're on level 5. There's 2 of them. One of them just shoots like these little mortars at you, and the easiest way to beat those is to spin, to run around him. The other guy has a Mario Brothers style little arm that's gonna go one way or the other, and the easiest way to beat that is also to spin. So really, all you do on this guy, on these guys, is get them together and spin around them. That's really all it is. So. Let's see if we can beat him. So, where are the bosses? There's the first one. That's the guy shooting mortars. This is the guy that's going to spin. So now all we do is we just kind of follow him around like this. He's already almost dead. Then he's going to run away. He's going to be like, oh, I'm scared. I'm going to run away. And then now he does this little thing that slows you down because that makes his buddy able to hurt you more. But then you just kick his ass. And then you kick his ass. You guys ever see the... Rush Hour 2, he's like, first I'm going to kick your ass, then I'm going to kick your ass. That's basically what we just did to him. Airplane mechanic in the U.S. Air Force. Nice. Nice, nice, nice. Well, everybody's welcomed here. We are hanging out. We're doing Linux, but we're also playing video games because it's Friday. We don't take Fridays super seriously. We do have a Discord. We also don't take the Discord super seriously, but that's a place to kind of sit around and talk with other engineers, hang out, say, hey, you know, I'm working on these kind of certs. I'm working on this type of stuff. You know, what do you guys think? There's a lot of like engineering talk around like Ansible and other tools and stuff like that are out there. But yeah, airplane mechanics. Yeah, being out on the line sounds fun. Yeah. VA. I actually meant to ask you the other day. Is the VA from like Veterans Affairs or not? And the reason I ask is I joke around often about the VA. I have buddies that are working for the VA still. And I always joke around about the VA gives you a second chance to die for your country. So, yeah, Fisherman's very welcoming of everybody except for Windows admins. And by the way, we're doing my labs today for the most part, right? Here's my labs. I'll link these up for you guys over on the YouTube side and on the Twitch side. There you go. Oh, nothing to do with the VA. Okay, good. But I do make fun of the VA a lot because of that. But Fisherman's also got labs out here, guys, that I think you should do. So if you do our little labs command, you'll see his stuff. But now, so we've beaten that level. So here's where this will get fun. If I've beaten, let's go to our prediction. Choose the outcome. Yes, I beat round 20, right? Oh, I haven't actually beat round 20 yet. Hold on. I gotta actually beat the. Oh, I did beat it. Okay, good. Let's predict. This one starts getting much harder. Will I beat round 30? So the game starts getting exponentially harder after round 30. Up to round 30, it's still pretty linear. So I've got a decent chance right now of beating level 30. But you guys can vote and see what you think. By the way, all mini bosses, there's now 2 of them, and the game's about to start getting harder. So you guys have 5 minutes there to vote on that, and I'll do the first. Actually, let's see. What's going on here? Hack the Planet. Hey, how's it going? We are doing Linux, but we're also messing around today, so it's not a super serious day, and we are hanging out and doing that stuff. What have you guys been doing? Hack the Planet. Were you guys doing all the Linux? Were you guys doing all the hacking? Yep. Shout out given over there. Always important. Follows are free, guys. You might find your favorite streamer. Hack the Planet. I just beat level 20, and now we have a prediction of if I'm going to beat level 30. So people can vote. I am the doctor. Oh, extra stomach. So guys, here's what the extra stomach does. You can get up to 10 more hit points per wave by keeping your life high and going and grabbing stuff. You were streaming Turing complete. Nice. Scope. I always take scopes. And we're going to take range on this one. We'll take the missile. We are not maxed on our guns yet. We're real close though. And I do like the clover. And I don't want any of that. I do want that. I will want that. And we'll take bait because we've got a free round. Level 21 doesn't have bosses. All bosses are doubled now, so it's going to be a lot harder. We'll take the bait, and then we'll take the damage for the next one. We also would like more of these. Only having, when you get here and you only have one of the vigilante rings, I only have one. Typically, if I'm going to go really far, I need like 2 or 3 by this point. But I didn't build this guy for luck, so I don't have nearly as much luck as I normally do. So there's some family stuff going on. Okay, people are texting me. Don't care. Wife's out of town. I can do whatever I want. All right, so we're gonna beat up these guys. Now I do want to collect things. Although we got the relic, so lazy relic means everything's free. But now every time I grab one of these, my hit points are going to go up. So at least the first 10 things I grab will give me extra hit points. By the way, when you get to like in the 30s, every monster will one-shot you if you don't have at least 300 hit points. And that's even with high armor. And sometimes, if I can get an anvil, I will have like, plus 60 or 70 armor by that point. I haven't been building on that, so I'm probably not going to have that on this guy. But sometimes when I get up there, I'll have that many. Alright, so my goal is to beat level 30. Alright. Still getting extra hit points. You guys see I just hit 100. 101, in fact. I don't have to grab anything else because, all the things just fly to me. But I do grab these until I hit 100, or until I get 10, which I have for the level, so now I can just stand still. So there we go. Pocket Factory, there's a reason. So you might say, Scott, do you really want the Pocket Factory? Do you care about engineering? Do you care about spawning a turret? The answer is no, but when you see the word unique, the reason you sometimes take things is so they don't show up in the shop anymore. It's unique. I can't hold 2 of them, so I never have to look at it again. We'll take luck. We'll take luck. We'll take damage. And then we'll get more bunnies, because the bunnies let you roll for free. That's always good. Yeah, Rodon, did you not know that? The wife is away until Sunday, so I'm just hanging out. I'm just going to be doing... And I don't have college. My college that I teach at, I don't start again until Monday, so I'm kind of like on a free weekend right now. Although I am doing work stuff on my other computer. Actually, I need to do some more stuff here in a little bit, but we'll do that around this mess around. All right. Remember I told you guys this is going to start getting hard because... Oh, you guys are still predicting, right? Yes. No, yes. This is hard for me to get to level 20 or 30 because here's the thing. Right here, all of these are doubled now. So there's going to be 2 bosses this time. Twisted Seed, I am on call, but I'm also building stuff. And when I go into build mode, I don't really care about time anymore. I mean, I am a salaried employee, but I'm also kind of hourly because I'm a contractor. It's weird. But the point is, I'll be working all weekend. Yeah. College just admin class this week, so I've got some downtime. Nice. Yeah, Hack the Planet. I have a little bit of time this week off, and then I start back up. And I was telling the guys earlier, I need to look at my college stuff because my classes at DeVry, I haven't looked in some of my stuff for a while, so I need to see, like, do I have all my stuff updated? I might need to update some of this a little bit, right? So it's it's got good starting information, but it doesn't have all my information in it. So I do have some stuff to update, and then I have other classes. I actually have a new class this quarter that I got to build. So, well, when I say build, everything's in the class, but I like to add, I don't know, I wouldn't say pizzazz. I like to add a little bit of color around the systems we're talking about. So like the one class is an Azure class. It's a cloud class. And I have a whole bunch of AWS certs and only one Azure cert, which is funny. But I don't want to just show them like, okay, this is you setting up a system for the first time and doing a network. That's all the lab stuff. I want to show them the blogs and the cybersecurity stuff, and there's all these different things that they can go spend time with. So I try to show my students that stuff because, like, that's what the guys do out in the industry, right? That's what we do. We try to keep our skills sharp by going and hitting all these different things. So all right, we're gonna fight two guys this time. Let's see if we can beat two of them. Who are they? All right, this guy you spin on. So you spin on this guy. And then the mother, remember the mother was the one that jumps all those monsters out everywhere. The mother's a problem, but not not when I have this weapon, or not when I have the rounds that penetrate. So there we go. And then now we get more hit points because we get maximum hit points. There we go. Again, I didn't really care about the turrets because it doesn't do that much damage. I just didn't want the unique item to keep popping up. Anytime you can get rid of unique items, you should. When you go into the deeper levels, because it's just one more thing you don't have to get rid of when you roll. So that's important. And yeah, you guys are still. I think you guys all finished your gambling. So let's see if we can get past level 30, and then we'll bet on level 40. And I've only beat level 40 like 4 times. This is the end mode of. This is like the endless mode at the end of. I'll take this because harvesting doesn't matter nearly as much anymore. And I'll take speed, and then head injury, and this. This one's a trap. This is really good if you're only going to level 20. This is terrible if you're going past level 20. This one, what it does is it keeps higher level items, these red items that you get, they will start to take away your regeneration and you'll go negative, which this doctor is really based on his ability to regenerate. So I can't get that gun, damn it. I do want that, and we have enough luck that the baby elephants and the masks are going to start being important because they'll do extra damage. That medical gun would be fine if I needed it, but I don't, so let's save our money for the next level. Alright, and again, I don't have to collect items anymore because they all just fly to me, so all I'm doing is dodging enemies now and picking up these little things to get extra hit points, extra max hit points. Alright. By the way, you guys probably noticed I'm not normally in the just chatting channel, but I did today so that I didn't have to, like, I didn't want to change out of, like, science and technology and then gaming and then back to science, so I just said, ah, fuck it, I'm chatting today. So, I don't normally do that. In fact, I think I've only been in that channel maybe, like, twice ever in, like, all my years of streaming. But we're just messing around today, guys. Anyways, when I'm on Fridays, you guys know that I just mess around anyways, but I do have some serious things to do. And we're doing those serious things right now, which is beating Brotato again. Which, I don't know, I've probably beaten Brotato like a few hundred times, you know. I probably have more hours in this game than most anybody. This is also a trap. This one is it caps out your max hit points. This is perfectly fine if you're near the end of the game and not going to the higher levels, but it's not good now. Blindfold is good, it's crit and dodge. And I'm going to take... For this guy, I'm going to take luck because I want my luck a little higher. Recycling is good because everything that you recycle gets more, so this is actually pretty good. And it's unique. Remember I said we want to get unique stuff out of the way? I also, I don't want stone skin right now, but if I had gotten if I get an anvil, then I would want stone skin, but we're not going to buy it yet. Take more regen, less regen. Take more luck. And... we'll get this because we can get the tentacles out of the way and they give us more crit, and we'll also take this for more crit too, and attack speed and range. It's all good. Alright. Yeah, just killing enemies, killing bosses again soon. By the way, when you get to level 30, it's those 2 bosses again and one of those mini bosses. So there's that. And then also something just happened in one of my email windows, so I gotta go check that out. By the way, I had a pretty good interview today. Some of you guys know I work for a company called Redline, and they contract me to a bunch of different high performance compute. Sometimes I'm on contracts just for little projects. Most of the time, I get planted full time with somebody, and then I do like some other percentage with other people if they need, and then do project work and stuff like that. But my contract with the company I've been with for the last year, which is a big college, it's probably coming to an end. They can't. They're not going to be able to get funding to have me on for another year. I've helped them build their team. I've documented all their stuff. It's been good, really good relationship. In fact, I got asked by NASA today, "Why are you leaving?" And I go, "The contract's up." Like they want to keep me. They tried to hire me. They actually asked Redline if they could hire me directly, which would have been funny. Most of the time, it doesn't work with contracts, but they actually wanted to keep me. But we ended up hiring everybody, got the team fully staffed. I'll probably be moving off soon and going to some of these other things, but they're trying to get me in these other things. So it was funny, earlier I was wearing a collared shirt and stuff, and just going and talking with NASA about this big, I think we have 18,000 nodes on that cluster. And by the way, guys, that doesn't scare me any. I've told you guys this, and we've talked about it. When we do Ansible, whether I'm hitting 2 nodes or I'm hitting 18,000, it's all about if I've got my inventories right. If my inventories are right, I'll hit the button. I don't care, because I know that the thing should work, and I understand kind of what's going on. This is unique. It'll give me less enemies and less damage. I'll take it just to get rid of it, just to get out of there. I can finish all my guns epic, so that's good. And I can take this, and I'll get that one on the next one. And we want higher piercing damage, because our piercing, which is over here in secondary, piercing tends to be pretty low. But where's piercing damage? Yeah, but we can get it a little higher, so then the damage that goes through goes up higher. You're scared with Ansible? Twisted Seed, as long as you know your inventories are good, you're good. Plus, there's all kinds of tools to test what you're going to hit before you ever hit it, to look at what's going on and all that kind of stuff. Yeah, when you're highly confident in your link skills, that's true. That's true. All right, now we're gonna fight another 2 bosses again. So this is scary, and they're not difficult bosses. This one, so the one is trying to lay a bunch of eggs and being annoying, and the other one is trying to make a bunch of little aliens all over on the screen. So they're all problematic, but they're not the worst things ever. Let's kill that guy off. Oops. We'll get rid of him. Then we're gonna kill this one, and this one's gonna start making a bunch of babies soon, but they're not too problematic because I've got the penetration on my weapons. Now, once we clean the screen up, I start going and picking up my little extra hit points. So I want to get 10 extra hit points per level, right? That's important when you're going into the deeper levels, because I can almost be one-shot, even at 140. I have really low armor, so I don't have any addition. I take additional damage, in fact. So I really need to keep my hit points as high as possible. I need to get an anvil. The anvil's the best item for me right now, because what the anvil will do is it'll give you 2 armor per level if it doesn't have a gun to update. If it has a gun to update, it'll update my gun every level. Twisted Seed, you're worried that it might fail halfway through the run book. Well, that's the thing, is you have to test your stuff. You have to make sure that it's good. You have to understand where things can fail, and then make sure that you do that. But yeah, Twisted, you've been around enough. You've seen me do Ansible, and all those labs are there for you to go. And by the way, this is one of the things. Fail in those labs. Go do the labs and break stuff and see what happens. Because what does it cost you? It costs you free 99, because it doesn't cost shit to do. Like, Killer Coda literally doesn't cost you anything. Yeah, it literally, like, they don't even bug me. Like, Killer Coda, like, I tell you guys, like, they don't even send me, like, emails or anything. Like I don't even get, like, anything annoying for being part of their stuff. So go in there and fail all over their stuff, and then you'll get the confidence to do it in a real lab environment, right? All right, Barricade. Look, the Barricade, I'm getting 35% more because I bought that thing earlier. So I do like the propeller hat because I want more luck, so that's good. Medical Kit, this will give me +2 HP regen every 5 seconds until the end of the wave. This is pretty good, plus I just got the luck, so I don't mind using it. And then we'll take range. And none of that stuff, but I do want that. And I don't need baby geckos anymore because I have the relic. but they still give me more range. So I just buy them. Plus, once you have 5, they don't show up in the inventory anymore. I'm worried because it's database jobs. I'll do more Ansible stuff this week. Twisted Seed, you can, if you do any of that stuff and then anything comes up or anything's weird, let me know and we'll go look at it. You know, I have literally all weekend. In fact, what I was gonna do tomorrow, when I'm online tomorrow, I'm gonna be down in the Discord in one of the channels. So if people want to talk or whatever, we'll just hang out down there. I could even hop in there now, but we've done that before on stream, very rarely. But if people want to go down there and hang out and talk and whatever, we could do stuff down there, kind of like we do our normal on our Saturday. So we run a Linux group, the professional Linux user group. On Saturdays we have meetings, and I always try to get people to come and talk to the group. We don't have a boss this round, so we're going to take bait. Bait gives you plus 8% damage, but for the next round you have these little jerks that show up that are kind of hard, but I'm going to kill them all really easy. We'll take more attack speed and range damage, but a little less armor, that's fine. And we'll take even less armor, that's fine. And I probably want the range damage and attack speed. And since I'm getting extra hit points, I'll do that. And I want the flag because it gives me less enemies. So I'm just going to take that as well. I'll get that on the next round. So, alright, kill everything. Here's those little jerks I was talking about. They charge you, kind of like that one boss did, but I killed them all so fast it didn't matter. Alright, a good chance I'm going to beat level 20 or level 30 by the way. So for people that did vote. We're getting into the later levels here. It starts getting a little harder. But we do want to grab at least 10 items before the end of the round so that I can get 10 extra hit points. Because honestly, by like level 30, I will be one-shotted. Anything will kill me one hit if I don't have at least 300 hit points, because I don't have enough armor. And that's a problem, but we go with what we have, right? We don't go when we're ready, we go when we're ready enough. That was Colonel Graff from the book Ender's Game, also the movie, right? Colonel Graff was the guy who trained Ender. Also, I think it was Robert Redford? I forget who it was. Hey, how's it going, Quartz One? Don't want that. Don't want that. I do want that. And we'll take all of these things. And then... Alright, good things. We'll take this because this is going to give us more range and crit. Less armor, though. This is one of the best things. It gives you 2 luck for every crit you have. That's critical because then our luck will be really high and we'll do more damage. And we don't really care about the diploma because we're not really playing this game for engineering right now. And I do want those and I do want those, so we'll save everything. But we got to beat these two bosses on this level. So what's our mini bosses? These are, I think these are 2 of the easiest ones. This guy, you just got to stay within a circle until he goes to half life, and then all you got to do is just stay away from him. He'll try to pressure you a little bit, but he's really not a big deal. That other guy, he got all his little eggs off, which is a problem. I probably should have been paying attention a little more to them. But oh, I might die. God damn it. I wasn't healing fast enough. All right. Anyways, I did not do what I was gonna do. I did not make it, guys. All right. How do we vote on that? Hold on. So I did not choose the outcome. I did not beat round 30 of Brotato. Sorry, guys. It's terrible. All right. Let's go do the next lab. So the next lab is checking disk and mount information. So here's the lab. I'll pin it for you guys over here on the... Actually, I haven't even been bothering pinning them. I'm just hitting the buttons and putting it in there for you guys. So it'll be over... Oh, there we go. So it's on the YouTube side. It's on the Twitch side. YouTube, people care about persistence, I guess. So I'll just... I've been streaming on YouTube the last few days. So this one has some simple things. The task condition standards. The task is examine Linux disk commands. Understand how to find file system versions on local disks. Right? Understand what's going on. Look at a system that you've never been on and figure it out. Right? That's going to be our thing. Our condition will be given a bash prompt, complete in the allotted 60-minute time. You have 60 minutes. You can pay them for more, but Killer Code is free without it. And I've been using them long enough to know that they're not gonna charge you more unless you ask them to, so that's fine. Execute and understand the commands. Understand the command output of the given system. That's our standard. Okay. Gotta have an alternate now that TikTok's about to be banned. Yeah. All right. So we come over here and I say, you are a new system administrator at a company. That's how all of these start, right? You've been tasked with finding out information about a set of servers that has little or no documentation to it. This happens all the time. Check physical disk information. Echo the number of physical disks that you have into root disks. Echo the number of partitions that are on the disks or disk into root partitions. So, how might I do that? Well, I know that there's this thing called df-h, and that'll tell me some things. That'll tell me what's mounted and how much usage there is. But maybe I have lsblk. That'll tell me a little bit. It'll list the block devices on the system. And I have block ID, and that'll tell me some stuff. And I go, maybe from all this I can figure out what's going on the system. I also have a mount command. It'll tell me what's going on. I can cat etc fs tab and see how systems were mounted when the system came up. So I got a lot of stuff. I got a lot of things I can look at. But let's see what the solution to the lab says. The solution to the lab will walk us through a set of commands that I want you to kind of understand as a systems administrator, system engineer, right? So we come down here and I say, check the disk information and count all the partitions up. So we do an fdisk-l, and then we grep down for just the virtual disks. On some systems, on some really old systems, there would be HDA. On more modern systems, you're going to see SDA. And on some systems, like in my home lab, if I just am on my home lab, XDDA, right? And there's whatever the initial letters are, and then you've got the letter that determines the numbering of the disk. This is a letter, but it is ordinal. It is a counting letter, right? So the first disk is A. So in this system, I have a VDA disk. If I had a second disk, it would be VDB. If I had a third disk, it would be VDC, and it would go on and on and on. When we hit Z, it would go to AA. AB, AC, AD, and it would count like that, if you're wondering. And when I say count, it truly is counting. It's ordinal. It's in order, right? So VDA1 is a partition of VDA. VDA14 is a partition of VDA. And VDA15 is a partition of VDA. So this has one disk, dev VDA, and then it has 3 partitions to that disk. That's what I'm seeing from this information. But we also have ls block, which will tell us something similar. Here's our block device of a disk, and then here is our 3 different partitions of that disk that we carved up. Here's block ID, which tells us information about those blocks. Dev VDA1 has some information on it here about a label, a UUID. These are ways to identify it to the operating system that I'm on, right? Dev 15 has some labels and some partition, UUID, and that kind of stuff. And then we've got these dev loops. These are just RAM disk things with squash FS that have been started. Not super useful to us here because they're block devices, but they are not physical or virtual disks. They're not disks at all. They're just slots in RAM that are doing whatever they're doing with squash FS. So the answer here is there's one disk and there's 3 partitions. We see that here. We see that up here. Right? We see that. We can understand that looking at a system. If I asked you the same thing on my system and I showed you this, what the hell? I was like, what the hell box am I in? Hold on a second. LSBLK and block ID. How many disks have I added to this poor box? This box has been around for a while. Can anybody tell me how many disks there are right there? We have disks and partitions, and then we also have other things in logical volume management. But does anybody know how many disks I have right here? All right. Staying hydrated, guys. Very important. Not part of it, but it's very important. Also, got a new one of these. If anybody asks me why I'm on here streaming, I'm just a guy who's a hero for fun, right? All right. And I have this one. I can answer that for money. That one's my favorite. But I also love this one. Doing it live. Doing it live. Just getting pissed off and yelling at everybody. I get this one, right? Homer just holding on to the can, being dumb. This is my normal. This is how I normally act all the time. Where I'm normally at. What's the first one? Oh, that first one's just whether or not I'm there, right? All right. We check all that stuff. Boom, validation successful. The next one says check the file system type and mount points. So now we know what's going on. We have 1 disk and 3 partitions. But what's on those partitions? How would I mount those if I wanted to get any of these mounted onto the system? Well, I need to know what type of file system's on them before I can mount them. And if they have nothing because I just carved them up, I have to give them a file system. I actually have to make a file system for them. So I said echo the file system type of the root partition into root fs type, and echo the name of the file that defines the mount points into root mount info. So the name of the file that defines all the mount points, you need to know that. And then also what's the root partition. Over here, I say of these disk commands, which of them seems to show you the most important information and why? So which of these do you think has interesting information, right? That's something for you to think about. The YouTube playback works better on your LTE phone. Nice. Nice, nice. What type of files, what are the types of names that are given to the partitions? Well, A is the disk, and then their numbers after the counting letters, right? What is the file system type of that partition? So now we got to look down. Here in the block ID, we see for devvda1, which is the root file system, we are using ext4 for our partition. The 2 most common types of partitions you're going to see currently in the Linux world are going to be, in professional Linux world, are going to be ext4 and xfs. Those are going to be the 2 big ones. You may run into some btrfs, btrfs. Probably not. You may run into, definitely going to run into NFS in some places depending on what you're doing. You might run into, in the cloud, some EFS, which is like an elastic file service, which is literally just NFS over in the cloud space, right, inside your VPCs and stuff. But anyways, let's look at this. So I say mount grep VDA. Oh, the hell? Yeah, here we go. Mount grep VDA. And right here, I can see when I did mount and looked for VDA, here's VDA1, and it's mounted on /, and the type is ext4. That would also be very similar to if I did a block ID on it, and I see that it's type ext4. So even if something's not mounted on your system, if somebody wants you to tell them what type of file system is on a partition, you can do it. Block ID and the name of the partition. Not impossible to figure these things out, right? So I'm going to go throw that in there as the root fs type. And then I go to cat etcfs tab, and cat etcfs tab tells me how those were mounted. So the / the root partition, was mounted from this label cloud img root fs. Well, that label maps, cloud img root fs, maps back to devvda1. Devvda1 is right here, mounted on root of the file system. So there's all these different things. You might say, why did people do that? Somebody in some room, some mailing list probably of Ubuntu years back, decided that in their etcfs tab they were going to use label. You will find often that people use UUID. That's probably the most common one. But you could just do, if you wanted to, you could literally just use devvda1. So if I cat etcfs tab, right here, instead of doing all of this noise, I could have literally just put /dev/vda1, well, or whoever set up these labs. But because some decision was made that that's how it was going to be come up and be read, that's all there. So where are those mappings at? They're here. Obviously, we can see them here. But where are those mappings actually defined inside of the Linux OS? Well, we can go look at that. If we do an ls-l on div disk by label, we would find that the cloud img root fs, which is right here, right? Cloud img root fs, points to the parent of my parent VDA1. So if I were to cd to dev disk by label, and I were to go to my parent of my parent, and ls in here, I should see a VDA1 right there. Right? So I went to the parent of my parent, parent. That took me 2 up, if you want to think of it that way. It's the parent of my parent. And then in here, I saw dev VDA1. Well, I'm in dev already. VDA1. If you want to see all of these mappings, I have a little thing that'll loop over them for you and show you all the mappings. And we could have done it easier ways, sure. But if we want to see type by label, there's our label. If we wanted to see the type by part UUID, there's the part UUID for VDA1. Here's the path, PCI. This is the actual PCI path that points to dev VDA1. And then here is the by UUID. There's a UUID for it as well. All of those can be found ls block dev VDA1. But that's block ID. All those things are mapped right there in the file system. There's nothing in Linux that you can't go figure out where it is if somebody shows it to you the first time. So when I started on this box, I didn't know any of this stuff. I didn't have any idea where any of this stuff was. But and then we went through and we ran all these commands and we found where everything was. As a sysadmin, how much are you involved in the change management process? Every change I try to make, Robodom, requires a change. Everything I have to change requires a change. Everything. So, very involved. I'd say takes, if you're bad at it, like 30% of your time, and if you're good at it, like 15% of your time. But you will use change management all the time. Or you will just be like Yosemite Sam with your 2 pistols in the air going pow, 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 because it's the wild, wild west and you do whatever the hell you want. But I don't think you'll stay with most organizations very long if you keep doing that. Or you'll just get slapped on the hands a whole bunch because people don't like when you're changing systems. You won't like when you change systems when you're the one who has to go fix them later, right? So yeah, sysadmins are always involved with change management. It's not just engineers going and trying to build things. In fact, I would argue on projects in engineering, I get to deal with it less because I just get to build shit new, and then it gets codified into a system that is now protected by change management, and I don't have to do anything. Especially, yeah, Robodom, I build all the environments. I am the one who builds the ship until it gets pushed off into the channel, and then when it's in the channel, change management starts. Once it's pushed off of the docks, you know how they launched the ships the first time. I'm the guy building the ships often, so my thing is, it's like I'm like Judge Dredd going, I am the law, right? Judge Dredd, I am the law. The love? No, I didn't say the love. Well, I'm gonna snip that. That's funny. I am the love. I'm gonna send that to my wife later. She's gonna be like, what the hell? All right. Then I say, if you look up the CIS benchmarks for RHEL 8, you'll notice that one of the first tasks is hardening a system deals with setting up different partitions. Why might partitioning of a system be so important to security? Why might you not want to partition a system like that in the industry? I am the law. I didn't like the newer one, by the way, guys. The one that was a few years back, probably like 10 years ago now. I wasn't as big a fan of that. Where they like shoot you up with the stuff and then throw you off, and like time slows down, so it takes you like 10 years in your mind to hit the bottom. I thought that was kind of silly. And also, I used to joke around, like, I think that came out in like 2012. Yeah, the one with Carl Urban. I told people that wasn't even the best movie that year that involved a police raid of a tower controlled by a kingpin where they had to fight their way to the top. And you say, what was the other one that year? The Raid. The Raid was immensely better than that fucking movie. The Raid, the first Raid movie was like probably one of the best fight scene movies I've ever seen, right? If you guys remember The Raid, that was a fantastic movie, and I think they came out the same year. So I used to tell people, yeah, like, because they're very similar plots. If you guys watch both of them in the same weekend and tell me they're not very similar plots. I realize they're coming from different perspectives, but I'm saying it's very similar plots. And I used to joke around about how The Raid was the better movie in every way. All right. Anyway, so now that we've done some stuff and looked at the disks, now we can play with the disks. We have the power to check what's going on inside of the system. So I asked some questions here. Why is it important to know about the size partition as well as the inode count? How do you check each of them? So we're going to look at that now. Check the disk size and usage. Find the size of the partition / put that in a file called root size. Place a single file that is 3... Did I really put 3G? Oh, Control Byte, are you still here? Oh, Control Byte, why didn't you protect me from myself? 3 gigs, guys. Sorry. That should be 3G capital B, right? God, somebody should have protected me from myself there. I can't believe that lab's been sitting there for like a year and a half like that. Anyways, all right, calm down. Place 10,000 files in a directory. There'll be file 1 through whatever, all right? So here's our solution. The little detail, yeah, it's fine, it's accurate, but... All right, we'll do a df-h, and we've got a bunch of information right here around the root file system. So, something to note real quick. This is the root file system, the slash. So if I cd to /, I am in the root of the file system. If I cd to root, who knows what that's called? Somebody knows what that's called? Somebody here knows what that's called. But think about it for a second. This is the root of the file system. So what is /root? What's /root? That's root's home. That's root's home. Yeah, guys, that's actually root's home there, right? So / is just the root of the file system. Everything hangs off of this. Everything, the absolute path starts here on all things. Hey, Rod Void, how's it going? Thanks for the follow. Hopefully this stuff's useful too. Yeah, it's your home, right? Yeah, because we're root. By the way, this user is root, even though the shell doesn't look like it, and we talk about that sometimes. You guys can always, S1, you can always echo and fix that shell if you want, right? Change it to whatever you want. But we have the home directory here. So here's the root of the file system. There's root's home. And I said to go ahead and add a disk. So what's the size of the home? We can go look. Here's the size of, not home, root. There's root. It's got 20 gigs. Excuse me. There it is. 4.5 gigs used, 15 gigs available. Not root's home, definitely not. So, I said the command just cuts out the unnecessary information. You can check the output by removing that and see what happens. So that's what I did, and it's 20 gigs. So now we're going to make a little, this is a little diddle I like to use. I'll clear the screen. And wherever we're at, we're going to dd, which is going to be the disk duplicator, and we're going to say the in file is dev0. So go to the kernel and ask for a bit, and it's going to give you a 0, and it'll do that for as many zeros as you ask for. The out file is going to be root big file. The block size is going to be 1024K, which is exactly 1 meg. And then we're going to count 3,000. Oops. I also need to make sure that I have a space there. Count is equal to 3,000. Now that's going to write, and we're going to see that it wrote approximately 3.1 gigs into the system, and it did it at 1.1 gig per second. And it also should tell us, it doesn't give us the time there, but it tells us that it did it, and it tells us the overall time. It took just under 3 seconds or so, right? Now if I do a df-h on just root, I see that when I had 15 gigs before, now I have only 12 gigs free. So I did use 3 gigs, right? Can you check the much simpler command du-sh? You can. So if I'm in there, I can use a du-sh. Let's see, where am I? On root. Yeah. You can do that. Yeah. But du-sh will show you the usage of the system. So if I was over here or something, and I did a du-sh, it'll just give me the total, right? And then if I was in root, then yeah, I could use du-sh, and it would tell me that it's using that. But I want to know how much I used against the whole file system, so I use df-h. And even if it was in a different directory, I could do that. So it depends, like, if I'm trying to see, like, the macro view, that's df, and du is if I want to see just the folder or subfolders that I'm in, which is useful in other ways, too. So real quick, I'll look, and I'll see that it's there. It is approximately 3 gigs. That's a ls-lh. See that file's there, and it's just some root big file. And it did use up the space, the 3 gigs that we expected it to, right? Well, then I can go here, and there's another thing. I have a df-i, and this is actually one that can get you in, I don't want to call this, I won't tell you this will get you in trouble, but in big storage solutions, sometimes this can. I've seen us run out of inodes in GPFS before. That's the general parallel file system, which is a huge IBM thing. IBM just bought HashiCorp, by the way, so if any of you guys are still using any of the HashiCorp products, it's all IBM now, so congratulations. We're going to just run this real quick, and I'll show you that there's all the inodes that are free on the system. Then we're going to touch 10,000 files. That's a little diddle right there that'll touch 10,000 files for you. Then we check, we see that we made about 10,000 files in here. And then we look again, and instead of having let's see, where were we at here? Yeah. Instead of having 2.465 million, right? So 2,465,000. Now we have 2,455,000. We've lost 10,000 right there. This has lost 10,000. Now you might say, Scott, could you fill up all the inodes in your system without filling up all the space, and would it still break the system? And I want you to think about that. Will that still break the system? Will the system that has no other reference pointers to put memory back anymore in the shelves, even if it still had 12 gigs of shelf space left, would it break the file system? And then, by the way, you can test it. You can just go make a bunch of files if you want, right? It will break your file system. Your stuff will stop working. So that's something to think about, all right? So we hit check here, boom, and then we did that. Looks at you learning Linux, you looked at the disk space and usage. So that was our third lab. That was our third little lab from the book. Come down here, and the next lab is all about networking imports. Right, checking networking imports. We'll do that one here in a minute. But we're gonna play some more Brotato first. Oh, do they have the DLC? Hold on, is the DLC open? Nope. 2024. We got some other games too. It looks interesting. They got all kinds of new weapons. I have never been a fan of the melee in the game, so I stay away from it. Oh yeah, all kinds of crap going on. All right, we'll get rid of that. We're gonna play a guy who I sometimes beat it with, but not all the time. We're gonna play with the multitasker. So the multitasker, instead of having only 6 arms, he gets 12 arms. He's the only character that gets that. And we're going to play it with laser guns, because if you get enough laser guns, this guy's really, really strong. So I'm going to make another one of these. By the way, you guys notice I'm in the just chatting channel. I'm not in the technology, so I can just do whatever I want. But I won't be doing hot tub streams, even though some of you guys keep telling me to. The first one, excuse me, will be, first prediction will be, will I beat stage 15? So, you guys can vote or spend your channel points as you want. Will I beat 15 of Brotato? And I will leave you guys to vote on that while you watch me play. And see if you think that I'm going to beat level 15 of this game or not. Alright. I could do whatever I want in the science and tech channel, couldn't I? I can do whatever I want anyways, can't I, Ranger? Or, Robodom. Called you Ranger. I want to check on Ranger Dog, hold on. How's Ranger doing, guys? Ranger is acting like he's got a hard life. It's only 70, shoot, it's only 75 in Phoenix right now. It's actually kind of nice out. It's been 90 all week, and now it's only 75, so that's pretty nice. All right. Oh, there's Ranger moving around. Still alive. Always got to check on him, make sure he's still alive. Ranger's been working hard, guys. All right. So will I beat the first 15 levels? You guys can vote. We only got one person spending channel points, so that's an easy one to vote against me. All right. The laser cannons shoot really slow, so they're really hard to play with, and it's one of the only reasons it's only, I think, effective on this character. Any other character that tries to play with them, I'm just not a big fan of the laser cannons or the laser guns. They do a tremendous amount of damage though, which is super useful. I couldn't get the shot off. And they scale really high with range damage. They scale at a 4-to-1 ratio, so they're really high. And we want more attack speed and more guns. The one thing that he loses though is he gets plus 20 damage to start, but he loses 5 damage for every time he gets another gun. So that sounds bad, except the guns do so much damage that it's negligible by the time you get to high enough level to actually do something with it. So, all right, we'll see. There's like a critical mass with this guy right around like level 8 or 9, where if you just can't get enough guns, then he loses. But if you get them, then he's got a chance. See how slow? I mean, shoot, they're shooting so slow even right now. God damn. You guys got to remember, I don't have to pick up a crate. It'll come to me at the end of the level. But you want them to get it. It fills your life up, so it is useful to get them still. All the other stuff you do want to take though. All right, garbage. Take range damage and don't want any of that. Want more laser guns. I'll take regen because I want more regen, I guess. And then we'll take that, and we do want a penetration. Now, a laser gun penetrates once, but with that it'll penetrate twice, so it'll go through 3 enemies, and it does a pretty good job of damaging things, so we'll be okay with that for now. Alright. Because your bullets can penetrate multiple times, but there's a significant diminishing returns on them. I think it's 50%, and then I think it's another 30 or 50%, so it drops pretty fast, but you can there's tools that'll make it better, like the pumpkin. So, all right, this is more manageable, but it's not good yet. We gotta get more guns. Just always more guns with this guy. It's an interesting looking character. Yeah, this guy just keeps getting more and more. Get more attack speed. Bullets. More lasers. We want the range, and we want all this. All right, let's keep going. See how we do. The whole goal is to get all 12 of his guns and just be like a big walking laser light show, basically. Just killing everything. The initial hit's 40, the second hit is in the 20s. That's enough to kill pretty much everything on the screen. So all I need to do is just kind of keep the guys lined up. And I can do a pretty good job of killing everything. Don't want to get overwhelmed on any of the levels. So, alright. That was okay. Give some more speed. Take all that. More guns. This is a really good, man, that's really early to get an Obliterator. Obliterator's a really good gun. It's heavy. It blasts through everything. Like, it penetrates everything. It's got 100 piercing. It'll go through all the monsters on the screen. So it's actually a pretty good gun. I've never seen one at wave 5, so that's pretty good. We'll take that, and the Cyberball's pretty good, but not on this guy, not right now. So we'll just hold on to those for now, and then we're just gonna keep building up whatever we can get. Yeah, if we get Obliterators, they fire really slow, but we can mitigate that later. But they do a lot of damage, so they'll be useful in endgame if we can get a whole bunch of them. So one cool thing about Brotato is the way the shop works. Once you have something and it kind of gets, I don't know if it gets triggered or tagged somewhere in the back end where they're like, well, he likes that, so I'll keep giving him that for the run. So there's a little bit. Hey, how's it going, Critzy? We're doing some Linux today, but we're also playing video games. So we're doing a little of everything on a Friday because, you know, it's not super serious. The wife's out of town. She went to a scrapbooking retreat with her girlfriends, so we're doing that. You're doing your CKA in 2 weeks? Nice. Nice. I can do some CKA stuff this weekend. I got time. We're gonna take some hit points, I guess, and attack speed on this guy. Always try to get as much attack speed as I can. We're gonna take the bait, and we'll take the harvesting, and we'll get the piercing in the next round. This level, the whole thing I want to do on this level is make sure those guys don't get the pop. And then these things are significantly harder when I have less good guns. Oh man. Yeah, so I took the bait there, right? I did that to myself. So I want to keep these guys from popping up as much as I can. Okay, good. All right, I should be able to survive. That was my fault. That's kind of like a little challenge early on. If you take that bait, it can kill you, right? It can kill you, and it almost did kill me there. But no, I'm pretty okay now. I should be able to kind of out DPS anything else that comes out. But I didn't do a good job of popping eggs this round. But this is like one of those levels that's kind of like a on this guy it can be a kind of like a kill or be killed. All right, there we go. Take that. We're gonna finally get that. It's over the top, and we'll take more attack speed, and we'll save that. So now we have an obliterator, which is going to do 216 damage and go through everything on the screen. But it fires pretty slow, so it's doing 1.96, so it's pretty slow cooldown. But you guys will see it firing. It'll kill all these guys one hit. So this level is the one that I told you guys is the DPS. It's kind of like a DPS check, like if you're doing enough damage to keep going, and if you don't, this level will pile up very quickly on you, and then you'll lose. So that's the challenge. Alright, so doing this. Also, I'm supposed to give blood tomorrow, but they haven't messaged me, so I guess they don't want me to give blood tomorrow. I don't know 100% if I am giving blood or not. If they don't tell me that there's an appointment, I guess I don't have to go, right? I was telling somebody the other day, I've been giving blood since I was like 18 years old, maybe even earlier. Maybe they let you start doing that at 17, I don't know. I've been giving blood for a long time, so the other day was the first time I've ever, yeah, just blood donation. The other day was the only time that they've ever, they pricked my finger and they go, you don't have enough iron. And I'm like, what? My blood always goes like that to the bottom. And the girl's like, yeah. And I go, well, I just got done working out for an hour with one of my buddies, like one of my wrestling buddies. We do a class at the gym, and just it's all the closest thing to what we were doing would kind of look like a HIIT, high intensity interval training, or what people do in CrossFit, but it was basically just body weight. It was all calisthenics. And the girl's like, well, yeah, maybe sometimes people burn off all their, and I was like, really? So anyways, they turned me away last Saturday for giving blood. I was surprised. Never happened to me before in my life. So kind of sad. I told my wife, I was like, they didn't call me a hero. They always call me a hero, you know, because when you donate blood, they didn't do it this time. All right, this level is going to be interesting because I have a lot of bullets and a lot of damage. I got a lot of piercing, but there's just a bunch of really weak enemies, and this one can kill you. So this one I gotta try to stay to the outside, always be firing into the middle on these guys, because there's too many enemies for my weak slow weapon. Well, they're powerful slow weapons, but if I'm not penetrating through and killing, these guys would pile up on me very quickly. So I gotta kind of like stay to the outside and always be hitting multiple, and that's kind of one of the ways to win this level, because if you get spread out and you're not hitting enemies behind enemies, I don't have enough guns to, you know, and they're too slow. We're doing all right though. We're keeping the damage going. Damage going in towards the middle, so that's important. If they get all around me, yeah, I'll kind of lose because I won't be able to do enough damage. All my over damage, my trample damage, if you will, if anybody remembers Magic. I know some of you guys probably still play Magic. I haven't played it since like '95, but Yeah, the game's been around since the early 90s, in case you guys didn't know. I haven't played it since 95, though. Alright, we want crit. That's huge. We want more range damage. And better gun. That. All that stuff's good. Take that. And more laser guns, because, right, we need as many guns as we can hold. We don't want the sniper. It's a good gun, but it doesn't really matter to this build, and we'll take that. So we have more lasers. We have 11 of our 12 guns now, and that's pretty good. So, also, at any time I can combine these guns and keep getting more, right? These all need to go to level 4 eventually, so that's all something to happen. And how'd the voting go? Everybody said yes? Oh, alright, well. I guess we'll see. Can't believe you guys all believe in me that much. I think you guys just maybe think that I normally beat level 15 or something. That's not true, though. It's not always true anyways. Alright. See how we do here. Everybody see that IBM bought HashiCorp? I don't know if all you guys were around when I was talking about it earlier, but yeah, IBM did buy HashiCorp, so that's an interesting development in the industry. Makes you wonder if that was part of the business source license thing that was going on in August. So they switched to a business source license. Maybe they did that because there was rumblings. Maybe there was talk of them getting bought out. And maybe that was something that, you know, they needed to sort out before IBM would buy them. I don't know. Like I'm guessing there, but that could have been a thing, and that could have been a consideration. I don't know. But it is interesting that they did that and then they got bought. Most companies that do that, BSL or any of the business source license, they're trying to. Most of them are trying to cause not problems for, but they're trying to stop the competition of the cloud vendors that are using their stuff for free and making money. That's most of what they're trying to do. All right, we want the baby with a beard because it'll do extra damage. We want the gentle alien, and we'll take range damage. We will take the slowdown with the tooth because that's important. Take more harvesting and another laser gun. Now we're full on guns, but we can still get more. Right? We can always switch things around. And we want silver bullets so we do more damage to the bosses later. That's important. Alright. Alright, we're doing good. Alright, you believe Robodon? That's funny. Alright. So we're messing around today because it's Friday and that's what we do on Fridays, right? We mess around. We see what kind of shenanigans we can get into. I do have some stuff to build in my home lab, so hopefully I get around to that tonight. But if not, we're just gonna hang out and do whatever we want, right? It's this or watch bad horror movies on the internet, because I try to watch horror movies and they just, I don't know. Maybe I'm just too overly critical, but I like horror movies, but they never like do it for me. So what I mean by that is they just never really get scary, you know? Like I'm trying to watch a good story and a good horror movie and watching people get killed, and it doesn't always happen. It doesn't always work out for me. So I try to find good ones online. Maybe I need to get, does anybody here have that, what's that, there's like a horror, it's almost like a Peacock channel, but it's like for all horror. What is that? Yeah, Robodon, I don't know of any good new ones. I watched, I watched one called There's Something in the Barn. Because I've been through all the regulars, right? I just rewatched all the Nightmare on Elm Street the other day. I do this while I'm working, so I have like something on the side. But then I watched this one that was like kind of a B or like a C rated. I mean, this was bad. And it wasn't super good. It's called There's Something in the Barn. Let's go with attack speed, because this guy scales really well with attack speed because he's got 12 guns. So we'll do that. We'll lose a little bit of attack speed back. That's fine. And then we do want range damage. We'll take that. And then we want another laser gun, which we're going to have to combine one to get that, so that's good. And we'll go ahead and take lifesteal, because why not? And then wisdom. Wisdom's one of my favorite because it'll give me 5% damage every 5 seconds. But you do have a sunk cost of minus 20 damage, but you'll, work that out. Yeah, this one had like little elves, and they had all moved to like, where did they move? They moved to, I think, was it Iceland they moved to? I don't know. Wherever they moved, there was something in their barn. All right, so we got an elite to kill. This is probably the best boss for me to fight with this build because this guy doesn't do a lot except try to stay away from you and plant things on the ground. So I can pretty much kill him. That's good. That's probably some of the highest damage I've ever had in this game right here so far. Like, if you guys saw how quickly I just melted him down. So now all I got to do, build in a little bit more survivability into the build, and then just keep upping my damage and my attack speed, right? Like I do a lot of damage right now. I need to make sure that I'm survivable and that I'm doing enough actual hitting of, because what they're going to do in the next one coming up in a couple levels, there's no boss. It's just a horde of enemies, and the horde of enemies is also kind of hard because there's just so many of them, and I have really good single target DPS right here. Like, my damage on any one target is just going to melt it, but they're going to have hundreds of targets on the screen right there. So there's different things you got to build for here. All right, that's huge. Big crit, big range, take it, and more crit. Let's take it. More attack speed, take it. Take all that. And my armor is pretty bad. I take 25% more damage. That's not optimal, right? We're gonna take more pumpkin damage, and that's good for now. All right, we don't have that horde until wave 15, so I got 2 more waves before it comes out. But we'll do more here in a little bit. We'll do some more Linux. But gotta decompress. Engineers can't just be all work, all go, go, go. They gotta do some relaxing too, and this is one of the mindless ways that I sometimes relax. Although I haven't played Brotato in a while. When I turned this on today, I was like, I haven't been in here in a bit. So, but I do kind of look forward to that expansion. It might be fun. It really depends. This game was a big hit too, by the way. A lot of people really liked it. So, super simple, roguelite. Not quite. You don't build up anything in between rounds, but actually you kind of do, actually, because when you beat with certain guys, you open up and unlock items, so there is a little bit of persistence through the levels. So, alright. So we're doing that. You have so many guns. Yeah, I have as many guns as anybody's ever had right now. More attack speed, right? Because that's skills. Take more crit and dodge. And then more laser guns. More ranged. Because remember, range scales 4 times with these guns. Because they do 400% range. This one does 1,000% range. So when I get range damage, it's 4 times as much for those guns, and it's 10 times as much for the obliterator. So that's a really good pickup right there. And then we'll take more crit in one of the next levels. All right, one more level before we get to the horde. Right. We should be able to handle the horde because we've got the baby with a beard, and that is doing, for right now, it's doing 11 extra damage on top of. So when we kill something, a bullet fires at something else, and it can actually cause a pretty good cascade. If it we need a little bit more damage out of it, but we should be fine. We're hitting for 113 and 158. 204. So, by the way, if you see my damage constantly going up, that's because I've got the beard, or it's called wisdom, and it keeps causing me to have more and more damage as the level goes on. So my guy will hit harder and harder as the stuff goes on. I think I just saw 740, which was probably the obliterator hitting something with a crit. I'm hitting for 256 with something right now. Yeah, so we're doing a lot of damage, but we're also taking a lot of damage. See how that almost killed me one hit? That is not optimal to almost die and then be at half health because I don't have anything healing me. That's not good. I need more sustain. We'll take more hit points for now. Better laser gun, crit. We do want the lure, even though it's on. Okay, we want this again with the baby with the beard, and we'll take more enemies. This is gonna be iffy. This is a level that beat me here, but then we'll be on the end of the. Oh, look at how many of those freaking light up things just happened. That was a lot. All right, so the horde levels, you always end up running because there's just so many enemies. It's very hard to kill all the enemies and keep up. So but we'll see how we do. It's good that we do so much damage and have such high penetration, because even though they're piling up, we're still killing them in their little groups back there. So That's pretty good. We're doing good damage. As long as they're grouped up, we hit them pretty good. So, all right. Yeah, this isn't as bad as I thought it was going to be. I thought I was going to be running more. Didn't think I'd be able to pick up the stuff as much. Typically, if you can't pick stuff up, you got to circle around and pick it up when the enemies aren't there. But no, we're doing pretty good. And you might notice I'm not picking those things up. I have no reason to pick those up until I get hurt. And plus, when I get hurt, they'll automatically fly to me. So it's better to just wait, not pick them up until you need them, right? Take the blindfold for more crit. We don't need the turret. Don't need charcoal. More attack speed. We'll start building up our luck. That's good. Screwdrivers are good, but not on this guy. And we'll take crit. We'll take more armor. Take more hit points. We'll take more attack speed and range. A little less life steal. We're not using life steal on this guy. And then another laser gun here in a minute. All right. These levels are just loot, basically loot boxes. We're just beating the loot pinata right now. Those little guys that look like brains that try to stay away from me, they'll keep buffing the other guys and making them like twice as strong, and they move faster and everything. So that's why they hang out in the back, those little brains. But we just kill them and collect all their loot. This is kind of an easier run now because we've got all our guns. All right. Kill that guy. Take his little loot box. I used to call that guy Timmy, and it was his little backpack. It comes from an old Adam Sandler skit. If any of you guys don't remember, but they used to put comedy out on CDs back in the day. Used to go buy a CD when I was a kid, and it would have a bunch of comedy tracks on it by like Adam Sandler, or he's the only one I can really remember, but other comedians. The Jerky Boys. If any of you guys remember the Jerky Boys, they were out there back in the day. Attack speed. Minigun's pretty good, but not for this guy, so we don't need it. We'll take more attack speed, even more attack speed, and we'll take a little less attack speed but more damage. And then now we got one more elite, and then we just got to get ready for the bosses. Oh, by the way, we can do the prediction. I did beat round 15. So here, I'll do another prediction for people that do want to have one. Will I beat round 20? Will I beat round 20 of Brotato? So you guys can predict on that. Anybody wants to see if they think I can make it? Pretty much any two hits are going to kill me. So we're familiar with Sandler's mainstream stuff. Yeah, Robodom, some of his stuff back then was so off the wall, but it was so funny. I can't even talk about it on stream, I don't think. Some of his stuff was so dirty that like I literally couldn't even talk about it on stream. It would be too awkward. So, all right, somebody's voting no. Somebody's got to go for those channel points. But remember where we're at right here. We're at level 17. I've got more firepower than probably. I mean, I've probably had thousands of rounds of this. I'm probably in like the top 1% of firepower I've ever had. So, think about that. Let's do. We'll do one more lab, and then we'll go do the balance of that. How's that? Let's go hit this lab up. We'll do a lab, and then we'll finish off that thing. Trying to be strategic with the bets. Did you bet against me? Let's see. I think I can look at the. Where's our? I think I can look. Summary. Yes. No. Robodom said no. Somebody vote yes. I'm gonna win this one. Somebody can take 4,000 points right now. Those points don't mean anything to anybody. You can just do a bunch of ranger checks though. But you guys can vote against him. All right. We're gonna do IP and open port information. So this is the lab right here for anybody that wants it. We'll go throw this over on the. If anybody's on YouTube, I don't think anybody's on YouTube, but if they are, here's the lab. And we'll throw it over on the Twitch side. Here's the lab. And yeah, Robodom, you didn't think I was going to catch you, did you? I don't care. I don't care if people. I don't think. Wait. This one should have been. This other one should have been done. Yeah. All right. All right. Nobody's voting anymore. All right. Fair enough. I guess nobody has to vote, but. So, let's do some IP information real quick. So, this is Linux Lab 4, checking networking and ports. And the task is learning about Linux networking and view current system networking state. So what's going on in our system? How fast are things moving? Nobody wants his points. Anybody can vote against me. Robodom says no, but I'm saying yes, but I can't vote in my own thing. The condition here is given a bash prompt, complete in the allotted 60 minutes time. That's always the condition. And then the standard is execute and understand the commands, understand command output of any given system, or of the given system. So here's some reflection questions. What are the home addresses of IPv4 and IPv6 networks? What does the pipe character do within a Linux command? If you ping Google, look at the IP route command. Which route was chosen to send the ICMP message out? How do you know? We're going to do all these different types of commands here, right? Okay. Somebody vote against him. Somebody go against maybe that's Robodom. You know what I think that is? That might be everybody trying to revolt and saying, stop playing Brotato. Stop playing Brotato. That's what everybody's doing here. All right. So, questions are on the right. I want you guys to think about those. What you're doing is on the left. And here it is. You're a new system administrator at a company. You've been tasked with finding out information about a set of servers that has very little to no documentation on it. I'm telling you guys, like, if that's a theme in all of my labs, please believe that that is something that is actually going to happen to you in your career. You are going to be tasked with figuring stuff out that nobody's looked at since it was first set up. So that's going to happen. So we're going to check network information, put a name of your network interface into a file called root interface, put the IP address of your network interface into a file called root primary IP, and then write the default route to a file called root default. These are all things that I do all the time in my environment. I have a set of servers right now that when they boot, they sometimes do not have the right route. And you say, well, how did that get set up? I did not set it up. But I'm the guy who makes sure that they're right. I use Ansible and stuff for it, but how do I check that? How would you even know if your system has a good route? Well, let's go look at this stuff. Hey, thanks for the follow. What's that? Mara, hopefully this stuff's useful to you. But here's all the things we're going to do. So we could type anything we want up here, but here's our solution. IP adder will show us that there is one interface here. There is a second interface here. And there's a third interface here. And all of these interfaces have different pieces of information about them, right? Oh, somebody's going to get a really big payout if I don't pass that, right? If I don't beat Brotato, there's going to be a really big payout. If config isn't always there, if config isn't always on all modern Linux, in Red Hat it is, so you can use ifconfig instead, but either tool will still tell you the same information. It'll just give it to you in a little bit of different output. If you guys want to see ifconfig, ifconfig, here's ifconfig. It looks nice. I've got a Docker, I've got an eth0, I've got a loopback, and I've got this virtual bridge doing whatever things I'm doing in my environment, right? And then there's a bunch of information. There's your IPv4 addresses. There's your Ethernet, which Ethernet is going to be 48 bits in hexadecimal, right? The first 24 bits are going to be the vendor, and the second 24 bits are going to be the product of the vendor, right? So you can actually take these. If you guys didn't know this is really useful to you. If you didn't know, I could go find out on this Ethernet one here. We'll use the Ethernet one. I can go look at who the vendor is for this device, if this was a physical device. Now, this isn't a physical device, but let's go here. Let's just go to Linux and just say MAC address vendor lookup, right? I just dropped this in here real quick. Wait, what? Oh, I've never seen Google say I've had a problem like that before. Here, we'll just click here and just drop the MAC address in here and see if it can tell us. By the way, it's going to have none because that's a generated one. That's a special generated one. But what if I came here to my Windows box, right? Because you follow the same rules whatever you're doing. ipconfig/all. And in here, in my internal home network, right here on my Ethernet adapter that connects to my network right here, I have a physical address right here. Control C that. Drop this in here. And this will tell you what vendor made this. The Dell One Way Round Rock, whatever, right? So I could find device information on the network. Now, one thing about MAC information, before you say, Scott, you're doxing yourself, you're giving your MAC out. MAC information never leaves the network it's on. MAC information is non-hierarchical, and it's part of the Ethernet 2 frame, and it gets stripped off by literally every device before it goes to the next hop. So, doesn't matter, right? But it is good for me to know what all my devices are. If I just looked across an ARP table in a network, ARP-A, right? I could tell what all these devices are if I wanted to go look up all those physical addresses. I could do the same thing in my Linux ARP, right? Oops. What? I did it twice? ARP-A. I can see all my devices in my network, right? So there's different things that you can do. And in our case, we've got 3 interfaces. We've got this loopback interface. Loopback is always there in TCP/IP, and it is always 127.0.0.1, which is home, my device. If I do a ping of 127.0.0.1, I can test the IP stack, the TCP/IP stack for this whole kernel. If I go ping 127.0.0.1, that coming back tells me TCP is working on this box. I can go muck around with TCP. You can use sysctl commands, and you can change the way your TCP/IP works, and you can break it. And then those pings might not come back, right? We're not going to do that in this lab, but that's something to play with. I've got this other interface, and this interface right here, I know it's not easy to read because I don't have it all like this, but this interface is going to have a 172.30.1.2 address with a /24, meaning that the significant network portion of this address is the 172.30.1. This part over here are all the hosts inside my network, right? So /24 means. Now, we come over here, we can see on this network that I've got this set up, I've got this, and I've got this Docker network. This Docker network is a 172.17 network with a /16, which means that this is the network portion right here, and these are the host portion. So I have a huge amount. In fact, it's 65,500. Hold on. Something broke my. Something broke that. Am I back? Am I back talking again? Can you guys hear me? Good. My network got messed up, or my thing got messed up there. But anyway, so Docker, probably not my primary interface. Loopback interface, definitely not there. Yeah, you guys could hear me, but that thing wasn't doing my CC. If I need to make a little command. If you guys ever see my CC not working, I need to make like an ! CC command, and it's got to be like, go fix your damn CC. And I'll look down and I'll see that because I don't notice always that this thing isn't running. But so real quick, we could look at our IP address, and then we could carve that down and look at just my interface that I care about, and just the we'll go throw that into a file called root interface, and then if we cat root interface, we'll see that it's ENP1S0. Then I can see what's the IP of that interface, and I can just throw that in a file. But real quick, how do I know that this is my primary interface? I mean, I guess, but we know it's not the loopback, but how do I know it's not this Docker one? Well, let's go do an IP route real quick. And with our IP route, we do have a default route, and that is going to be how things go if they don't know to travel. So if something in my network goes to 172.17.0.0, which is matched to our Docker, it's going to go to our Docker. If it's 172.30.1 and anything else, it's going to go out ENP1S0. If it's anything else in all the world, it's going to go out our default route to here. So that's my default gateway right there. This is also what you might call in the router world a gateway of last resort, right? And if I wanted to test that, by the way, I'm going to throw that in there. There's my default. And then I'm going to ping real quick over to Google. Wait, what am I pinging? I'm pinging that. Let's also, as I said over here, let's ping Google as well and see what happens. After you ping Google, look at the IP route command again. So we're going to clear, and we're going to ping www.google.com. And we could do a -C3. If you don't give it In the Linux world, it's by default just going to ping forever, unless you give it a requirement of stopping after a certain amount, which is with count. So that pinged Google, right? But then I do an IP route, and how did I get to 172.217.13.132? Let's check. Does 172.217 match 172.17 in the first 16-bit placement? It does not, because the only way it could do that is if it was 172.17. It's not. So it did not go out this interface. Then I have 172.217. Does that match 172.30.1 to that significant place? Does it, I don't know, Robodom, you might be able to, if you guys have ever seen Nightbot, there is a way for moderators to add stuff. So if we do login and then go look in the commands, in our custom commands, there is a way to build these on the fly, Robodom, and I don't know what it is. I think really we would just have to go like exclamation mark, like CC, and then be like at het Tanis. Let me see. Hold on. I need to see if my name is Tanis. Fix your CC. It's broken. And then the user level for that can just be moderators if I want. And then there can be a cooldown on it, and then I hit submit. And then to go fix that other thing, which were my commands, I have to put it in here. And then it would be exclamation mark CC. Now, Robodom, if you do CC, or sorry, if you do commands again, it'll tell you the commands, and then if you do exclamation mark CC, it'll yell at me. So, there we go. All right. By the way, so did 172.217.13 match 172.30.1 to 24 places? It did not, guys. It's busted. Nobody else should be able to do that besides mods, by the way, Robodom. So if you ever see anybody but a mod do that, let me know, and I'll go have to fix it or something. Yeah, so CC's working. That's good. We come down here. We did all that. Now, I've shown you guys this before, but there's other things about networking that might be interesting to you. Right here I said, after you run the timeout... Oh, so then there's some other stuff. But let's keep playing with ping for a second. Actually, I'm going to take a real quick break. Let's go check on Ranger Cam. We're going to go to Ranger Cam. I'm going to take a real quick break, and we'll leave it on Ranger Cam. Hourglass. I'll stretch my legs for a minute. I've been sitting here for a while. Thank you, Miles. I appreciate that. And quick break. And then finish lab. Check on Ranger. You guys can check on Ranger. Excuse me. All right, I'll be right back. I do need more water bottles, too. All right, I'll be back, guys. Get more water bottles. I am super excited that I get to eat cold pizza for dinner. I actually really like cold pizza. You guys might think that's weird, but that's what I do. Ranger's had dinner already, but I'll go give him a treat a little later. Alright, I'm going to leave the breakup, so even though I'm here, so if anybody's got questions, feel free to ask me. But I am kind of sitting here chilling for a minute. I'm going to check some college stuff real quick. See what's going on in my college classes. And it's super interesting to me that nobody has posted in my college class in like the last 2 days. I almost feel like I got logged out or something. Like, am I not connected to my college stuff right now? Nobody's posted in like 2 days. I'm the only one that's posted in my college class. So, kind of, it's kind of interesting to me. I guess I'm gonna post again today then, here in a little bit. So, I'll do that on a break here later. Got my other stuff going. Let's switch our music over. By the way, I need to give you guys some options for music. Where, hold on. There's my music here. If you guys want to switch the music ever, here's my channels that I've built for music. We've got our stream 8-bit, we've got our stream acoustic, we've got our stream coffee shop. Those ones are okay, but somebody would really have to want to ask that to go there. Stream drums, those are okay. But the main ones we listen to are the stream chill, the stream dark, and the stream fast. So if you guys want any of those, I guess I can make a request like this back on Nightbot. If you guys wanted, let's go log back in real quick. Commands, say music. You can request to change the music. Your options are stream. Your options are chill, dark, fast, 8-bit, acoustic, coffee shop, and drums. User levels, everyone. So you can request whatever you want, right? Doesn't mean we're always going to go to it, but you guys should be able to do that now. So if you do music, well, what's Ranger? It's always weird to me when Ranger alerts, like, because I wonder if somebody's down there. You know, like if he's alerting when he's as old as he is, it's super weird to me. Like, he's an old lazy dog, and if he's like looking around like he's like paying attention to somebody, and he can't hear me up here, but he's kind of like alert, like something's going on down there, and that always makes me wonder what's going on with him. So, all right, we'll chill on Ranger for a little bit. Got 3 more minutes if anybody's gonna go, you know, smoke them if you got them, whatever. Let me move this stuff out of the way. I think we're on chill right now. This seems pretty chill. Go to fast. Oh, also gotta make sure it's on. Yep, okay, good. It's on loop and just random, so it'll just randomize whatever you guys, whatever we're hearing. All right. Gosh, Ranger's such a lazy animal. He's a good dog though. And it's nice and cool. Maybe he and I will go for a walk later. He doesn't like going walking very far, so I just take him to the mailbox and back. And the mailbox is about 2 houses down, so it's not a bad walk for him. But when he's done, he's like, "Oh man, that was like the longest walk I ever did, bro." And I'm like, "You used to chase a ball for like 3 hours straight. You would run." But you know, he doesn't chase the ball anymore. He won't go. But we love Ranger. He's kind of our little mascot around here. You know, do things as lazy as possible and still collect all the loots. He's also probably got the easiest job of any one of us, because man, I don't know if I've ever seen him do anything ever. Never, not even once. All right. Anyways, let's come back over here. Stop talking trash about Ranger. We'll finish up the lab. I'm gonna let that finish, because I don't. If somebody walked away and expected they have 8 minutes, I want to give them the full 8 minutes. Same thing I do with my college students. If I just start going and running through stuff, I'll feel a little bit like a jerk. So the next thing we're going to do is we're going to test some network stuff. And I don't have this in the lab, but this is something that I think is valuable to know about the system. So one thing that I'm going to talk about here in a second is how we ping. And ping is the Packet Internet Working Groper. So congratulations, now you know that. And it's Internet Control Messaging Protocol, right? ICMP. But ICMP is going to exist at layer 3, right? ICMP is up here. And we're going to stuff that ping packet down into a frame. So we're going to do some stuff. Some of you guys have probably seen me do this a while ago. I haven't done this on stream in a bit. But we're going to ping things, and then we're going to prove that what we do with the packet does matter whether or not it goes down into the frame, right? Frames have a maximum transmission unit. They have a certain size that you can be to fit in them. And if you don't fit, we fragment the packet, right? But we're going to set it to no fragment, and then we're going to try to see if we can send something bigger. We did this a while back, so for some of you this might be familiar if you've been around, but we're gonna play with that a little bit. Also, one other rule about ping that's really important: don't ever try to ping weird shit to Google. They just drop your traffic. So one of the funny things about this is if you ping Yahoo or if you ping your local network, your gateway, it'll work. But if you go trying to ping Google, you're just gonna get all kinds of other non-responses. So let's do some stuff real quick. We'll ping, so we'll do IPR, IP route, and there's our default right here. So that's where we want to ping to. If we couldn't remember that, we can go throw that in a notepad, but we can remember that. And then one other thing, let's do our IP address again, and let's look at things about the ENP1S0 real quick. A couple of things that are important here. One of the things that we see right here is that there's a maximum transmission unit of 1500. That's a very common 1500 bytes. That's all that's going to be allowed in an Ethernet frame. Now that includes a header. There's a header that's 40 something bytes, maybe a little less. And that header and then the payload have to be under 1500. That's maximum transmission unit. This is super weird. It says that we just went to an ad, but I thought we just got off of an ad. So is anyone on an ad? Hold on. That's super weird. I literally thought we just got off an ad. So I apologize, guys. We'll hold off. We'll wait a few more minutes. My timer ended and then the ad started, but I swear it just said that we were on an ad. So, all right, we'll wait a minute, guys. We'll wait. Yeah, it's super weird, man. I know some of you guys are still hanging around. People that are, subscribed and stuff. You guys don't see the ads, but that was super weird. Also, interesting fact, and I think this would be the weirdest thing because I don't think anybody would like you if you did this. Did you know that you could have subscribers still need ads, or subscribers still see ads? Did you guys know that? There's actually a setting in Twitch where you can say, even if you subscribe to me, you still get ads. And I'm like, that's the main reason to subscribe to somebody. I don't even subscribe to people. I use Turbo, right? I don't get ads at all. I pay the $10 because I swear to God, I can't sit in a stream for 30 minutes without just, oh, there we go. Okay. Yeah, I was just talking about how I don't get ads because I use Turbo, but the reason is because I can't subscribe to everybody, so I just use Turbo, right? I'm super lazy about that, but I can't stand ads either, so I apologize, guys. By the way, like, if you guys have been like on Amazon Prime and they have those ads at the beginning, I haven't watched an Amazon Prime thing in like last 3 weeks. I haven't watched anything on Prime. I use my Crunchyroll, I use my Hulu, I use Netflix. I even have High Dive, which is like a kind of, it's like a, it's anime, but it's kind of like almost, I want to say like not as moved over to America anime, but it's not. They used to have a pretty high level of like uncensored stuff, but I don't really, they don't really have that anymore, and also I don't really use it for that. I just use it for keeping track of like newer animes and stuff, and there's some pretty good ones over there. But anyways, let's ping this real quick. Let's ping over to our default gateway, and we'll just say ping-c1. We want to test our ping to 172.30.1.1, and we get a response, right? Good. So now we ping over there, and we say that we want to use a size. And by the way, if you need help, you just do help. And then I'll say I want to do a size as the number of bytes. And I'm going to ping over there with a size of something bigger than 1500 bytes. Let's say 4500 bytes. Now, I know that I literally just read right here in my system that there's a maximum transmission unit of 1500. So there has to be something that gives right here. This either is going to break because it can't send that, or as it goes down the stack, right? We talked about that IP stack. As it gets to the packet layer and starts to go into frames, what's going to happen is your data link layer, which is layer 2, is going to chop that into 4 packages. And you say, why not 3? Isn't the 1500, 1500, 1500? Haha, I got you. No, there's headers. So it's going to have to be at least in 4 to be able to go. Now, we're not going to see that. We could see that on the TCP if we were watching TCP dump right now. But let's just run this and see, did it work? Yeah, it did work. And it says that the total bytes was 4,508 bytes was the response back, or was the, yeah. So we got a ping, right? We got it to work. And when it came back the other way, it had to be chopped up into 4 frames as well. Again, we're not looking at that right now. We could do a TCP dump and look at that, but that's not a big deal. But what if I say, don't you dare carve that up, which is right here, the dash capital M. Where's dash capital M? And this is our PMTUD. It says define discovery can be one of do, don't, or want. And when we say do, we're saying, and you got to go read the man pages for this. I've just been doing this forever. Do says do set the do not fragment bit. I know. Because wouldn't you just think it was don't fragment this? This is do set the do not fragment bit. And this should fail because now when that 4500 bytes comes down and hits the data link layer, what's going to happen is it's going to go to chop it and it's going, this is a major award. You can't just chop this and throw it in 4 boxes. You can't do it. And this will break. So that by the way proves how the stack works. That's a way to prove it, right? And if you've never played with some of these tools, you'll be like, I just ping across and everything works and it's good. But I use these tools and some people, you probably watch this and go, why would you need to know that kind of networking? Because sometimes your device communicates on a far end with another device, and I've had this before. And the networking team told me, and I said, guys, I am using storage over here, and on this network, all of my traffic needs to be super frames or jumbo frames. We call them jumbo frames. 9,000 bytes is a common size. There's also 18,000. I think there's a bigger one. But they would assure me that everything was as expected. It was 9,000 bytes all the way across. And then I would say, okay, so I should be able to send, and then I wouldn't get the performance out of my storage systems. This has happened to me a few times in my career. I don't get the performance out of my storage systems. I know what the vendor says I have. I know what we planned and architected for, but I don't get the speed I expect. So what do? Well, there's this old saying in engineering, one test is worth 1,000 expert opinions. I could go and argue with them. I could go and send emails to their managers, to my manager. I could do all that. But what if I just go do this and I verify that, guys, between here and there, I sent an unchoppable frame, right? I said you cannot, and I'll even set it at 8,000 if I expect it to be 9,000. It wouldn't matter. If anywhere along that networking path that I don't have purview into, it doesn't have my jumbo frame set, I now know. And I take that and I go, guys, look. Somewhere along the frame, some device, I don't know which one, tried to chop this up and found a little thing at the front and said, this is a major award. You can't chop it up. You guys know what major award is from? My wife loves quoting that movie. I've only seen that movie like twice in my life. And I thought the same thing all the other Brazilian Jiu-Jitsu guys thought was the kid Ralphie's got a terrible half guard, right? It's a Jiu-Jitsu joke. Anyway, sorry. Doesn't matter. Anybody that's stuck with me this long here is probably insane by this point anyways, but all right. So we did that. We chopped things up. We had fun with networking. Guys, the networking stuff that happens is only magic until you go spend some time with it, and then you go, that's not magic, that's engineering. And I go, you can do this. This is all, it's all chutes and ladders. Everything points to something else. Everything literally has to talk to something else by using the right protocol and the right number of bytes and all that kind of stuff. And you can prove all this stuff as you go and learn how to use the systems. And if you didn't know, ping is that powerful. Ping, I can tell all kinds of things about a network with ping. So a lot of times we just turn our devices off so they don't even allow ping. By the way, if you do anything weird like this, you start sending weird size frames to Google, it ignores you. So never use Google for your tests. Use Yahoo. Yahoo's better. Yahoo accepts everything. They don't give a shit. It's actually kind of funny. But Google does not play. If you send any malformed ICMP traffic, it just ignores it. It doesn't respond. It black holes you. So, all right. So we did that part of the lab. Next part says, let's check this system for open ports. This is one of my favorite things, right? Like seeing what the system is trying to do. So you have a netstat command, but you don't have netstat in all modern systems. You do have netstat in Red Hat systems, but you don't have it in Ubuntu and most of these type of systems. So just remember that SS will do the same thing. And what SS will do, I'm going to make this a little smaller. I'll make this a little bigger. And then I'll clear the screen because that's a mess. And what SS will do is it'll tell you all the UDP connections that are unconnected and all the TCP listening connections on your system. There you go. And then if I want to search by one, I can capture this output and say, yeah, there's SSHD listening and SSHD listening. That's SSH connections, right? That's the daemon for SSH. And then container D is there as well. Now, what are they listening to? Here's the local address port. SSH will accept any IPv4 address on port 22. That is the any for IPv4. This is the any, or one of the common any's, for IPv6. So I accept any IPv6 coming in on port 22. Then this one is container D. Container D is listening to 46.749 as the port, but only on localhost. So only myself can talk to this device right here. And we actually did this earlier. We were doing that, what was that tool? It was called NetData. And we installed NetData, but then it was only listening on itself, so then we had to open it up to the world. Some of you guys were maybe around for that when we did that earlier. All right. So we did all that. Say echo yes into root ports because we do see that SSHD and container D are running. Yep. Yeah, container D is what's running Docker on this box. By the way, we use the killer code of labs, and they allow us to use the labs. You know, I'm not breaking any rules here. But it's funny, we're doing Linux stuff. We're like, hey, this is an Ubuntu box, we're going to do some Linux. But really, this is also, well, no, this is just the individual one, so it doesn't have it. But we have, on the other ones, we have Kubernetes stood up. So we could do Kubernetes labs on these too. But this one, yeah, this one can just do Docker, I guess. So I could do like Docker images, Docker PS, right? Do I have anything running? Do I have any images downloaded locally? Do I have anything running? That's our two commands. You also can get away with Podman. They're very similar, right? But container D is on these because container D tends to be the Kubernetes backend. So, all right. So then I say, can I see the listening ports for 22? And LSOF, if you don't use it, LSOF is really good for finding the open files to a directory and those kind of things. But did you also know that you can use it against ports? So you can see what ports are open on a system and see what's going on and kind of dig in on what's going on inside of the system. There's a lot of maybe useful information down in here. And then we can do a systemctl status on container D. We can see that main process ID 575 for this. Does that map to 575 here? Yep, it does. Look at that. Everything maps to something else, guys. There's nothing here that's magical. You can point to every piece of this somewhere. And if you say, well, could you point me to? Yeah, we can go deeper, guys. Right? We can, right? We can CD to proc, and then CD to proc, and then 575. This is a running process. So there's all the information about that running process in a flat file, in a directory with a bunch of flat files. That's all the information about this process right there. You can go look at all kinds of things. So lots of information here. So then I say, can we look at our netcat? Yeah. Can we netcat to our own system and see that one of the things about an open SSHD connection is it'll always send back a header and tell you the version information about it. That's kind of useful to know. That's also why setting an alternate port for SSH isn't super useful, because when people scan your systems, which they will scan your systems, it's always just going to be there. By the way, look here, in the last 6 hours, these are all the people that have tried to log into my home lab. All these bot users from all over the place. Look at all that. There's, probably about 100, maybe like 120, if I had to guess. We could count them if we wanted, but what's going on here? Shit busted? Alright, here we go. Okay, so then we'll stop container D, and then we'll go look for it again. It's not listening anymore. And if we, the directory we were in doesn't have anything in it anymore. I'm not even really standing in the directory anymore because the directory's gone. That's kind of funny. All right, anyways, we check that. Now we can check network traffic that's actually hitting our interfaces, right? So we look at throughput of our interfaces, and then we can make a little PCAP file that we could download and look at inside of a tool like Wireshark. So I might run here. I'm going to clear the screen. And I'm going to say something like if stat every 2 seconds for 10 seconds, or for 10 iterations, it'll be 20 seconds. We could run this. And now we can see the kilobytes per second from the OS side. By the way, it's a good thing if you don't do a lot of networking. Capital B and lowercase b matter. Right? Some of you know this. Some of you know, you're going to be like, Scott, fucking clearly. But not everybody knows that. So when you look at something like this, this is kilobytes per second. So this is bytes. This is times 8 from kilobits, right? Because every 8 bits is a byte. This is the way the OS is looking down at the interface. When you do things at the interface level, you're often looking at the actual bits, the bit rate of the interface. So that's always going to be a lowercase b. That does matter when you send emails and when you talk to other engineers, and people will call you out on it, right? If you're like talking in bytes, server guys, we tend to talk bytes because I don't care about how the bits are flowing. Network people tend to talk about the bits, so just know that, because you don't want to be talking past each other in a meeting. We're trying to troubleshoot something and figure something out, and you're talking bytes and they're talking bits, and the scale is not the same. Well, because one is 8 times less than the other one, right? All right, so anyways, so there's that. Then we can do a TCP dump and just gather 1,000 packets from that interface. So TCP dump -ni against the interface ENP1S0. The size is going to be the full size, and then -c is 1,000, so 1,000 packets captured. And then we're going to do a TCP dump to a specific file. So we're going to go ping this. And when I did that, I generated a whole bunch of trash pings, just so you guys know. And what happened there, let me make sure I'm in the right directory. Yeah, I'm in root, so that'll generate it. And then if we look at this file, there it is. It's about 21 kilobytes. You can also do it as an ls-l. If you just want to see it like that. See the raw bytes, that's the raw bytes there. See when it was created. And that cannot be read by catting it, right? Well, we can try. But it's not going to read it properly because it's actually in a .pcap format that you can then pull out, and then you open up Wireshark, pull it up on Wireshark and play through, right? We're not doing networking stuff right now, but if I pulled up my Wireshark, we could go look at what's going on inside of the networking, right? All right. So we come over here, and I say after you run the timeout command, see if you can modify it to timeout for 15 seconds. What other uses might you have for the timeout command? So if I just go press up here a few times, where was our timeout command? It was up a little ways. You could time out for 15 seconds, couldn't you? And I said then what other uses might you have for the timeout command? Well, you can when you loop over a list of servers, you could have a timeout command so that if it can't connect to them, it just times out, and then you could have some answer, something that's keeping track of which server you're on, and then it would know that you didn't hit like these 3 servers out of 100, and then you can go fix those 3 servers later. There's a lot of reasons to do it, but timeout is one that I like to use so things don't hang. I can keep server SSHs from hanging. I can keep all kinds of things. So, kind of useful little thing. All right. Then we hit check, and it says, "Look at you learning Linux. You looked at the network and all that stuff." I said, "What ports was Containerd listening on?" It was listening on some 4,000 something, right? Like we can go. Oh, I shouldn't have catted that out. I told you guys it wasn't any good. Hold on real quick. Can't see what's happening. Yeah, I shouldn't have catted that out. But I also can't see what Containerd was on. It's been too late. So, Containerd was listening on some 49,000 something. Then I said, looking at ifstat, if the system is using is this system using a large amount of its interface bandwidth? Why or why not? No. This system can go way faster than it is, and it's not currently. All right, there's your Ranger check. You guys wanted to check on Ranger? There you go. Boom. Okay. So we finished that lab, and then digging deeper, I say, what does it mean to run a dual stack IPv4 and IPv6 interfaces? What are the use cases for it in the industry? Why might you want to turn that functionality off? This is very important. So we come over here, and let's look at the system real quick. Clear IP adder again, and this box, this ENP1S0, is running an IPv4 interface here. That's all it's running. It's got no IPv6. But in my home lab here, clear this up, IP adder, I have IPv, this is my internal IP address. That's IPv4. That's INET 4, right? It's just INET because it's IPv4. And I've got a dual-honed IPv6 address that can also be used to connect to this system or to connect to other systems, right? So the reason that you might want to do that is if you're transitioning support to like newer systems, or you're trying to communicate using IPv6. You might have moved your whole organization to IPv6 and that's what you use everywhere. However, IPv4 may still be required for some of your OpenShift containers. Maybe some of your OpenShift containers require that you use IPv4 to communicate with them. That kind of stuff can happen, right? Some tooling is still set to only use IPv4. So, you have to know that and have to know why you should or shouldn't use IPv4. But if you were going to go on a little Google Safari with that, you might look up dual stack IPv4, IPv6, or you might look at what some people call dual honed interfaces. Those are the terms that I would use if I were going to look at for that. So what are the use cases in the industry? As we transition from one stack to another, IPv6 is the future. It's been the future for like the last 20 years. It's just we're not all on it. You can choose if you want to run it or not based on if you need backwards compatibility or for newer tooling. And that's the kind of thing. Why might you want to turn that functionality off? If you're not doing anything with IPv6, you should turn it off. Why have more attack surface? Why do anything with something if you're not using it? Turn it off, right? All right. So that's that lab. That was lab 4. We've been getting through them. So now the next one will be SSH and SCP. So we'll push data, we'll pull data, all that stuff. But we'll do that here in a little bit because we got to finish up Brotato. And if anybody wants to, well, the bet's already been placed, but I got to see if I can beat round 20 of this, right? So you guys are welcome to hang out. You guys remember I'm in the Just Chatting channel, so I can do whatever I want. But let's go, and I got to beat this mini boss. If I can beat the mini boss, then I have a few more levels, and then I've got the... Yeah, Brotato's still going, Robodom. Let's see how we can do. All right, this is one of the easier ones to beat right here. You stay close to him and hug him, and then when he goes to phase 2, you just melt him, right? So that was pretty straightforward. I'm doing pretty good damage. So now all I got to do is stay away from all the bad guys, and well, that's always the trick, right? But I'm definitely out DPSing pretty much any problem in the game right now. So we do a lot of single target DPS right now. So it's really good. We also do damage to the guys behind them and the guys behind the guys behind them, right? So We're doing a lot of damage right now. So it's good. There is we saw DLCs coming out for this game, so it's gonna be kind of funny. The DLCs coming out. But yeah, we're just going through, guys. We're going through all the lab book, and the book is finished. Right, I've officially called it done as of last night. So if anybody was waiting to get the book, then you know you can pick it up. Oh, look, another one of these. More crit, more. What's going on here? More crit, more range. All right, we'll take. Normally I'd take more damage, but we're kind of low on hit points. Yeah, we'll take more damage. Screw it. All right. We want a bandana for more piercing. We want more damage. We'll take armor. That's fine. And then, what's our speed doing? Are we still up on speed? No. We won't hold on to that. Got 2 more levels before the boss. 2 more levels before the boss. And Rodom, thanks for letting people know about the book. Also, did I fix that? Yeah, I'm on the 7th book of the Deathgate cycle. I could probably finish that. I could have finished that this weekend. However, I'm trying to spend a lot of time streaming this weekend. Mainly just because, you know, I want more people down in our Discord. Our Discord is at about 1,050 people. So we're doing pretty good on that. We got a lot of engineers and architects down there. Lots of security-minded people talking shop, doing whatever they're doing. You know, we got some good community down there of engineers that are looking to help each other. People are looking for work. There's a few people that are looking for work. There's people that are trying to hire people. There's a pretty good little community, I think. So we welcome anybody that wants to learn Linux. And specifically people that want to do it professionally, right? Like the goal of this group is to get you guys doing this stuff professionally, because honestly, you guys can do it, right? There's nothing that says you can't do this. Yeah, I think we're the best Linux community. I'm gonna take ranged. I always take the bunny because that was weird. Wonder if it's storming in Phoenix. Hold on here. Is storming here? It does say rain starting in an hour. Hold on a second, guys. I gotta look on my little. Hold on a second here. It might rain. I did not think it was gonna rain today. Of course, I haven't been outside all day either, so there's that. Oh, guys, you know what I didn't even tell you about? I don't know if any of you guys are veterans or anybody here is interested in military stuff, but my brother, I'm very proud of my brother. He was on, go here, again, guys, I am not going to tell you I know what's going on Discord when I pull it up, but we should be in streamer mode, so I don't know why it's showing people's full names. But anyways, off topic here, my brother was on, there's a kind of popular podcast in Phoenix called Mike Broomhead. I don't really listen to him because I don't really do podcasts or anything. But my brother was on there today. My brother's Sergeant First Class Steve Champagne, and he's from the Arizona National Guard. My older brother is yeah. There's Robodom. My older brother was on there today. So it's like a little 9-minute little excerpt of the podcast. But he was telling people about how you can do a lot of people, and I never once thought about this in all my life. I was in the Army. But I never thought about the National Guard as like, not service, right? Like, because everybody calls it being in the service, but National Guard really is kind of a way to like, let's say without being cheesy, like serve your community. In that, before National Guard do anything else, they're almost always deployed locally. My brother Steve has been deployed down to the border. He's been on the border mission before here in Arizona. My brother Tommy was on the border mission for a year back in 2010 or something. Man, that's really loud out there. I wonder if I don't know, maybe it's thunderstorming out there, but I'll go check it here in a little bit. Me and Ranger will go outside. All right, let's take that. I kind of want the more hit points. Let's see. Put me in that crap. We'll take the piercing, and we'll take the flag just because it'll make less enemies. All right, one more wave, and then we got the final bosses, right? So people can win their points or not. And as long as I don't throw, but I never throw in Brotato. I never throw. I'm always serious, super serious. Like Grandpa Rick, super serious. Gonna be super serious. And then he goes, "Oh, the guy who makes ghost trains wanted to use a ghost train." They say Alan, the guy that makes ghost trains, wants to make a ghost train. Pretty funny. If you guys have never seen the Rick and Morty with the oh, what the hell were they? It was World Ender was the bad guy, and then the why do I keep wanting to say Bionicles? That's not who they were. They were the what was the name of those guys? Somebody knows. And he ends up killing all of them. The Vindicators. That's exactly it, Robodom. Yeah, I haven't seen that in a while. Maybe I need to go watch that one. God, I was so mad at season 7. I can't. I'm never gonna watch season 7 ever again. Like 6 almost pushed me off the show. 7, I'm done with 7. I will never rewatch anything from 7. But all the way up through like 5, I love the first like 3 seasons of that show. Take more attack speed. We'll take more. Just take more speed in general, and then we'll take this. Take all that tasty stuff. Get another laser gun. It's even better, and that's fine. And now we're on the final wave. Oh, look at that. We want all that for later. Now we got to do the same thing, and then we'll see if we win the whole thing. So, all right. The rule is always to get to spinning. You always got to get to spinning around. Oh, that's not good. Get to spin around the guys quickly. See if you can kill one of them. Always killing. All right. That's the level. That guy's dead. So now all we got to do is finish, and then we've technically won at this point. But the game, if you choose to go to endless mode, will allow you to finish the level because then you're collecting more things. And then we'll see. Then we'll gamble on if I'm going to beat level 30. Although I will tell you, with the damage I'm doing, I will easily beat level 30 if I get 1 or 2 other good items that I need. So I'm melting everything. So. And these weapons scale ridiculously, so I have a good chance of being able to scale at least through level 40. So, yeah, the Vindicators was funny. And he's like, we're doing Vindicators too! And then he finds out that they had done a Vindicators in between. That was pretty funny. We want all that. That's going to make all these things more damage. And we'll just combine things and then go. And we want this, and we want this, and... We'll take the gentle aliens because we want more enemies now, so we get more economy, right? Like get more things. And let's kill. We're killing, but we don't have the. Oh yeah, there's like a thunderstorm rolling in, guys. That's loud. It keeps sounding like my neighbors next door are like dragging their trash cans in, but they live pretty. I mean, they're pretty far over, and I shouldn't hear that. But it's definitely more of like a thunderstorm starting. So nice. That works for me. But yeah, my brother was on the Mike Broomhead show or whatever today, and that was kind of cool. I got to listen to him go in there and talk about that. And then it's funny, he gave his phone number out, and the guy's like, "You're pretty brave giving your phone number out over the phone or over the radio." And he's like, "Yeah, the worst thing they could do is have to block them." You know, he's like, "That's the worst thing." He's like, "But maybe they want to talk about joining the National Guard." And I'm like, I was sitting there thinking, that's the kind of commitment. He's the #1 recruiter in Arizona State right now. My older brother is, so he's been recruiting for a while, and he puts a lot of people in, and he might even win. There's like this for the Western region. He might even win like some like I don't know. He gets trips. He gets like a trip every year out to Hawaii just from the National Guard stuff that he does. It's really cool. He gets some pretty good stuff. So I'm pretty glad. All right, there. Can't buy that yet. We'll take this. We don't buy this, but if we find it, we always take it because it's unique. And unique things are, you always take the unique things, guys, because then they don't show up ever again. All right, we got 2 guys to kill, two bosses. These ones are reasonable. Again, this first one is one that I've been killing since the game first came out. Well, they didn't have bosses when the game first came out. The new bosses here, they came in one of the patches, but that one's dead now. So, all right, so we beat those guys. I played that one a little looser than I should have. I should have just beaten that guy. But you'll also notice that after level 20, the bosses no longer always give you a red, which is kind of shitty, but it's fine. It keeps the game scale, I guess, in some kind of reasonable scaling here. But I do not have any of the really good items I want. I don't have a ring or the vigilante ring. I don't have a the main item I want right now is called the anvil. The anvil's like the number one thing I could have right now, but don't have that. I have some decent reds, but I don't have like any epic items to really get far. But oh, by the way, so we gotta finish that. Hold on. Manage prediction, choose outcome. I did beat round 20 of Brotato, but now I'm gonna let you guys predict. Will I beat round 30 of Brotato? So will I beat round 30? You guys got 5 minutes to do that prediction. And I don't want the chameleon. I do want the tentacle. I'll take the baby gecko. I don't want the lemonade. I want maximum damage. Mammoth is terrible for this guy because it's melee damage. Good for a guy that does melee though. These are really good if I'm playing a luck build. I have a lot of luck, so I probably should start specking luck. Yeah, that's probably good. And then we want damage. That's huge. All right, we should be we should have a chance of getting to 30. So you guys can vote, right? And voting right now would be good because you could vote after if I die. But I should make it here pretty all right. I will wait before the next bosses though, in case the voting isn't done. But I'm doing ridiculous damage right now. Hitting for 300s right now, pretty decent. I'm hitting for 400s on some of my crits. That's pretty good. Yeah. High 400s. Probably be hitting for 500s because I think this guy. Yeah, I have a beard, so yeah, or wisdom, and that causes me to hit way harder. So we're almost hitting for 500s right now. So 512 there. And we're hitting, so every 5 seconds it goes up. Right? That's just going to keep going up all the way until we get to. I want to run into those things. Those things will end my night. Alright, there we go. Alright. Regen. We want damage, but we also want more range, so we'll take range. And then we'll take. This is the boss on this one. So we will take more damage. And we'll take more luck and harvesting, and then we'll hold on to that. And focus is really good because you get plus 30 damage, but for every different weapon you have minus 6 attack speed. But we have almost all the same weapons, minus 1, so we only lose minus 6, so we definitely want focus. And then we also want a better laser gun. That'll go stack with one of the other ones somewhere. So, good. Alright. Oh, I said I'd wait before the bosses. You guys can vote. Oh, 30 versus 30? That's pretty fair. Pretty fair little voting. $30 to 30. Somebody else needs to want to get in there, right? Somebody else wants to get in the things, all the things. What we got going on here, guys? Well, I'm gonna wait a minute before we do that. What are you guys talking about over here on? A lot of stuff going on in Discord. Are people going down there? Alright. Yeah, that's the whole reason I do this, guys, is to get you guys in there. You know, I'm out here just saying, come on, there's a bunch of people that want to do Linux and teach you the craft, and they don't even want to charge you anything. Unless you buy the book. The book's the only thing that costs anything. Everything else around here is free. Even hanging out here is free. Well, I guess you gotta watch ads, but other than that, other than watching ads, which I think you're on right now, so... God, that it's. I wonder if I'm about to get like hit with a serious storm here, real quick. Hold on. So I'm looking at. Let's see. See the full forecast. I'm pulling this up in. This isn't my normal browser, but I'm pulling it up in that browser. Phoenix, and I'm up here in Phoenix by this lightning. I'm around the 101 here. This over here is where the Cardinal Stadium is. Feels like 61 because of probably the wind, and we've got a significant storm coming in. By the way, have you guys ever heard this? Here's a fun fact. So the 10-day forecast tonight's going to get down to 58. That's pretty cold. There's an 81% chance of thunderstorms. Or thunderstorms, but there's an 81% chance of rain. Does anybody know what that means? Have any of you ever heard what that means when there's a 81% like that. Has anybody ever seen what that is? Or go look it up. Feel free to look it up. It's a really interesting thing. What does it mean when they say there's an 81% chance of precipitation? Anybody know what that means? It's an interesting thing that means from like a data science guy. Anybody here, like, I'm an amateur data science guy, right? I pretend to be a data science guy, but I'm just a systems engineer, right? But 81% means something in weather forecasting, and it does not mean what you think. It's not that live coding, but it's a no, Rognum, it's not. That's what I grew up my whole life thinking, that it's 81% chance that there's going to be rain. That's not what it means. There is a 100% chance that there's going to be rain, and it should cover about 81% of the area that it's in. So, of this area here, this saying 81% is a prediction that there will be rain, but only 81% of you listening, or 81% of the area will be covered by rain. But that's a prediction. When there's any prediction on a weather forecast, it is predicting that there will be rain, but that's the coverage of the area. And you can go look that up. That's super wild. Yeah, I would have never in all the way. I thought that was there's an 81% chance that there's going to be rain here. But it does kind of mean that, because they're predicting 100% chance of rain. But it means that, yeah, 81% of the area, or it's almost like when you sit down at a slot machine, there's no actual gambling going on at a slot machine. I don't know if you guys know that. My uncle used to run a gambling, they used to build slot machines out here in Phoenix and fix them. There's no actually gambling with a machine. They pay out a certain amount. The only gambling you do in a casino is where you sit. I don't know if you guys know that. That's true. Those machines are set to pay out anywhere between like 88 and like 92% as per whatever the rules are. If they didn't have rules that they had to pay out, those things wouldn't pay out at all. If you guys didn't know that, that is 100% true, and I'm not making that up. My uncle used to run a company out here in Phoenix called the One Arm Gambler, and they sold stuff all over the state. Anyways, all right, let's go do this. Did you guys all vote that wanted to? Looks like you did. 50 and 50. You guys voted like for the most nothing burger anywhere. Okay, all right, let's go. Kill him. Melt him. I'm not even playing with that guy. Dead. Alright, this guy's dead too. Get out of here. Hit him with the big one. Yep. You can mutate all you want. I'm going to kill you. There you go. Boom. I'm pretty sure I'm going to melt everything up to like level 35. And then it's a really steep. It gets really steep. And if you hit 40, I mean, things are hitting you for about 500 at that point. So I don't have nearly enough hit points to make it there. I can get a bunch of tardigrades if I could find them, but I haven't found any yet. I could get a lot of armor, but things will still hit me really hard. But the game's about to start scaling out of control really soon. But I should be able to make it to 30, barring anything really stupid happening. But then again, I said that last time, didn't I? But we'll see. I do kind of hate that I still got to go pick stuff up. It's nice to get that little relic, so I don't have to pick things up anymore. I don't have to wander. I can just hang out in the corner, you know. So I've never heard of prescribed fire. What is that? Gambling token. More damage. More crit. And we'll take that, because our regen is okay. And we'll take that, and we'll take that. Alright, we're going to save everything. But we would really like... We have a couple geckos, so some of the stuff's flying at us. But I think we just have 2 geckos, so there's a 40% chance that things are going to fly at us. Prescribed fire. Hold on. Oh wait, I gotta pay attention. Sorry, I was reading chat. I almost died. No reading chat while I'm playing a betting game. Although you guys only bet 30 points, so that's basically nothing. That's basically not even worth. I mean, we've already talked more than 30 points worth of time. So see those little annoying guys starting to pop up, but they're not really problematic yet. Plus, I'm doing a very high amount of damage right now. I'm probably in the top 99th percentile of damage ever done by one of my characters. Oh, see that was one hit. That was one hit right there. Took nearly all of my hit points. All right, I gotta play smart. I can't mess around. Last dev job we had to account for the cause of the project we were on. Interesting. Prescribed fire. Interesting. All right, this is huge. Your projectiles gain a bounce, so now they're gonna bounce off of somebody, but you lose 25% damage. Still worth it. And then you take more damage so that it's worth it even more. Then you take more damage, and then we'll take the little kitty cat, just because it's useful. And now we're gonna get more obliterators, and we'll get more community support. So the more enemies that are on the screen, the more damage we do. That's huge. And then, yeah, we're good. So we'll hold on, and all you gotta do is stay alive. Stay away from everybody, and get better guns, and then. I do need a better plan for staying alive. I need some of these other things, but that's fine. The goal, keep the screen as clear as possible, and just keep marking everything. Don't die. Alright. Beating the whole game, guys. That's the rule. We've already won. In fact, when we die, it'll say, when I die here, it'll say we won. So that's a thing. Alright. Boom, 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 boom. Killing everything. Because we've already beaten the game proper. Now we're just going for high score fun. Just memeing right now. Right. Oh, that would have killed me. One hit. Any of those charges will kill me one hit. So I can't play around with that stuff. I'll take damage and lifesteal over engineering because I don't care about engineering, and we'll take luck. And this is hard. They're making it hard because I can get another bounce, so it would bounce even one more time, or I can get an obliterator this turn. So I think I'm going to take another obliterator, and then I think I'm going to hold on to all these because all these things are huge. And well, no, we won't hold on to that. We'll buy a laser gun. Because now we'll have another laser gun, and then now all we got to do is survive against two monsters, and we could stay far away from these bosses. We don't have to be anywhere near them, because the ricochets are going to hit them from everywhere else on the map. I don't even want to be anywhere near those guys, because any one of those kills me. Oh, there you go. Didn't beat 30, guys, but we won. All right, we're winners. All right. So choose outcome. Did I beat round 30 of Brotato? No. Choose prediction. Alright. Let's get Brotato out of the way. Let's do some SSH stuff. And actually, I kind of think I might want to eat first. So, what I thought about doing here is, what if... Brotato out of the way. What if, for my break, so if people want to do Linux still, or if people want to do networking and system stuff first, what I'm going to do, and this will be a nice little break for me, but we're going to leave all this stuff up. And I'm going to take this down in the background, so there won't be any of that chat. But what I'm going to do is I'm going to pull up a video that I have, right? I'm still going to be sitting here. I'm going to be munching here. But what I'm going to do is, do I have this in here? Recordings. Let me ask you guys this. I'm going to do a poll for you guys. And here's the new poll. What video do we watch? The video's me, right? So I'm not giving you guys anything else. We can watch HPC topics. Oops. HPC topics. Or we can watch networking. Those are our two options. I'm going to give you guys 5 minutes to decide there. Right? So there's a poll going. You guys should be able to... I'll put myself back on here for a minute. You guys can decide what we're going to do. We're going to watch a little video. I'm just going to stay on. I'm just going to be hanging out. But I'll be sitting here. You'll even be able to see me, but it'll be a recording of me. If you type anything to me while I'm munching here and eating, I will answer you. Right? I'll sit here. Maybe I'll even talk, pause the video, whatever. But we'll watch the video for a little bit. Is that fair? So it'll be a video that I put together for you guys, and we can do whatever stuff you guys want. And I will even add to it and type things in kind of as we go. Can we do Bill Dance blooper? I don't even know what Bill Dance bloopers are. Is that a... So, you know what's weird about that? By the way, Fisherman. I like, what's the rule on that? Like, I see streamers, like, they'll be like, oh, I'm gonna eat, so they'll do, like, they'll watch food videos on YouTube, but is that something people really do? Well, I think that would be funny, but, like, I watch guys like Baru does it, and there must not be any rule against it, but it just seems really weird to me to watch somebody else's video on your stream, but apparently that's not against rules. It seems to me like you wouldn't do that. I don't know. I don't know. I bet he has some really good blue. Is he like the guy? Is he like how Tim the Toolman Taylor was? Some of you guys know Home Improvement was a show back in the 90s, and there was this fake character that Tim Allen played. So Tim Allen played a character, and I forget his name, Tim the Toolman, I guess, and he played a character in a show, and that character was absolutely stupid. Like, that guy would mess stuff up and turn on chainsaws and do all kinds of stuff, and his buddy was like kind of like a Bob Vila ripoff, and his buddy was the guy that was always doing all the work well and not. It was funny. It was a pretty good show. Very fun. Anyways, all right. So you guys vote. You guys are voting on what we're doing next. You got about 2.5 minutes left on the voting, and then I'll go off the stream here, and then but I'm gonna be here. I'm gonna go down and get food and eat, and then you guys can kind of hang out and do that stuff. So you guys can do. I mean, you guys can put points to it. We got HPC topics or networking primer. Those are the two that I have recorded here, and I hope the sound is pretty good. I think the sound should be pretty good for you guys. But also, while we're doing that, I will check my college stuff, which again, I told you guys, this is amazing. We're in the week 6 right now, and it started Wednesday, Thursday. This is Friday. Nobody's made a topic discussion post but me. I've literally never seen this before in any college class ever. Like, I feel like I'm in Bizarro world. Like, there's no discussions. I have nobody to respond to if I wanted to right now. It's super weird. So I'm checking my college stuff out. I'm also checking out my NOAA email on one of my other screens. Check out what kind of good stuff's going on. By the way, guys, there's so much good stuff at NOAA Library. God, the NOAA Central Library. I've shown this stuff to you guys before, I think. But if you've never been in the library here, there's a tremendous amount of stuff that they have available for you to get into high performance compute stuff. If you want to, like you might even say, Scott, you know what? That's cool, but like data science is fun. But I want to go do financial stuff. And I said, that's fine, but maybe you want to be a financial guy. But did you know that there's a lot of ways to go learn about stuff, build portfolios, fun stuff in here to work on that then you could turn into a, maybe use that to get job prospects. Maybe you have no. What the heck was that? Hold on a second, guys. That was super weird. I will be right back. Ranger's not alerting. Give me a second, guys. That was like a really loud noise. And it almost sounded like somebody triggered it. Alright, that was super weird. So, I am home alone. My son is not here and my wife is not here. And that sounded like, if you've ever seen somebody like push a fire alarm, like have you ever done like the test and it does like a real loud ring? I've never heard that sound before in my house. It looks like networking primer 1. Okay, that was weird. So, I got 16 of my closest friends sitting next to me now. So, just in case anything weird's going on around here. And I was watching, so you guys ever seen this? So I've been watching a bunch of this show called Law and Order SVU. And Ice-T is on it, and he's absolutely hilarious on this show. Because he's like trying to be all serious. Well, Fisherman, I've never heard that sound though. That sounded like somebody was pushing it. Yeah, I've never heard that before. That was weird. That was creepy. I'm here by myself, and there's a thunderstorm coming in. So I got a room full of dolls right behind me here. This whole wall that I have, my wife has her doll room in there. I should go close that door. Those things are creepy. If you guys see any dolls walking down here, let me know, because fuck, that's it, man. I only have 16 of my best friends sitting here next to me. I can't show you on stream because it'll trigger some people. But anyways, I got a bunch of my friends, and there's yeah, it's weird. This is the beginning of one of those real life ghost stories. Anyways, in this, so I had to tell you guys about the Law and Order SVU because me and my wife have been laughing about Ice-T, and Ice-T was in the army and he did all this shit. But the funny thing about the guy is he's got this show that's like 15 years old with him and his wife. And in one of the shows, he's talking about bringing his gun. Yeah, he was talking about bringing his gun to go deal with ghosts. And she's like, what are you going to do? You can't shoot a ghost. And he's like, I could try. And it's just funny, like, hearing Ice-T talk with his wife about killing ghosts at a haunted thing. And she's like, what was weird about the place? And he's like, you about to find out because I'm taking you there. So he was taking her to this haunted-ass mansion. And I didn't get to see the episode. I haven't seen the show ever. But me and the wife are probably going to watch it because it looks funny as shit. Especially considering that, like, he plays a serious detective, and he has songs that are, like, the most ridiculous shit about cops and stuff, right? So it's kind of funny that he ends up playing a cop for literally, like, 25 years on a show. I think that show's still running, by the way, Law & Order, SVU. All right, you guys picked what you picked, so here's what we get. We are going to run the networking primer. Let's see. Look at that. It looks just like you guys are actually watching me. All right, I'm going to turn myself off here. Drop that over as well into the stream. Can you guys hear that? I'm just going to put it like this. That's fine. You guys can see me. That'll be fun. All right. That is not me. That stuff out of the way. You guys should be able to hear me. Rotom, give me a thumbs up if you can still hear me over there. Hold on. Hear me? Hold on. Let me see if I can bring you guys through with Windows Media Player. Hold on. I have. Hold on. This is me. No, Rotom. This is me talking now, but you guys are not hearing me. Yeah, I got to add it as a source. Hold on real quick. I actually have it as a source. I need to go make sure its properties are towards that Windows Media Player. So let's make sure it's device. Desktop audio is muted. Microphone Yeti, there. It's a little bit low. Let's turn that on. Okay. Let's see. Let's try this again. And okay, good. Oh, you guys should be able to play sounds too in Discord. You guys know how to do the sounds right at the bottom. You got the little. Did that work? Was that better? It doesn't look like that sound's coming through that way. Hold on. I definitely have a Windows Media Player as a source, but it doesn't look like it's finding. Yeah, hold on. Doesn't look like it's finding that when I set it as a musical. Yeah, Windows Media Player. It's there. Use timestamps, auto monitoring, mute output, monitor and output, and then. Nope. Still not working. All right. Hold on. Properties. See the properties right here. Look, properties, and the default monitor off. Like I don't need to hear it. And then if I play it here, it should show up. I'm pretty sure that's gonna come through on the. Okay. Yeah, I don't know. You need a thicker string with your tin can. Yeah. Well, I can see. In the thing here, I got a Windows Media Player here, and then the device. I don't even know what the device would be. I guess it could be any of these. And then when I go to run it, I should see that playing through. The live stream too. I don't see that playing through. Shit. Alright, we're disabling performance mode. What the hell is this? I used to have those fucking speakers, guys. I used to have those exact speakers right there back in the day. Alright. So my Yeti microphone is working, and my Streamlabs music, my Windows Media Player is not working. So let me remove this, and let me make a new source. Wait a minute. Nope, that's not how we do it. Go up here. New. Hold on, guys. We'll get it. We don't want Windows capture. We don't want any of that crap. We don't want any of that garbage. We need audio output capture. Okay. Audio output capture, I believe, is what we want. So then Windows Media Player is the one that we want to use. And then Windows Media Player is here. Properties. There's our Windows Media Player, which can use any of this bullshit here. Let's play it. So yeah, you guys want to... Whoa! Don't want that. That worked, but I want it only monitor off. There we go. Sorry guys. Did I melt everybody's head? Tell me if this sounds better. Put any of that stuff up you can. Alright. People online are probably like, what the hell is this guy talking about? We've got Discord. We're in there talking shop. And we are doing the professional Linux users group. This is like kind of our normal meeting time. But I'm also going to show it on here for people on Twitch that just refuse to get on Discord. I think you guys can hear that, right? So if you guys want to troll me on Discord with claps and duck sounds and stuff, you guys can certainly do that. Also, made even funnier by the fact that I really can't see my Discord right now on my monitors that I have up. So that's kind of funny. That'll be for my jokes when my jokes don't land. All right, one more minute and we'll get going. And again, this isn't, like, I don't really save these VODs off anywhere. So if anybody is interested in this, I'll do a more closed down version and I'll record it and put it up somewhere, kind of like I did with the high performance compute stuff. So that'll be something available to you guys that want that. All right, give it about 20 something more seconds. I'll go check on Discord in case anybody's got any things. Yeah, now you guys got all the sounds. I really thought there was a womp womp. That'll be for when my jokes don't land. How's that? And I don't know if you guys can hear that back in through Twitch, but that's funny. All right. And then after this, in the Phoenix area, we're doing a meetup. Not a meetup. It's not a real meetup, but it's we're going to be doing a like a game night tonight. So some of my friends that are more gamers are going to come over. We're going to do some gaming. And if not too many people show up, we're just going to go to a game store and look at retro games and stuff. And for you guys that know me, I have quite a few, like probably an unhealthy amount of board games and stuff. Some of you guys have seen the pictures of my board game wall at home. And wait a minute, there's a question from Fisherman about so to play those sounds, if we were down in Discord. Wait, hold on. Do you want me to have those sounds for this, Fisherman? Because what you have to do, you got to be in Discord. Oh man, guys, that storm is coming. That storm is hitting hard right now. But anyways, you got to be down here, and you go to in Linux chat, and then you play them right here. So if I was in here and you were in here, which for this I was in there, you would be able to play them over the stream. So that's what had happened. Oh, storm's coming big time. Big time. All right, I'm gonna keep playing this. Hold on. Tell me if this is too loud right here. In my board game room, and the wife built the shelves for that. Her and her dad put together some really nice shelves. All right, well, let's get to it. I don't want to burn up too much time. Normally, the first few minutes of the Professional Linux Users Group that meets on Saturdays, we would kind of just talk around and see what's going on. We'll skip that today because everybody's here for the networking primer. I'm just going to kind of brain dump for a few hours on stuff around networking. I'm going to pull up some stuff. We're going to be looking at Wireshark. So we'll be looking at stuff in here. We'll be looking at stuff inside of an actual Linux system, right? We could also look inside of Windows systems too if we want to, but you know, anything networking is going to be on the table for today. All right. Here's some quotes to get you interested. If you already weren't interested, let me tell you why I think you should be interested, right? So I get that not everybody wants to be a network engineer. A little funny story about me. I didn't want to be a network engineer. I got my CCNA when I was still in the Army. I got out. I was a network engineer for 2 years. Almost 3 years. I moved up. I was a LAN tech, and then I became a LAN 2, and I was in charge of the firewall and wireless for a pretty good sized school district here in Phoenix. And I just didn't love it. Like, I was like, this is okay. And then I did some networking and monitoring over at GoDaddy, and then I really got into Linux, right? I've been heavily into Linux for like 20 years now. So, but that being said, no matter what you do, every device you have touches a network. So the idea that the network should always just be a cloud that we don't understand doesn't really sit well with me as an engineer. Like, I think we should understand, you know, any sufficiently advanced technology is indistinguishable from magic. We should not think of everything happening magically. We should have a way to go and understand it, okay? So we'll talk about the types of computer problems, right? This is just some XKCD jokes. I think XKCD is great for engineers to reference because they have some really good stuff. And we're going to talk about, you know, why do you want to know these individual pieces? Well, there's a lot of good kind of engineering knowledge that will help you troubleshoot things. It'll help you in your, I guess, probably ability to just kind of grasp what's happening in a network and stuff like that. And it'll greatly help you to resolve issues in a system. So let's just say those are the reasons that I think that you should be interested in this. All right, so here's the topics today. We're going to talk about the simple communication model. We're going to do a lot with networking. There will be a whole lot of stuff with networking. We'll talk about the 3 types of addresses that we use. We'll talk about how and why we subnet. I'm going to do some decimal to binary conversions, stuff that may seem a little basic and simple, but it's important. Not everybody sat through a class and learned it, so we got to learn it. I'm also going to point out while we're doing that I don't expect everybody to be an expert in that right away. It takes time to learn some of that stuff, okay? And then we'll do OSI stuff. OSI is the model that most of us use to go through and think about everything in networking. So I'll try to fit most things to the model. Not all things will be part of the model, but we'll talk about what happens at each of the pieces. We'll talk about, you know, heavily on these bottom 3, the bottom 4 rather, and then a little less physical because I decided not to go as far into data transmission as I was going to, but if any of you are interested in that and want to talk about that later, we can. And then presentation and session we'll kind of gloss over because there's not so much in there. In fact, the top 3 aren't as important, but the top one kind of becomes important again as we talk about some of the communications and security standards. So we'll get into that. Learning AWS, think I could cruise into DevOps and network. Yeah, networking's huge. So hopefully this gives you guys a good foundation and gives you a place to go. All right, so here's our course objectives. If you're just like, hey, you know, Scott's sitting here talking, he's got his Linux group on. I think you guys can, somebody make some noise for me. I think you guys got some sounds you can push. Anybody that's on our Discord can jump down in there and play the sounds if you want to and talk on there. There you go, clapping and all that good stuff. These are the things I want you to know. You don't have to know everything, right? It says right down here, this is not about becoming an expert. Even if I thought you could, even if I thought I was capable of teaching most people this, I don't think I could make anybody an expert in 2 hours even if I wanted to. This is kind of like a survey. This is high level stuff. It's the buckets that the things fall in, and hopefully it's a time for you to ask me questions because I've been using this stuff a long time, so hopefully this stuff kind of makes sense for you guys. And we're approaching 100 students in our thing over the last, I think I've probably had that open for about a month. So we'll describe the components of computer networking. We should know at the very base level, like the different pieces that go into each of it. Understand why we subnet larger networks into smaller ones. You've probably heard a lot about subnetting. You've probably heard about fixed length and variable length subnet masking. Maybe you've just heard those terms. Maybe at work you have an IP address manager, like an IPAM system, but maybe you're too scared to get in there and you just let the network team give you an IP address range and then you just hope that your stuff's in the network range. We'll talk about why we subnet things and why those things work the way they do, and then we'll just kind of talk about that. We'll talk about the flow of data through a network, this is kind of important. The data flows down, across, and back up through the stack on two different hosts. Also in between there, it's also flowing up to each of the layers of the devices, but we don't need to worry about that for now. And then I want you to know that at each layer, the device talks across to the other layer in a way that it understands, almost like we're addressing an envelope or something. So there's a term that goes with that called protocol data units, or protocol data units, I don't care how you want to say that, at each layer of the OSI model. I want you to understand what those are and what the implications of them are, and we'll look at them technically as far as the headers and the footers that are applied as we talk about each of those, all right? And then we'll understand the term modularity and how it applies to the model. If we understand modularity and we understand the model, then we know what we can change and what we can't change. With modularity, if it's kind of like it's back to that idea of magic, right? Where's he at? I don't know how to work magic, but I do know how to work engineering. And once I understand a thing, I know how I can change the components if they're modular components. So that's some of the things that we'll kind of get into here. Again, out of scope. This is not expected to, this is not designed to make anybody an expert. It's designed to help you figure this stuff out. If anybody wants to join our Discord, you guys are welcome to go down there. Here's our Discord link. And by the way, people on Discord, if you guys want to ask me a question, you can. I don't mind, as long as you don't mind being on stream here talking. Just interrupt, because guys, I've been teaching for 15 years. I know that I move fast. I know that when I start brain dumping, it goes fast. So if there's something you want to know more about, just stop. Okay? All right. So let's go. Here's the basic thing. Some of you might have even been on stream earlier. I was talking about the simple communication model. The most simple thing that can happen for communication to occur always has 5 components. There's no simpler model known to man that has less than these 5 pieces. These 5 pieces are always there if communication is happening. And there's no simpler form of this that is an effective type of communication. So we have a sender, a receiver, a message, a medium, and noise. Those 5 things always happen. The sender encodes using a protocol. The term protocol means the rules that govern communication. That's all it means. It's a simple term that extrapolates out into the rules that govern communication. So if you hear me say protocol or you hear somebody else say protocol, they're using it as like a wrapper around the way that communication happens. So if you've ever heard that term and just been like, man, why does everybody talk about the protocols? That's what it is. It's the rules that govern communication. We have the sender. It's going to encode a packet by some protocol to be transmitted across a medium. Right? The medium is either a physical cable in our case with electro or optical signals, or it could be free space. It could be air of some type via some type of radio, electromagnetic wave is what makes a radio, or some type of laser optic wave that typically is line of sight and deals more with environmental factors and that kind of stuff, right? There's a message, again, that's encoded. It's traveling across the medium. And then despite our best efforts in all the world, we will always have noise. There will always be noise, right? If I come down here, there's my stuff. There's my noise. There's always going to be noise in a system. You can't get rid of it. So these 5 pieces are always going to be there. So if we can understand the individual parts and what's going on in here, it's going to help us to do communication. I mentioned this earlier today. There's a 6th one that's required if we're doing what's called effective communication, which is a feedback loop. So something is being sent back to let the sender know that the receiver heard. That's a different concept. The simple communication model is these 5 pieces. They'll always be there. All right. So let's talk about some fundamental terminology. This will be like level setting. Some of these things you're going to see again. Some of these things you're not. But I just want to make sure that everybody understands, because when you look at networking diagrams, people start hitting you with the TX and the RX, and you're like, right? Like what the hell's going on? And when we start looking at packets inside of both Linux and Windows operating systems, which is most all operating systems out there, you're going to see TX and RX. TX is always the sender. So back to my old model, the TX side is always the sending side. It's the transmission side of the communication link. The RX is always the receiving side. Makes me think, I probably should have added simplex, half duplex, and full duplex, but that's fine. We won't worry about that level of lower communication. But there's always a sender and a receiver, right? That's how we talk about them. When we get up into wide area networks and specifically around networks that we don't control, right? We talk about systems in our control as being autonomous systems. And AS is an autonomous system. I control my network at home. You control your networks. The ISPs between us control their networks. That's known as an autonomous system, okay? When we meet with one of those systems, right? That's typically called a wide area network. There's a lot of ways that we can determine what's a LAN and what's a WAN, but one of the best ways in an organization from like a company standpoint in an enterprise is the LAN, the local area network, is something you've bought and you own, and it's a sunk cost and you're just paying to keep the electricity flowing to it. A wide area network is something you lease, typically. It's something you lease and you will never own it. You are always just going to be leasing that circuit from somebody else. Now, that's a very high level determination of those things, but that's a good one that's kind of good to know. All right, now when we talk about the interface from the WAN that we don't control through the LAN that we do control, now we're talking about how do we connect. And typically you'll have some kind of data circuit equipment and data terminal equipment, right? Data circuit equipment is typically on the vendor or the ISP side, right? And it's responsible for the clock rate of the serial line. Yeah, Rodom, you probably should be able to hear in both, but you guys are welcome to go and do this however you want. Okay, yeah, you guys online should be able to hear me. You guys there? Okay, good. All right. I'm just trying to do this, to two audiences, but with different levels of being able to communicate back. DTE is your data terminal equipment. It's typically on your side of the connection. All right. Now, right where any wide area network and local area network, or multiple local area networks or multiple wide area networks come together, between those autonomous systems, there is always a demarcation. The demarcation is the point that ends your responsibility and my responsibility begins, or where my responsibility ends going out and your responsibility begins. If any of you have ever called, this is one of the most maddening experiences any of us will ever experience, but you've called like your internet provider, and they're like, well, I can ping the modem, or I can get to the modem, and you're like, all right, well then it must be on my side. But before all that, they made you turn it on and off like 17 times, and you're like, just tell me what's wrong, Anyway, so but we can't do anything about it. We can't troubleshoot past what is under our control. So we need them to verify that they're at least getting a link to us, right? And then another term that's just a good level set term is a metric is a metric is any unit of measurement used to differentiate a system. So we might say, I'm going to use this metric for I'm going to use the metric of bandwidth to determine which of these links is the best way to get somewhere. And I say, okay, well, I'm going to use the metric of latency. Those are two very valid metrics, but we should know, one, that metric just means a form of measurement, and two, we need to know, like, if we're talking to each other and I'm like, this link is better, and you're arguing that that link is better, but we're using different metrics. This is why, by the way, it's so useless to argue with people online, is because we've never agreed to the fundamentals of how we're going to come to a conclusion, right? Like, I'm going to argue this point, you're going to argue that point, and we're going to do what's called talking past each other, right? It's the same thing with communication, and same thing with working with other engineers. It's good to know what metrics we're using to measure something, because you're gonna find that you can get to solutions faster and better if you decide to work a certain way. All right, so that's some fundamental stuff. No questions on that? All right, we'll keep going. So there's three major types of addresses that we care about. There's three major types of addresses you're going to see in the networking world. There are probably a few others, but the three primary types you're going to see as a systems engineer, as a network engineer, are these right here. At layer 7, you're going to see DNS addressing. Most of us have probably used DNS addressing. Maybe you came to Twitch, maybe you've gone to some code wars or something like that. We got a little code wars battle going on in the Discord, so that's kind of good. But DNS addressing is the mapping of some readable name to an IP address. It can be an IPv4 address or an IPv6 address. We're going to break those down here in a little bit. But it is our way of remembering. I can remember Google real easy. I have a little bit harder time remembering that. I may be able to remember that for a few days, but I can't remember Google and Yahoo and MSN and Twitch and Amazon and all those like that. It just gets to be too much, right? So DNS addressing is the way that we map human readable addressing, right? IP addressing is a logical hierarchical addressing that happens at layer 3 that allows routers to do path determination. Routers do two things: path determination and packet switching. Path determination is based on your IPv4 or your IPv6 address. Routers will make a path determination out of their routing table to where things are going, and if they don't know what to do with a packet, they will send it on to their gateway of last resort, or what's sometimes called a default gateway. However, this is a little fun fact about Cisco that not everybody knows unless you've done a lot of Cisco. If a Cisco device does not know what to do with a packet, it simply drops it on the floor. And you might say, oh, I've never had a Cisco device do that, because you've always set the gateway of last resort, or somebody has set that for you. But I assure you, if you don't have a gateway of last resort or a way for your device to send something to, like, hey, I'm going to phone a friend, I'm going to send this to another device, it will drop it on the floor every time. That's the behavior of Cisco devices. Behavior of most networking devices, but Cisco's kind of painful when it happens, right? And then the one that, you're not going to use much, you're not going to play with this much or see it, but your system sees this all the time, is MAC addressing. So I didn't go too much into IP addressing because we're going to break that up ad nauseum later. But MAC addressing is a hardware address that's burned into the network, burned into the MAC or the NIC of every device that you have. Now, if you've got a virtual machine or you're dealing with something up in the cloud, those MAC addresses can be generated. We can also spoof them very easily, especially with a lot of our wireless devices. We can just change what MAC address it's advertising with. But the thing about MAC addresses is that all of your devices see, within certain rules of how forwarding and broadcasting happens, they see most of the other MACs that are on the same network segment with them. So they see all of that's going on. And they use a tool called ARP, Address Resolution Protocol, to figure out and keep ARP tables, Address Resolution Protocol tables, of what's the mapping of the IP address, or in this case the host name, with the hardware address that is known to it locally. Yep, some people like the please do not throw sausage piece away. When I get to those layers, we'll talk about them a little bit, and then I think as you do more of them, you will probably less use the acronyms, but the acronyms are great when you first start. All right, so those are primary parts of addresses before we dig into we're going to get more into all of these addresses here in a little bit. All right, so let's do a quick binary rundown. If you guys have never done anything with binary, I'm going to show a little bit of this. People that came on earlier when I was kind of like running through this and prepping the last little bit, I did draw this up a little bit. But let's do some binary information around the IPv4 stuff. Like, this is the stuff that a lot of people struggle with, but allow me to give you my 10 to 15 minute primer that I think makes this work the best in my head. I'm just going to draw 3 lines right here, real quick. And on those 3 lines, I'm going to draw some numbers. All right. Now, can anybody tell me what that number is? What does that equal? While you guys think about that, or what that answer might be, I'm going to draw some stuff over here. King Bun said 579. That's true. See if I can count to 10 on stream. All right. Well, what this is a numbering system we've all used many times. You, Moon, that's not wrong, right? It's not wrong. But let's think about something. Some of us probably learned this back in like 6th grade. I'm just going to step you back for a second. I'm just going to step you back to when you were a kid and you learned this. But I'm going to use some technical stuff. And again, it's going to be technical jargon. It's going to sound real pedantic, like I'm overly concerned with the use of words. But we have to get to kind of the heart of this, so we have to use some of these words. So there are 10 states of nature in any one of these. So any one of these positions here can exist between 0 and 9. Does everybody agree with that? In this numbering system, that I am not tricking you in any way. I'm just showing you the numbering system we tend to use, like if we were counting money, has the characters 0 through 9, which is 10 states of nature, meaning that there are 10 possibilities that can exist right here. That is what is called a base 10 numbering system, absolutely. So this is a base 10 numbering system. Now, because we are representing 10 spaces over here, this is 10 to the power of 0. So this is the tens column right here. Sorry, this is the ones column, because anything to the power of 0 is 1. So this is the ones column right here. This next column is 10 to the power of 1, and anything to the power of 1 is itself. So this is the tens column. And right here, this is 10 to the power of 2, so that makes this the hundreds column. Now, earlier when I asked you guys what this number was, what I was looking for is kind of what probably some of you, I mean, probably all of you went like this immediately, is this is actually 5 100s, it is 7 10s, and it is 9 ones. And you did that in your head without even thinking about it. But that's how this numbering system works. Now, we're down here for this because we're dealing in ones and zeros going across a line. The numbers we allow for that are 0 and 1. We only have a 0 or 1. There's only 2 states of nature. There's 2 states. You can only be a 0 or a 1. Those are the only options you have. So if that's the case, now 2 to the power 0 is the ones column, because 2 to the power 0 is 1. 2 to the power, 2 to the power of 1 is itself, so that's a 2's column. 2 to the power of 2 is 4, 2 to the power of 3 is 8. That's where these numbers come from. They're not made up. It wasn't like some guy that just knew math better than all the rest of us said, that's how we'll do binary. All right, so now since we're looking at this, and it's 8-bit, it's called 8-bit, because there's 8 bits to each of these, dotted, decimal. Eight-bit dotted decimal. I know that's hard to read, but 8-bit dotted decimal is what we're looking at here. So each of these represent 8 bits. So we have them all down here. So if I told you that all of these were set to 0, what number do we think we'd have down here? We'd probably have the number 0. And if we were to turn them all on, right? The states and base 10 are the number 0 to 9, well, there are 2. Yeah, that's absolutely right, Yumun. Absolutely. If we were to turn all of these on, there's a little trick we can do here. It's 128 plus 127, because 128 on plus all the numbers before it can only add up to 127. 128 plus 127 is 255. So everything that can be represented in these numbers is 0 to 255, which is, by the way, why you have between 0 and 255 in any of your locations on your IPv4 32-bit, and again, an 8-bit dotted decimal format presentation. So let's look at this real quick. I'm going to do a little bit more with binary around addresses. Let's say 192.160. 192.168. Let's just say like 19 for today. 19 dot, let's go 37. We'll do a fun one. And we'll make this a, we won't worry about the slash to this, but we'll talk about why we need these different things around the page here to help us out. But let's break this 192 that's in a decimal format. It's got a 1, a 9, and a 2 in it over here. How are we going to stuff that down into this? And if you've never done this before, this is the crux of all of it right here. I'm about to show you the absolute crux of how this works. We're going to take that 192 and we're going to ask ourselves, starting from the left, does it have a 128 in it? Can I represent, out of a 192, can we extract out of that, squeeze out of that a 128? And the answer is yes. So we're going to turn that bit on. That's the 128's place. Then if we take 128 away right here, we should have 64 left over. And the next one is the 64's place. Can we get a 64 out of a 64? And the answer is yes. Now we have 0, right? Just put 0 there. Can we get a 32 out of it? No. Can we get a 16? No. Can we get an 8, 4, a 2, or a 1? And the answer in all of those is no, we cannot. So let's do it again. Let's go to 168. Can we squeeze a 128 out of there? Yes. So that's right there, because it's in this section. So then we've got 40 left over. Can we get a 64 out of 40? No. Well, we've got 32. Can we get a 32 out of 40? Yes, with 8 left over. So can we get a 16? No. Can we get an 8 when we had 8 left over? Yes. So we got nothing left, so there's no 4, there's no 2, and there's no 1. Now, if you've never seen that before, that's how that works. Now, I picked this one because it would be a little more challenging. Is there a 128 and 19? No. Is there a 64? No. By the way, if you get lost, that's where I'm picking them from. Is there a 32? No. But there is a 16. But now there's no 8. There was 3 left over. There's no 4. But there is a 2 and there is a 1. So that right there is the digital representation of 19 when you were dealing with 8 bits. Now let's do 37. Let's look at 37 real quick. 37 has no 128s. It has no 64s. It does have a 32 with 5 left over, which means no 16s, no 8s, but there is a 4, which means that we have 1 left. 1 right there. So we just broke 192.168.19.37 down into its binary. Now, there's a few more things we got to talk about that make this kind of mapping that I have here complete, that are going to go into IPv4 addressing a little bit, and hopefully assumes that you have a little bit, right? This isn't a bare beginners type thing, but let's look at this first octet here. There's a 192 in it. To determine what class we're dealing with, there's 5 classes typically. There's a class A, B, and C that you'll see all the time in this world. Then there's a D that you will not see often, and there's an E that you will you'll see D more than E. E will very rarely ever be there. But if I look at this and I tell you that the rule right here in this first octet is that it falls into one of these, can anybody here tell me if this is a class A, a B, or a C network? By looking at this first octet, 192. If it's between 0 and 127, it's a class A. It's 26, but if it's a class B, it's 128 to 191. And then if it's a C, it's 192 to 223 in the first octet. So do we know what class this is? It's class C, right? It's class C address because the first octet is right there. Class C address has 24 networking bits. There's 2 portions to an address. There are the network portion, which in this case is the first 24. So there's 24 network bits. And then in this case, because we didn't give it anything special, there's 8 host bits. Now, there's other bits that we can slide in here later called subnetting bits, but there's none right now. I'm going to show you why we subnet on the next slide, and then I'm going to show you how we do it. But let's just look at this for a second and look at some more of these rules. We've already used this right here, so we're checked on this, and we've used this to determine the network and the host portion, which is left over. But then let's come over here, and I say something about masking. I say that N bits are 1s, subnet bits are 1s, and host bits are 0s. So let's go up here to network bits. All these network bits are 1s for masking. So my mask is down here. There's my IP. Here's my mask. And I go like this, a bunch of 1s, because that's the rule. Network bits become 1s. There's 24 network bits, so here we go. And then I said that host bits become 0s. I don't have any S bits here, so these are out for right now. So there's no host. So in host bits, they're all 0s. Those 0s look like 1s. All right. So there's all 0s. So now we convert. So somebody says, can you take this address and tell me from the default what the subnet mask is? And I say, yes, I can. Didn't we determine earlier that if these were all on, then we would have the number 255? Hey, Johnny man, how's it going? We got 255 right here, so all the bits are on. We've got 255 here. And then we got 255 here. .0. So, if somebody was programming a 192.168.19.0 network into their system, like you were putting it in, like if I went and looked at my Windows stuff right now, or if I were to go program this in as a subnet mask on, let me just close this real quick. If I were to go here and cd to etc sysconfig network -scripts, and then I just more my if cfg-eth0, you would see that it's 192.168.11.245. That's my address here. That's my host address. And my net mask is the same one we just did. 255, 255, 255, 0 with some gateway, right? And then that, when we go look at it, that's exactly what we have here, 255, 255, 255, 0, which means that we have a network, a big network over here of 0 to 255 with usable hosts, and we'll talk about why we can't use the 0 and the 255. It's 1 to 254 are the usable hosts. And you say, why can't you have 0? Well, 0 is the network identifier, so that one gets tossed out. And 255 is the yelling. I want to yell at everybody, and that's going to be that way. All right. So we touched that. We'll do the hosts and the subnets here, these equations, on the next set of slides. But let's go through it. I also left all these so that if you have to do any calculations up here, you don't have to go write them all out. I did the first 16 for you, which will help us with pretty much anything we might want to do. All right, so we understand a quick binary rundown. This was quick. This was about as quick as I could do it, but hopefully that showed you how decimal works, because you've probably used decimal your whole life, and that was easy. But then we compared that to binary, and that probably was real easy to then see. And then we converted between them, and this is a thing that, again, I'm not going to be, I'm not going to be like one of your teachers when you were a kid and say, you're never going to have you're never going to have an IP subnet calculator in the real world, and you're like, I'm always going to have my phone on me, so I'm pretty sure I will. That's not the point. The point is, can you understand these things so that you can pull the proper size network that you need from an IP address management tool? Yeah, there's tools out there that do all this crap for you, but you still have to know what you want, and you still have to know how to ask that. So all right, so that part's done, but don't worry, we're going to come back. So if that was rough in your head, we'll go and we'll come back and we'll do some more of it. All right. So why do we subnet? In that example we just had, we were given a network address of 192.168.1.0. With the /24, that means that the 192.168.1 is the network portion. We cannot change that. That might as well be set in stone, written on granite tablets and given to us. The only thing we're allowed to do is use the 0 to 255 in this last octet. That's the only thing we're allowed to do. They're called octets because there's 8 bits in each. Again, the 0 gets thrown away because it represents the address space. And the 255 gets thrown away because it's how we yell at each other. So I want you to look at this real quick, and then I want you to think, hey, me and 4 other college professors, we want to get in this big room here, and we all want to have our classes. I want to have my class over here, and somebody wants to have their class over here, and somebody over here, and here, and here, and we're going to just be all over in this classroom. And then when I start yelling, everybody hears it. Everybody in my network hears me yelling. Everybody in this classroom. And then when another professor starts yelling, it goes to everybody. In the networking world, we call that the broadcast domain. So we want to carve these broadcast domains down, but we're not dealing with a room that actually exists. We're dealing with a mathematical construct of an address range based on how many bits we can place in those 8, well, in this case, 8 usable hosts that I have, right? So what we can do is we can borrow bits. And when we borrow bits off of this, we're going to take one of these that we had earlier. So these were all host bits. We're going to borrow one, and we're going to turn it into a subnet bit. Basically, we're going to cause it to be hardened down as a network bit that we can no longer change. And then it's going to subdivide our networks that we originally have. And it's going to look like this when it happens. We're going to go to a /25. So we're going to borrow 1 bit. When we borrow that 1 bit, we now have a 0 or a 1 in that far left 128th column from earlier. That's going to cause 2 networks to exist. It's almost like we put one of those big dividers up in one of those like big ballrooms or something. If any of you guys have ever been like in a convention center and they can pull the walls out and split the rooms. And in those rooms, now, in this case, the 0 is the network identifier of the first network. And the 128 is the network identifier of the second room. Then the broadcast, so when I want to yell and talk to everybody, that's the 127 over here in the first room. So I yell with 127 to hit all the hosts in here. And I yell with 255 to hit all the broadcasts of all the hosts in the second network. All right. So that makes the 2 networks exactly half the original size if we borrow 1 bit. But what if we need to carve this room up more? Well, we can actually borrow another bit. Now, once somebody in your organization, I always talk about like some senior architect or some engineer that you don't know carved this all up before you get there, because when you're a junior engineer, you're probably not going to be carving up your network. Somebody else will. But you still have to be able to look at them and go, okay, I have a /26, which means from my original 192.168.1/24 that I've carved up 4 individual networks that are between 0 and 63, 64 to 127, 128 to 191, 192 to 255. When I want to identify these 4 networks, when somebody comes and says, hey, you've got a 192.168.1.0/26, I immediately know somebody carved 2 networks off of it because I know it's a class C, and I know that /24 is what it originally was. Then I can look at that and say, okay, in those columns there was a 00, 01, a 10, and a 11. We'll see that here in a little bit. And that means that 064, 128, and 192 are the 4 network identifiers. Then somebody might say, and what's the broadcast address of all 4 of those? That would be 63, 127, 191, and 255. And then when college professors like to get sneaky, they'll say, what's the usable host range of the 3rd network? That would be 129, so 1 higher than the network, to 190, which is 1 less than the broadcast. That's all it is. And then maybe we borrow 1 more network. What does 1 more network look like? If we borrow 1 more bit, now we have 192.168.1.0/27. So we've got 3 network bits. And yeah, you know what, Quartz, I've been teaching this a long time, and everybody that I show this to says they like it. And that table that I use, by the way, that table's up in the Discord if anybody wants it. I'll also post the individual table if anybody wants it. I think it's the best way to work through and learn these if you want to. All right. So now look, we've got 8 networks. We've borrowed 3 bits. So in those first 3 places, it's 000, 001, 010, 011, 100. I'm not going to go through all of them, but it's 0 through 111, so 0 through 7. And in that case, on the far left. And now this is how it breaks down the networks. So I'm going to take this exact example right here, and I'm going to do this. So I just want anybody that's watching this that wants to learn this and said, hey, I got it a little bit before, but if you show me again, I'll really stick it in my head. I want you to look at this for a second, and I'm going to show you mathematically how we do this. Okay? Is that fair? Is that fair to everybody? Okay. Now I want you to do 2 other things real quick. I want you to look at and see that there's 30 hosts per network. So there's 30 hosts in here and 30 hosts in here. You say, Scott, how do you know that? Well, I can't use 0 and I can't use 31, which would have allowed me 32. So I have 1 to 30. So I want you to remember that. There's 30 hosts per, and I want you to remember that there's 8 rooms. If you guys can remember that, write it down if you want. 8 rooms, 30 hosts per. All right, let's go do this again. And I ask all the questions. This is the exact, there's nothing different between these 2 slides once I explain them to you. Okay, so this one here is how we carved up the room. This is how we're going to do it mathematically, or mathemagically. But remember I said earlier, for people that got here earlier, I said everything is magic until it becomes explained to you, and then you're like, oh, that's it? That's what everybody was all, that's what people get paid a whole bunch of money as network engineers for? Yeah, this is it right here. I'm showing you. This is it. 192.168.1.0/27. Let's play all the game that we did earlier again, just for practice. 192, I'm going to squeeze it down into binary, so I have it in my hand. 128, yep, got that. 64 is left over, yep, got that. There's nothing left, so that's it. That's everything there. And I'm coming down here to look, so we'll do this one the way I normally do. 168 has a 128 in it, yes. There's 40 left over, which is not a 64. But there is a 32 with 8 left over, which is not a 16. But there is an 8 and an 8, so there's that. And then it's 0, 0, 0. All right. 1 is really easy. It's just this one over here. There's no 128s, no 64s, no 32s, no 16s, no 8s, no 4s, no 2s, but there is a 1. And then these are all zeros all the way out, but I'll just leave those empty for now. I know it's a class C, so this is how it was originally broken down. I always draw this first line. That's 24 network bits, 24N. And if I want to right now, I can come over here and say, well, network bits are 1s. So the hardened part of this network that cannot be changed is 192.168.1.0. And the subnet mask that I was given by default was 255.255.255.0. But somebody in my network before I got here borrowed 3 more bits. 1, 2, 3. So I'm going to draw another line like this. It's going to be a dotted line because somebody in my network carved this. Now this is still the 128s, the 64s, and the 32s place. Does everybody agree with that? But now I'm calling these subnet bits. So it's an S bit, an S bit, and an S bit. This is just what we were just looking at a second ago. Now here's our host bits. Host bits are what's left over. Okay? Now, subnet bits get 1s right here, and host bits get 0, so I go 1, 1, 1, 0, 0, 0, 0, 0. Now I got to convert this net mask back, so I got to add 128 plus 64, that's 192, plus 32 is 224. So my subnet mask for this network, somebody might ask you this question, 255, 255, 255, 224. I don't think anybody's ever going to ask you that on the street. I'm just saying, like, mathematically you might get asked this as an engineer one day, right? But now let's look at these subnets real quick. This is where you're going to go, aha, that's where he made those numbers up from. I assure you I did not make these numbers up. I'm about to do them right now, watch. I'm going to count this, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Suffice it to say, there are 8 possibilities there. And look at this real quick. The first one, if I take all the host bits and make them 0, because the host bits will always be 0 in the network address. Let's just count these up real quick. The first network is going to be the 0 network, because everything will be 0. The second network, look at this place right here, is the 32 network. So the first network is 0, the second network is 32, the third network is 64, because it's right there. The fourth network is the 64 plus the 32, so that's the 96. The fifth network is the 128. The sixth network is the 128 plus 32, so the 160, right? Hold on. Then the 110 is the 192 network, and then the last one, which is all of them on, is the 224. I'm going to show you guys something. You're going to think that I have something up my sleeves. Watch this real quick. All those numbers I just said are right there. It's the 0, the 32, the 64, the 96, the 128, the 160, 192, 224. I didn't make that up, guys. I practiced it a lot, but I didn't make it up. Yeah, U-Moon, that is smooth because that's how it works. That's how it works. We're counting on these places here. So if we count, you can think of it like this real quick. You can think of it as I'm counting by 32. That's how some people like to do it. You can do this. Watch. You guys want to see some real magic that'll really fool and piss off? This is your college instructor hates you because of this one trick. I'm going to show you guys the simplest trick in all the world. If all of these bits were on, so let me show you guys. I'm going to break all these networks down. I'm going to write all the network ranges right here. I'm going to say 0 is the first one, right? And then I'm going to turn all those host bits on, and I'm going to say that's 31 because 16 plus 8 plus 4 plus 2 plus 1, if these were all on, would be the broadcast. Does everybody agree with that? Yes. But that's way too much work. I'm like Bender. I don't want to do hard work. So I'm just going to count by 32, and I'm going to say 0, 32. Then I'm going to say 64. And I'm going to go like this each time. And then I'm going to say 96. And then I'm going to go 128. And this is why I'm telling you guys that I'm super lazy. Because now when I get all the way up to the top, I'm going to zipper them back. And I'm going to say, well, if this is 128, one less than that's 127. And if this is 64, that's 96. One less than that is 95. And if this is 32, one less than that's 91. This is 64. So one less than that's 63. And then if we go look at these, if you remember those real quick, and then we go back here and look at them, that was all of these ones. The 31, the 63, the 95, and the 127. It all fits. And again, like, this is well practiced. I've done this for 20, I passed my CCNA 21 years ago, and I've been doing networking for 23 now. But this is how it all works. It's never changed. This IPv4 has been exactly the same the entire time. So let's ask a couple questions. We already know that there's 8 subnets because we can go look and count them. And we already know that there's 30 hosts per subnet because we looked at that earlier. But how can we figure that out mathematically from these numbers that we have here? We started with 24 network bits. Somebody carved up our network. It wasn't us. Somebody did it before we got there. And then we had so many host bits left over. It's always network bits until we subnet, and then there's subnet bits until there's host bits, and then there's host bits all the way up. They will always add up to 32. Why? Because it's an IPv4 address that has 32 bits in that address space. When we get down to the frames later, it's going to make sense that those 32 bits, you say, where are those represented? They're represented right here. So I'm going to go down to them real quick. Right there. There's your source address, 32 bits, and there's your destination address, 32 bits. 32 bits across, we're looking at them right here. 32 bits across, that's them. All right, so how can we use, so I've got some equations over here. Some equations that'll help. 2 to the power of host bits you have, minus 2 is going to give you how many hosts per subnet you have. Now, I told you guys I'd make this easy for you. I've got a table over here. So 2 to the power of 5 is 32. Minus 2, why are we taking 2 off? Because 0 is the network. All zeros in the host bits are the network, and all ones in the host bits are me yelling at everybody with a broadcast. So I take those 2 off, and that defines the 30 usable hosts in that range. So how many hosts per subnet? There's 30 usable. We saw them visibly, and then now we just saw them mathematically, how we count them. And then we can either count these up, 000, 001, 010, and see that there's 8, or we can know that if you've got 2 to the power of 3, 1, 2, 3, you've got the number 8, and that's how many subnets you have. So you can do this visually, or you can do this through equations, which is the way that I prefer to do it. And you might ask, like, Scott, why is this important? This right here will save you a lot of headache. This right here will help you to pass your Net Plus or your CCNA. In your CCNA, they might not ask you to break anything down, but they will show you stuff that will give you problems if you don't understand how to break where the network ended and all that kind of stuff. So, okay. I've hammered that a lot. If you guys want to do that more, let me know in Discord. I used to throw these up like challenges every now and then, and I tell you guys to figure them out and send them back to me. And if you go look in our networking topics, you'll see some of them still. But I will always use this basic template right here for any problem. It's like the movie Gladiator, where he's like, doesn't matter what comes out of that gate, if we stick together, if you stick with this model, it does not matter what IP address range you throw at me and what /subnet mask you give me, I will figure it out every single time. And that's not a challenge, but if anybody has one they want me to work on, I'll work through it and show you. But we'll do that here in a little bit, all right? And there's our Discord if anybody wants to hop down in there. We got people down there. Now, we talked about the OSI model. Let's hit some of the basics of it. There are 7 layers. It compares with the original TCP IP model that the DoD put out, but I think that the OSI model is better for teaching it. That's my mind. There's 2 primary reasons to learn the OSI model. One is to teach it and to learn it. There's this old African saying, what's the best way to eat an elephant? And the answer is 1 bite at a time. So the best way to learn this is to just take each individual little bite and figure it out. So there's 7 layers: application, presentation, session, transport, network, data link, and physical. Physical is 1, application is 7. Generally speaking, from a networking perspective, we don't care much about the top 3, just so you know. Gotta get some. Yeah, move. I appreciate you coming by. Keep working on this stuff. And again, if any of you guys want to work on this and keep this stuff fiery hot, let me know, and I'll give you examples of it on Discord. I can do that every day or every couple days if you want. Up here, we're just dealing with data. This is why a lot of times for us engineers, this isn't super interesting up here. But then when we get down to the transport layer, we take that data that's coming down and we catch it as a segment and apply a header to it. The header is one of either a TCP or a UDP header, generally speaking. There's some other things that can happen, but TCP or UDP are the 2 primary protocols that happen at the transport layer to move data around our network. We're going to get into that here in a little bit. But there's only a header applied at this layer, so we only put it at the front of the data. Then we take all of that. I should draw little lines here. Hold on. Let me get rid of all this, and I really need to show this. All of this becomes the data that goes into a packet, and the packet gets a little header written on the front of it. And that packet is going to be an IP header on the front of all the data. So all this data got squished down into this segment, and then a header was added, right? And then all of this came down and got put in here, and a header was applied. And then down here, we took all of this and squeezed it down into a frame, and we added a header, and only in a frame do we add a trailer, or some people call this a footer. It's not wrong. It's a trailer or a footer that's added. And then those all get broken down into bits as they traverse the physical network to go to the other side. So let's look at that real quick. Here is an OSI model data flow between two systems, right? This is going to be system 1 over here on the left, system 2 over here on the right. And as the data flows down from your application layer down to presentation, we're going to talk about what happens at each of these as I go through all this primer. At the transport layer, we add a header. That header talks directly to the transport layer on the other side. You can think of it as like you're writing a pen pal to your transport layer on the other side. Then the network layer puts an IP address on there, and it adds some other stuff in here that we're going to look at in a little bit. And that talks directly to the network layer on the other side as well. Then it gets packed down into a frame, and that data link, that frame sends over, and that frame is really only understandable by this side over here. So each layer talks directly across to their other layer on the other side. Everything that I show you that we do on one layer, we undo on the other layer to get back to the data that's going to be used higher than the application layer. Okay. Down at the physical layer, we simply send a flow of bits across whatever medium we're going to send it across. Again, medium is the singular of media. There is no such thing as medias unless you're talking about like multiple media, like in a American media or something like that, I guess. But media is already the plural of medium, so you don't have to add an S to it really ever. But okay. We're sending data down, we're sending stuff up. I'm going to demystify all this. Every other bit of this presentation, aside from a couple of things that outlie and stand over multiple, is going to be directly related to this flow. All right? Hey, Twisted Seed, we're doing something down in the Discord, but we're also doing it up here. People in Discord, you guys can send me messages, you can emote. I'm not really reading the Discord chat, so if I miss any of it, I apologize, but feel free to text me or send me your little womp and music, stuff like that. That won't bug me. Actually, I think that'd be funny. But anyways, all right, so we got this. And this is going to be the flow that we look at really for the rest of this. So let's talk about some layer 7 concepts. What's happening at the top layer? Because, again, remember I said earlier, as network engineers, we don't really care about what's going on here as much. This is less interesting to us. However, as systems engineers, we do care about the application layer quite a bit. And then we care about transport network, data link, and physical. Presentation and session, there's not a lot to troubleshoot there, but I'll show you guys what's going on in there, and we'll see how we can see what's going on with it. But that's going to be very, very much glossed over like pretty much everybody does. There are things to consider in these areas, but not so much with us on the engineering side of things. All right, so what's happening at layer 7? Well, at layer 7 we have HTTP. Now, you get a port with HTTP, but ports don't really come in until you're down at the transport layer, so don't worry about that too much. HTTPS is port 443 typically, and DNS is port 53. However, when we get down to the transport layer, we're also going to discuss how they can be TCP or UDP in each of these. So it might be common to think there's 65,536 ports that can be connected to on my system, 0 through 65,535. That's actually not true, because you have to double that, because there's both TCP and UDP designation of those ports. So where like DNS is port 53 and you say, is it TCP or UDP? Well, DNS is one of the few ones that actually operates on both. And by the way, if you want to test that, go to a Kubernetes cluster and only allow one or the other through a network policy. You will break your stuff. Almost swore there, but yeah, you will break your stuff really bad, because it won't work because you need both. All right. Common devices that happen at layer 7 that we care about: web application firewalls, WAFs, reverse proxies, or what are commonly referred to as load balancers. That's real big for us that want to keep like site reliability engineering, and we want to have like 7 devices back here, and we want to abstract that with a reverse proxy. We're going to look at that a little bit. And then next gen firewalls. So web application firewalls and next gen firewalls are different approaches, but they're both things that are important to understand. And they tend to fall in layer 7, although they do kind of touch a lot of the different stuff. So let's break those down a little bit. And again, you're going to see as we talk through the layers that I made this little chart. This chart is made from here, but then I just colored it on each one. Yes, I painstakingly made it for everybody. Good. All right. So proxy just means on behalf of. almost all of you have probably used a proxy, maybe a VPN proxy or something like that. A proxy acts on behalf of someone else. That's what the word means. So you proxy out to the internet, they don't know who they're talking back to, they talk to the proxy gives it back to you. But we want to invert that. So a reverse proxy is really what we care about here. And a reverse proxy hides your back-end applications from the clients that are coming in. There's so many benefits to this. We commonly call this load balancing, because if I can take those clients and bring them in, and then they don't know where they're going on the back end, I can send them to 1 to n number of back end servers. And when I do maintenance on those servers, I can take down a certain pool of those servers and bring them back up. And with load balancers, I can do blue, green, and canary deployments and all this stuff that we talk about as engineers. I got a bunch of other talks on that. I even have some killer Coda labs that you guys can go do on those topics, right? If you want to see how a reverse proxy works to give you high availability as you deploy applications and stuff. So would a regular proxy not hide the backend IP? It does, Umoon. It does, typically. It can. Well, okay, let's put it this way. It can. In fact, if any of you guys have ever seen, there's a tool that's not really used much anymore, but it's called onion routing. Anybody here familiar with onion routing? Been around a long time. Got compromised by the government, the U.S. government, years ago. But what onion routing did at a very high level was this one proxy was actually a chain. It would be like a ring of like 100 proxies. And what would happen is you would enter that proxy somewhere. You'd get moved around through a bunch of different servers that had de-identified you. They would not keep any logs of you aside from your de-identification to be able to get back to where you came in. And then they would send you out to the internet for whatever dark web and BS you wanted to do. Then when you came back, you would come back through your de-identified chain to the one device that knew you. It would send you off, and then it would not have logs. So the onion routing was a really awesome early way that people really de-identified themselves from the internet knowing what was going on. However, probably back in, I'm going to guess this was about 2015. It may have happened earlier. I don't know exactly when it happened, and I don't do a lot with onion routing, so I don't mind telling you this. But if you think anything you do on the internet is actually de-identified anymore, you're wrong. The government, the U.S. government, infiltrated the onion routing. There's actually some white papers on this if you want to go read them, where they found out that if they could at least control 60% of this, they're all anonymized servers. You could stand up an onion router right now if you want. But they found out if they controlled 60% of Tor, it's called Tor, yeah, Tor is the onion router. They found out if they controlled 60% of the endpoints that no traffic would be de-identified to them anymore. And that's what they did. So that got compromised. That's why you don't hear a lot of those, like those activists that Anonymous and those kind of guys that used to be real vocal and then they all shut up one day. Yeah, I don't hear anything from those guys anymore. But I'm pretty sure that they got told, like, if you don't stop, we're just gonna probably just go finish you guys all off, however you want to look at that. But that was when Tor got defeated. The onion router got defeated when more than 60% of their endpoints were controlled. And you can go look. There's white papers on that stuff out there, like actual academic papers discussing how that works. If anybody's interested with that, we're more concerned with the reverse proxy. I got a question. That's why I went off on that tangent a little bit. Yeah. So reverse proxy is us de-identifying our backend from the client, so the clients just come in. Oh, thank you for that, Twisted Seed. I always appreciate people giving back. Anybody that got a gifted sub, make sure you guys thank Twisted Seed. By the way, guys, I do have a challenge. Anybody, any of you guys that know me know that anything I get, I try to put back into our community. We actually have a little Code Wars challenge. We have a fair amount of programmers in the Linux community, and some guys are trying to level up. If you can beat some of our senior guys down in in our Code Wars account, who Fisherman Guybro runs that, if you can beat like our three main kind of guys, which is King Buns, Fisherman, and Sending Grounds, you'll win a like if you can beat them in Code Wars. I don't even know what that means, but if you beat them based on their definitions, I'm gonna do a what's it called? Humble Bundle. I'll buy you a Humble Bundle. If you guys know what that is, Humble Bundle's this awesome site. Anyways, all right, I don't want to get too far afield. This is proxy servers. We're gonna go into Robedom. Go smoke them. That's what I'm telling everybody. Just go beat them. So all right. So let's talk about layer 7 firewalls real quick. I've got some images in here. I'm going to link this up on Discord later, so if anybody wants this, you'll have all the links and stuff. But unified threat management is a defense in depth, multiple layers of security appliances that protect your system. That's typically what we mean when we talk about the term UTM. By the way, I know people come and go during a Twitch stream, so let me, real quick, I'm going to pause right here. I'm going to go back up, show you guys what we're doing. We are going through here. We're going through these topics, right? It's just a primer on Linux. The goals are for you to understand the basics, to talk about some of why we subnet. We already covered that. Talk about the flow of data through the model. We talked a little bit about that. And we're not going to become an expert. We're just surveying everything. All right. Again, this presentation will be there for you guys that want it. Proxy servers, firewalls. Web application firewalls tend to be applied by cloud providers, and then we put them in front of our different web applications, and they can be really aware of kind of what's going on with that web application. They're aware of the OWASP top 10. They can be blocking things based on like pools of IP addresses. Now that's down at layer 3, but they can do like country level blocking of things. Next generation firewalls I kind of glossed over, but they're application layer firewalls that are available. They are aware of what the application is doing. So most of you have probably worked with at least an application, or maybe you've played on like Amazon, and you've realized when you click on a certain link, there's this path that's added, like a slash cart. So now you're in shopping cart, and then you go somewhere else and it's like slash sporting goods or something. I don't know. They're mostly abstracted nowadays, but if you go to my stuff, right, it's like test and read, and it's like really basic like stuff. But my firewalls and my devices in front can be aware of the pathing that is expected. So they can look for well-formed application requests. They could know, they can be tracking and looking at that path that's coming in, and they can look at that end little path and go, you know what? This guy's walking through and they're looking for cart, they're looking for login, they're looking for admin, they're passing in credentials as, you know, you have the little ampersand to, it's question mark in HTTP, right? You can put a question mark and you can denote different fields and try to pass in strings, and these next-gen firewalls can be tracking at that layer, up at layer 7, that somebody's trying to maybe message multiple times with different headers to try to log into different types of default passwords and stuff. All kinds of stuff, yeah. Sporting goods, baseball bats, yeah. There's all these different paths that you can use. Yeah, and then King Buns is showing, yeah, age, question, yeah, they're query parameters, and they can be aware of what a good one looks like. And they can be aware of ones that look like they're trying to overload the encoding that's allowed to maybe run things on the back end. By the way, that was a huge part of how Log4j got exploited. If you guys are familiar with Log4j, what Log4j was it was a logging tool that was built into Java. I'm pretty sure. I was mostly part of the platform engineering team that discovered it and got rid of it at my old place. But you know, thousands of machines and stuff. But what would happen is people would send in these query parameters to web pages, and they would get them to execute as code in your logging system. So Log4j is doing, as your JavaScript executes and your whatever, not JavaScript, it's actual Java, is happening over on your Tomcat servers. It's logging things out, and in the logging, it would read these strings that were being passed in, and it would do executions on that server that shouldn't have been run. And then people would reset. Normally what they would try to do, there was a lot of exploits for it, but one of the most common ones was they would rewrite your etcresolve.conf if they could to make you look as a DNS resolver somewhere out in the world. Once you can control a system like that, you can basically make a system talk to anything they want and think it's a safe communication. Like, I could make you go talk to somewhere over in, I don't know, let's say somewhere in Asia, like China or something, and make you think that you're talking to a local device in your network, right? That's a problem. All right, we're not going to get too much into that, but I'm just telling you, these are the systems that protect against that, right? And if you guys want me to do an analysis on that sometimes, there's some really good diamond intrusion analysis that have been done on those, and you can go read about them. They're all over the web. All right, here's an example of like AWS, and you guys probably know I have a whole bunch of the AWS certs. Web application firewalls, how they work in front of your different services. So we put a web application firewall in front of like CloudFront or a Kinesis Data Firehose, and it's pulling in the logs, right? But this request coming in, we can make sure that we can have managed rules, we can have allowed things, we can block for SQL injection. I'll tell you guys one. So I used to run the web application firewall for AAA. That was something I did before I left there. And one of the things, this was actually really funny, we were getting stuff, we would always get stuff from a bunch of different insurance companies that like would AAA, some of the big insurance providers, they have independent people that run insurance, and then they will sell for the different providers. This is how a lot of people do this. Not everybody's just like a State Farm or a AAA agent. Some people shop a bunch of different agents, and they will do that via a bunch of API calls that we allow only certain companies to come in from. Well, anyways, I'm going to tell you guys about something that happened. We had one of our third-party vendors, somebody that worked for us, and I forget exactly what they were doing. I probably wouldn't tell you anyways, but I'll tell you that they were sending us a bunch of banking information, and in the banking names, right, in the banking names, I just want you guys to think about this for a second. Dust off your SQL if you don't use it a lot. In the banking names, sometimes it would be like First Select Bank of Dover, First Select Bank of, I don't know, Anchorage or something. And there was that word select in there. So as they were passing it was API bundled JSON. It was a bunch of JSON being passed in for like authorized debitors and whatever they were authorizing against their accounts and stuff, right? But they were using the word select because First Select of whatever. That was one. Hold on. And the reason I'm mentioning SQL is probably already apparent to those of you that use SQL. But this is a name. This was in a string that was determined for the name. It looks like SQL injection. You're already, I don't have to, I only have to take you guys so far, and you're like, oh shit, that sounds really bad. What was the other one? It was SQL. So sorry, it was select, and then the other one was what was the other name that's very union. It was union, like credit unions, right? You've got unions. So select and union, those were the two major ones. It was dropping all over the place, so we had to go in and say, whoa, hold on, that's good. Yeah, well, because select is another one. If we can get you to read things, right? Select from. So it was getting stopped at SQL injection. So we had to say, no, hold on. If it's in a description field, we're okay with it from these people. So like you have to. It's almost like I tell people, when you think about security, let's say you sold diamonds, right? You were like Jared's out here that like sells diamonds. Hey, how's it going, Gray Fox? We're just going through kind of a primer on networking. People are down in Discord. They can play music, and they can mess with me, and then we're all up here doing whatever. It was a naming convention issue. Well, Robodom, I mean, none of us know all the names of banks, right? I don't know all the names of banks in my local area, let alone anywhere in the U.S. that could be billed. So, yeah, these people were sending in these JSON. It was JSON parameters, and in the description field, sometimes it was pinging. So we had to say, hey, if it comes from these and it looks like these, then go ahead and allow it. But back to that diamond thing. If you sold diamonds, I mean, you have to open your diamond store. So aren't you always open to robberies? Yes. It's the same thing when you do anything on the web. You are open to robberies. It's you are open to attacks. My stuff gets hammered all the time. I show you guys my logs of my open SSH connection, but I have reasonable protection and layers of security that I think is probably pretty good. Can't come in as root. You can't come in as any of the normal default users. You get locked out if you try more than 5 times. You never get unlocked, so you just get locked out forever. Even if you're some grandma that just got botted by somebody and now you attacked my network, I'm never going to let you back in. But guess what? You probably don't care anyways, right? All right, anyways, there's all these things that can happen. HTTP flood is part of just overwhelming resources. If I can't control it, nobody can have it, right? That's a denial of service of some type. Are people trying to scan and walk common paths? We can block that. IP reputation lists, and then bad bots. And bad bots, by the way, we had a really good talk a while back from my friend Jared, and he talked about good versus bad bots on his company site. And what Jared does is specifically look at all web traffic coming into a $1 billion web retailer. So he looks for good and bad bot traffic, and he looks for all kinds of things, because there are good bots. There are your resellers buying things off your pages to sell to other people in real time, and you want those bots to work, but you also want to limit bad bots. So, all right, there's a bunch of other stuff going on here that doesn't really matter. They mentioned an application load balancer, which also happens at layer 7. There's other layers that load balancing can happen at in all of these systems as well, but we're not going to get into it. We don't want to get bogged down too much. What happens at layer 6? We encode things. We decode them. So as we go down one side, we encode. On the other side, we got to decode it. You say, well, what the hell's an encoding and what's a decoding? Well, MP4 is an encoding format. And on the other side, when it comes up to be used by the application, it gets decoded back from that format, right? We compress and decompress. What are some compression formats? There's all kinds of codec streams that compress sound, especially in what we call real-time protocol and real-time sound. We compress sound. Even like, it sounds like I'm probably talking pretty fast at you, but in every second of sound of even me talking right now, there's probably like over 50% of that second that's wasted, that our computer doesn't need to hear anything for that to send over and get shotgunned over via UDP to get to you. So it can compress a lot of that algorithm. It can compress that down. That's called codecs. And then we decompress on the other side by the same codec. We can encrypt and decrypt. So layer 6 is encryption and decryption of things and this is different than TLS at layer 4 or IPsec down at layer 3, right? Encryption and decryption here. I'm trying to think of some of those protocols right off. I can't think of any. But the point is, whatever you do on one side, you got to undo on the other side. Otherwise, the message isn't going to get across, okay? Layer 5 is windowing and flow control. Windowing and flow control directly affects what happens down underneath in the transport layer. Windowing is how many frames, how many segments I can send before I have to get an acknowledgement back across all of them. And flow control is how long we wait and all that kind of stuff as well, right? So there's all this stuff. Yeah, base 64 is an encoding. Yeah, absolutely. All right, so let's drop down to layer 4. Remember I said 6 and 5 we're not going to deal too much with. If you guys want to dig into that more another time, we can do that. I have to go research some of that because I haven't used a lot of that in a long time. Layer 4 protocols. There's two major protocols, TCP and UDP. There's 0 to 65.535 are the available ports, so 65.536 total can be connected to or listened to on a device that's using the TCP IP protocol stack. TCP is the transmission control protocol. UDP is the user datagram protocol. If you're going to take like a CCNA or a Net Plus, I would highly advise knowing those two very well. TCP is connection oriented. UDP is connectionless. What does that mean? UDP just shotguns data across the network. It doesn't matter if it's an order. Doesn't matter if it arrives in order. Something up higher has to deal with putting it back together. The UDP is just going to launch it across the network as fast as it can. All right? Connection oriented is going to be completely different. Oh, by the way, UDP is going to use any path it can take across the network. It does not secure a channel with the lower layer protocols. TCP does, as best it can. It's connection oriented, and there's three things that have to happen for a connection. Now, when I teach this to my college students, I'm going to tell them, I always tell them the same thing I'm about to tell you. This will help if you understand, like if any of you are sci-fi fans, or maybe if you're Pirates fans. There's Pirates of the Caribbean, which was wildly popular. There's One Piece, which is wildly popular as well. Those are pirates. There's a lot of sci-fi, right? There's a lot of stuff going on in space. But I want you to think about this for a second when we talk about like a three-way handshake and the idea that we have a connection, pass the data, and break it down. Think about a pirate ship real quick. How does a pirate take over another ship? They've got to connect. They throw their hooks. They pull them over side by side. They pass over their pirates, and then when they're done, they break apart before they loot, or they loot. Then they break apart before they burn, right? Because you always pillage first and then burn, but you don't want to burn while you're still connected to the other ship, right? So my point in saying all that is, if those happen in any other order, you don't have a very successful raid, or you don't have very successful out in space. You'd be like floating around like the Mortys that got kicked off the Citadel, right? If any of you remember that reference. So three-way handshake is the SYN, ACK, and the ACK. That is the same idea. This is the same idea as a contract negotiation. It's a SYN. I say to you, hey, I want to connect, and then you say, okay, you can connect to me as on this port and this service if you agree to these terms. That's like sending a contract to me, and I go, I agree with those terms, and I acknowledge them. Now we are in a communication. Once those three things have happened, we are in a communication. I send a SYN, you send a SYN ACK and allocate some resources, and then I do an ACK. When you send a SYN, or when I send a SYN to you and you send a SYN ACK back, we are said to be in an embryonic state of that connection. We are not yet in a fully established, what we call an established state of our TCP connection until you send that ACK back to me, or until I send that ACK back to you. Once I send a SYN, you send a SYN ACK, and I send an ACK, that is when the communication can start, and I can start to pass data in sequential order with a certain number of them before we acknowledge. We're going to look at those headers here in a second. But while this is happening, this is very important here. great pirate metaphor. Yeah, I don't think I did it as good this time as I've done in the past, but I think that it's important. You got to send things after you've established your connection. The old SYNAC attack, if you guys have ever heard of the SYNAC attack, it was, I would say, hey, I want to connect, and then you would say, okay, connect, and then you would allocate some space to me. This is like a dinner party. You say, hey, I'm going to throw a dinner party, and I say, I'll be there. So you set out a plate for me. And then you send out a mass text, and I say, I'll be there. So you set out another place for me. And then I call you, and I'm like, this is Scooby-Doo, and I want another place. And then you set out a place for me, but I never acknowledge, and I never finish the connection. I just keep making you set out places until you can't support them anymore. That's the old SYNAC attack. That's been solved greatly long ago by a couple things. Servers will only allocate so many resources before they stop allocating resources to an IP. That's important. Embryonic connections, or what we call half-open connections, tend to be limited by almost all firewalls. Almost all firewalls, like your Cisco, your old PIX firewalls before they became the ASA, the Adaptive Security Algorithm firewalls, they would only allow maybe 5 or 25 embryonic connections to any one host from any one IP, and that was just a protection. Then when we're done, we do a breakdown of the section of the session where I say fin and you say FINAC, and we're done. Okay, that's the communication of a three-way handshake. UDP doesn't do any of that. UDP is just like your crazy uncle on the back porch of a swamp, just launching his shotgun out into the night, terrified of whatever's out there, and he's just like shooting off and drinking his whiskey and all that kind of stuff. That's UDP does not care if it gets there or not. Other higher level protocols have to deal with that stuff. In fact, the question I always ask my college students when I talk about this, because we're typically on like some kind of a stream like this or whatever, is what do you guys think we're using for this? So what do you think that like a transmission like this, where we're doing video and this kind of stuff, what do you guys think is going back? It's not doing a reverse shell get around TCP. Astro Boy, everything you're doing is still doing some type of TCP or UDP. UDP is your redneck uncle. Yeah, just launching a shotgun, just shotgunning data. So UDP is typically what we're using for stuff like this, because on the telecom side of things, long ago we found out that if your ear hears a stream of data even 1/6 of a second out of order, so in 1 second, that's 1,000 milliseconds. If you receive a packet 166 milliseconds late, or at this point it's a segment still, and it's a UDP and it's 166 milliseconds behind when we needed it, you might as well chuck it out. Because if I was coming in like that, if my voice was doing that right now, none of you would be able to listen to me. I would be too jittery. I'd be like those artifact things on like the old sci-fi type stuff. Yeah, UDP is faster. I'm going to show you why here in a second. It's faster because there's no handshake, and it's faster because there's less overhead. So let's look at that here real quick. So here's the protocol data unit diagram for TCP. This is a TCP header. So earlier when I said when you get to layer 4, when you get down to the transport layer, there's all data up here. I slap one of these bad boys on the front of all your data. So this right here gets slapped on the front of your data. There's 16 bits right here for the source port, and there's 16 bits right here for the destination port. Now, if you wanted to go challenge yourself, go to Google, type 2/16, caret is right there over the 6, you would find that is 65.536, which is what I told you were the available source ports and destination ports. So why is there a source port and a destination port? The source port is the port that I pick that I'm going to have you connect back to me on. So let's say that this happened to be, you sent a request to go to the website somewhere of somebody. So I want to go to umoon.com, right? And down here in my TCP header to connect over there, the destination port would be port 80. That's the destination port for web by default. That's what your Internet Explorer, your Google Chrome, or your Firefox is going to use as destination port. And it may get redirected, but it's going to start at port 80. The source port is going to be generally just a dynamic assigned client port on my machine that I'm going to listen back for. I'm going to listen back for port 5333. That is outside of the well-known ports. The well-known ports are 0 to 123. Those are the first ports that are well-known. And then 1024 up through like about 10,000, I think, are like the client ports that a client will normally pick. And then you have all the way up to 65.535 that you can do pretty much wherever you want. Yeah, that's Umoon. That's exactly where the port limit comes from. It's you've got 16 bits. So we could figure out the bits of whatever. Yeah, and actually, if we wanted to, we could go figure out what 80 is in this. It would be a bunch of zeros, and then we would go figure out the 80 from the last portion of it. That's all it is. Okay. So, but real quick, let's look at this real quick. Here's the RFC for it. If you want to go read the RFC, I want you to compare this header real quick with this. By the way, it's a little bit different size, but it's still 32 across. UDP has for the header a source port, a destination port, a length of all the data put together. It gives you an aggregate length of what to expect behind it, and then it gives you a checksum to be able to check if it's as long as it really is supposed to be. The checksum is the value of all the data, and then the checksum value dropped in right there, and then you strip the checksum out, you check the data, it's the right size, go on. But I just want you guys to see this real quick. Look at this. One was about this big right here, this big. But then this is the TCP compared to the UDP part. All right, so let's get that out of the way real quick. And I want to show you, these are the other things that make it. This is why we start to talk about overhead on a line. This one, again, this one's just pumping the shotgun and firing. This is like my little Brotato game where I'm just launching shells at all the enemy, right? We come back here. After this, we've got a sequence number and an acknowledgement number. Now check this out. TCP must arrive in sequence order at the far side, or the far side just goes, I don't understand what's going on. It needs to be sequence number order, so the sequence will increment. When we go and we're going to look at a demo here, and if I go to any one of these TCP streams, and then I follow the TCP stream, right? So I can just right click on it and say, follow this TCP stream. Every single one of these that I walk through, I will be able to watch as I go through these, as I click through. I will see the sequence number increment and the acknowledgement number increment at the same rate as they go through. It has to. There's no other way for it to work. It's like the way I explain TCP to people when we're talking about this is like this. If a train leaves a station with 9 cars and they are in one order, there is no situation in which those 9 cars get to the other side, assuming, the train takes off at full speed and goes, between here and Cincinnati, and how long does it take to get, I'm not going to ask you guys any of that. That's all basic. That's either basic algebra or calculus based on, if we're doing acceleration or not, right? Well, anyways, my point is, when it gets to the far side, it better be in the damn same order or something happened, right? It's the same way with this. Then there's all kinds of acknowledgement and all kinds of flags that can happen in here. There's an urgency, and then there's a bunch of options, then there's some padding, and then there's the data, right? The train word problem, yeah. Rodom, yeah, it's anytime, yeah, bad memories, any of that stuff. But I just want you guys to see that the TCP's got a lot going on. There's a lot of acknowledgement. There's the latency along the line for the acknowledgement to get back from the sequences that were sent within whatever window that you're allowed from the session layer above. So you've got a window of 18, so you can send 18 in sequence before you get that acknowledgement. If there was nothing else going on, there is, for those 18 things being sent, at least the time that the acknowledgement takes to come back, that is less time. That's less time to transmit because of the overhead of the time. Now, if we're talking like a 20 millisecond link, that's still 20 milliseconds, which is very, very short to us, but that's long to a computer. And most links over the WAN are going to be higher than that, much, much higher than that. All right. So UDP, much, much more efficient, but something higher above it has to deal with putting things in order and that kind of stuff. So there's actually going to be, I'll show a phone call with RTP, real-time transport protocol, that helps to deal with some of this, because there's other things that we can do in here. All right, other things that happen at the transport layer. And by the way, we could talk for hours and hours about any of these layers. Like this is like, we got to talk. There's security that happens at layer 4. TLS, transport layer security. It's data in motion, right? Data's moving around. There's 2 things that TLS does. 2 things primarily that are very important that TLS does is it verifies the authenticity of who you are. If one of you called me right now and I picked up my phone and I was like, who is this? How would I know that it was you? Do I recognize your voice from before? Have I met you? Do I know you from somewhere else? So it deals with the introduction to trust, right? So it's a trust thing. That's one. And the other thing that happens is once TLS has established that trust between us, we negotiate a symmetric key to encrypt all of our data and send the data. Now, this is not, strictly speaking, an encryption thing. We talk about encryption in other chats, and we talk about it down in Discord if people want to hang out down there. But what happens with encryption is there's asymmetric keys, where one side's a public key and one side is a private key. And asymmetric encryption costs 10 times the processing power, or 10 times the speed if you have like processing power. It's 1 order of magnitude greater than symmetric key encryption. What does that mean? That means if I'm wearing a little decoder ring here instead of my little rubberized wedding ring, if I was to have a decoder ring here, my system and I could talk faster like this than if I had some big sheet that was a certificate that had an algorithm that was cryptographically similar to your side, and when you sent me something, I could decrypt it only through using this other private or public key, depending on what we're dealing with, right? So TLS does those two things. It does the introductions, and then it does the negotiation of a symmetric key. By the way, the symmetric key is only used for that one run of that communication, then it breaks down forever. What I show here is the old TLS 1.2 way, which had 7 steps total, to the more efficient 1.3 handshake that it just assumes that, hey, you're a server I want to talk to. It doesn't do the hello and the hello anymore. Strip that off. All right. So with that, SSL happens at layer 7, but TLS happens at layer 4. So we're focusing on layer 4. TLS does encryption of data between two endpoints. SSL, which typically people call it SSL, but it's TLS now. Nobody should be using SSL anymore. SSL is the entropy got it. We can decrypt that too fast for it to be effective, so nobody uses SSL anymore. It's now TLS 1.3. A real quick look at that is the first part was the introduction, right? The trust. And it goes like this. I want to connect to some server, right? And I want to verify that server is who it says it is. So what I can do is I can trust a certificate authority, like CA is a very common one. GoDaddy is one that's commonly used. AWS signs their own as well. And I can pull down the publicly available version of the certificate for that server. Now the server has its private version of that certificate and that certificate key. It will never share that with anybody. But what I can do is I can send over to that server a string, and I can say, hey, go ahead and decrypt this for me. And the only person, and by the way, I encrypt that string. It's an encrypted cryptographic string based on the public key that I downloaded. And that server looks at that and goes, you sent me, Mama likes to bake cookies on Wednesday. And I say, that is what I sent you. Fantastic job. I agree that you're who you say you are. Let's negotiate a symmetric key to just be some bullshit decoder ring. And then now our systems can, I made that up on the fly, Twist. I didn't even practice it. No, I'm just kidding. But anyways, we negotiate a symmetric key to use, and all communication, all data is transferred over that symmetric key after, okay? But they got to send the cookies. Yeah, my mom bakes really good cookies. I can't eat them. They're too good. All right, so layer 4 example in Wireshark. So let's go look at layer 4. Here's a Wireshark capture I captured a while back, and here I can see protocols going on, and I can just go look at TCP. So when I fold this down, if you guys haven't used Wireshark before, let's see if I can zoom. I can't zoom in on it anymore. Here's the TCP information about that system. Now everything that's going on over at the right, like as I click on source port, you're seeing the hexadecimal representation. So if we were to take those 4 things that are limited right there. All right. You guys should be able to hear me again. Okay, let me pull this off of here. This was that, guys. That's up on up on YouTube. If anybody wants it, I was messing around for a little bit here, just kind of putting stuff up there and letting you guys kind of watch that while I was doing other stuff. Let's get back to what we were doing earlier, which is actually Linux. We're doing Linux, guys. You've been bamboozled. If you've been here for any amount of time, I was bamboozling you. I haven't been on here. I've been sitting here, but I haven't actually been on here for quite some time. So we're going to go in and we're going to do some more Linux. I've been hanging out I ate a little bit earlier. A storm hit Phoenix pretty hard. That was fun. We got more labs to do. So if anybody's on YouTube, we're doing labs, and if you're on the Twitch side, we're doing labs. Also, we were playing video games earlier too. Quite a bit of video games. I think we're still down in the Just Chatting channel, so you know we can do whatever we want in here. Don't really have to answer to nobody. But let's do this next lab. So this one is called Connecting to Systems and Pushing or Pulling Files, and it's also SSH or SCP. So I'm gonna link this one to you guys here, and I'll put it up on. Whoops. I'll put it up on the YouTube side as well. So if anybody wants to do this with me, you can. And then we'll pop back over here and let's do the lab. So anybody that wants to do the lab with me can, and all you got to do is go in there and click on the link. There's a pinned link, and then it's over on the YouTube as well. All right. So we've got a book. The book is sitting out there. It's on LeanPub. You guys can look that up if you want. I think somebody even linked it a little bit ago in chat. And none of my mods are around, so I'm pretty much by myself here. But this one says that the task, condition and standard, the task is learning about Linux networking by pulling and pushing files between your systems. We're going to pull and push files around the network. And then I say, given a bash prompt, complete in the allotted 60-minute time. So we're going to have 60 minutes in the lab. That's pretty common if you're doing Killer Coda. By the way, Killer Coda free, one of the best things I think on the web. I can't think of many things that are better for free. Hold on. Nice. All right. Wife's messaging me. All right. Get some water here. The standard for this lab: complete all the activities in the lab, correctly move files between the systems. That's the goal. That's what I want you guys to have. Oh yeah, I wish I had beer. I guess I could go buy beer if I wanted, but the wife's out of town, so I could drink all I want, right? Actually, I don't drink really, but if I did, like if somebody gave me a beer, I would drink a beer. Free beer is better. Good. All right, so we've got this lab, and the lab says you are a new administrator and need to connect from the main jump server to another server in the organization. You realize you need a better understanding of the SSH connection process. So we're going to do some SSH connection. I say connect to the other server and look at the specifics of the SSH connection. So last rated digit said, by the way, my VMs won't boot after I change the machine ID. Apparently the trick is to truncate Etsy machine ID when installing the QEMU guest agent in the cloud image. Interesting, last rated. I didn't know that. Did you find that and then you did that? You should be able to, I would think you'd still be able to get them to at least boot. Truncate the Etsy machine. Yeah. Well, I mean, on the plus side, it's better to figure it out now than like in a live system. It's just a home lab, right? All right. So what are we doing here? It says to check your IP address. So, why does it say check your IP address? SSHing to node 01, exit the system and go back to the regular system. Okay, that's fine. And then I said check the system uptime and why does this say check your IP address? That's not the right info there. They're brand new. Yeah, last rated. It's the best time, right? You're first just building them. Hold on, I gotta check one thing on my work system real quick. All right. Everything's weird stuff going on over there at work. I'm checking my work system and all right. I'm just gonna let that stuff go. So I SSH over again. I don't know why that says check your IP address. All right, exit and return to the original system. And I said check system uptime and layer 1 debug. So I'm going to SSH over to node 01 again. But this time I'm just going to do a simple command of uptime. And what will happen is it'll jump to that machine. It'll do the uptime command. And then it'll come back. I'm back on my regular machine. I actually did an exit status of 0. But I've got a bunch of these debug 1s. And these debug 1s are going to show me information about the how the connection's being established. I'm going to see that I read the configuration data for etc SSH underscore config, which is the outgoing SSH client, right? On control plane, I'm using the SSH client to connect out. In there, I will run into any configuration limitations on how I can or cannot connect to the other machine. Any keys that I am or am not allowed to use will be defined in there. And we can go look at that and see what's kind of going on in the system. Down here, it says that I then, inside of that file at line 19, there's an include for etc SSH underscore config.d, which is one of those extension directories, one of those directories where we can put more information. And anything in there with a .conf on the end would have been added to this file, but there's no match file, so that doesn't matter. So everything that this configuration is right there in etc SSH underscore config. We can go modify how this thing behaves. We can do all kinds of stuff. Then it comes down here, and it says we're going to connect to node 01. And node 01 was resolved in some way by my system, 172.30.2.2. That's how it got over there. Now, it could have resolved in two ways, two general ways. It could either be a local file, a local host file, or it could be DNS. Those are the two options. Now, I'm going to predict that that was probably done via the local host file. And if you wanted to see me verify that, I would do this. I would say cat etc nsswitch.conf. And right here, the hosts of my system, I will first look in my local files, and then I will go look in mdns4 minimal. And then, if that's not found, I'll go to my DNS. My DNS is resolved here, etc resolve.conf, resolve.conf, right? And I use 8.8.8.8 and 1.1.1.1. That is that's a Google DNS, 8.8.8.8, and I think one is, I can tell you who one is, right here. One is, oops. I always forget. Is it Cloudflare? Yeah, I always forget. It's right here. I don't even have his name in there. But yeah, I think you're right. It's Cloudflare, yeah. Yep. 1.1.1.1 I do. And then 8.8.8. Yeah, so that's Cloudflare. And then the 208.67.222.222 is the Cisco one. Well, whoever Cisco is, that's the other one. But yeah, 1.1.1.1 is the Cloudflare. That sounds right. Okay, so I can look at those. But, again, cat etc hosts, we know that it used the host files first because the etc nsswitch.conf is what controls that behavior for hosts. We look in files first. If files doesn't have a node 01, which it does, then we would resolve to 172.30.2.2, which is node 01, and that's how we got this value right here. And we're using port 22 because that's how SSH connects by default. And then we started to look through. Here's debug. Again, these are debug 1. You only see these if you debug. I started to look at all these different types of identity files that could have been there. And a -1 is a very common return in a lot of different programming languages for, I didn't find it, buddy. It's not there. But root.ssh id underscore RSA was type, it was found. There's a 0 there. So if I went and looked at this file, if I looked in this directory, ls-l on root.ssh everything, I would see the id underscore RSA, and I would not see any of those other things because I don't see them in there. They're not there. Then we come down, the remote local string, the local version string, here's my local machine. And then on the remote one, here's the remote protocol version and the remote connection, which came in from the header that we read out from connecting to the system. And then we start talking about what type of connections we're going to allow and what type of algorithms we're going to use, right? And these things can all be configured, and we can look through that. We get all the way down here. We check that the node 01 matches the elliptical curve DSA host key, and that was found in known hosts. So, here's an interesting thing. If you've never done this before, you can actually mess around with how your system works. So watch, I'm just going to do SSH with no V's on node up, and it's going to run and it's going to hit the uptime, right? So it's going to do that. But let's go mess with the system a little bit. Let's VI at root.ssh known hosts, where that is defined, and I'm going to go in here, and I'm going to look for node 01. I didn't find it. Let's just do this. Let's just delete all of them. I don't want any known hosts. I don't want any of them. And I'm going to try to connect to that node again. And it says, are you sure you want to use that? I don't know anybody on the network. And I say, yes, yeah, I'll use it. And then if we go look again at the known hosts, the known host has been populated with those hosts. So watch this. I'm going to DD them again, escape : WQ. And I'm going to SSH again, and it's going to say, are you sure you want to connect? And I'm going to say yes. And then I'm going to VI that known host, and I'm going to do this. I'm going to go all the way over here. And I'm going to say, I don't really like this. I'm just going to change that 4 right there to a 3. Just somewhere in the middle of the protocol. And now I'm going to try to connect, and it's going to say yes. And then it's going to, let's see. Get rid of all of it again. It's gonna say yes, I'll connect, and then I'm gonna go change that. I don't even know. This is weird. This is weird how they have this set up. Let's go all the way over here. We'll just change both of them to the wrong thing. And then we're gonna try to connect. And it's funny that it keeps asking me for the key again. Because normally when that happens, it'll tell you the key is broken. But probably the key is doing some type of check that I don't know about. But the point is, it's not known, so it's doing the host key check every time. Now, the interesting thing about this, let's delete all this. You can actually do, right here when you do your SSH, you can give an option, and you can say strict host key checking equals no. And this should go ahead and connect, but not ask you. So some of us, when we do, especially like early days of Ansible, I used to do strict host key checking no all the time. You don't have to do that at the command line, by the way. You do not have to do that. You can do that inside of a .ssh config file. So you can put that in your local root.ssh, and then you can have a little config file there. And that config file would be read, and the strict host key checking no would take into effect. And then we would not go, like, look, remember the behavior before was every time that there was a host key that wasn't known, which there's none known right now, that we don't know one at all. Now it's just going to go ahead and it'll be like, he said forget about it. So it just throws the host key in there. Right? So that's something to know. Something to play with. And then I keep having you add V's. And as you add V's, you get more and more debugs, all the way down to where you get these debug level 3, which are like almost like an S-trace level of what's going on with your debug in the connectivity. Look, it's even showing that you're passing the environment over there. I don't need to see that. You don't need to ever see any of this until you have a problem and you need to see it. Once you have a problem and you need to see it, then and you got to debug why is LS colors not coming over correctly or something. That's when you dig in. I tell you guys all the time, when we build stuff, I only need to look low enough down for it to work for whatever it wants. All right, I gotta fix this lab. It's pissing me off. All right, so I'm gonna come here. Here's the Linux lab. I can't believe this lab sat here as long as it has like this. We're in SSH and SCP. We're in this one, and we're gonna go here and it says check your IP address, and I'm just gonna say check your connection to node 01, because that's more of what you're doing there. That really bugs me that that's been wrong like that for so long. Fixed message in step 1. All right, commit that up, push that up. If any of you guys are wondering, the connection that we're using, all these labs are up in my GitHub. You can always go find these. You can do pull requests against them. Right, they're up in my GitHub. I don't do a whole lot with GitHub, but I do all these labs in there. and that they're all built out of there. So this lab will rebuild, it'll go and it'll sync and all that stuff, and then it'll be right the next time. So what additional information was shown with the -VVV option? Everything was shown, everything about the connection. I say, so we looked at the SSH connection over to node 01. You should note that the keys are being used, and that is why no password was asked. There was a key file and it was used, and we'll explore that more shortly. But let me show you something else about this. When we're connecting, right, even if we're just regular connecting, you're getting that to happen. But what if I went in and I went to, let's just cd to root.ssh, and in there, we see that this ID underscore RSA, which is my private key, is set as 600. So let's just have some fun. Let's say chmod 640 on ID underscore RSA. So that key is now 640, meaning somebody else other than just the root owner can read it. Now let's try to connect. And it's going to go, whoa, buddy. You're trying to use a private key that is accessible by other people. Nope, we're not doing it. Nope, won't let you do it. So I got to hit Control C to stop that. And then if I just change this back to 640, then it'll work again. The connection will work automatically through the key. And similar to that, if I'm in this directory and ls-ld, this directory is 700, meaning that I can read it, write it, and X is to traverse into it. I can chmod, let's say 775 on here. We'll look at our LSLD and it's 775, 775. Now I'm going to try to connect, and it's still going to work. But that is not best practice to have that as a readable or executable drive, right? That's not a thing that, or a directory. I wouldn't normally want that. All right. So it says you are tasked with pushing a new message of the day onto a server. So you want to push over this this thing, and then you also know that the server has a correct etc cron tab configuration that you want to use on other systems. So you're going to pull that data. Yeah, Diamond, that should not have worked, but it did, and I don't know why in Ubuntu, so I'm not going to worry about it. Johnny man, how's it going? It's back to me again. I probably spent a little over an hour and a half just running a VOD. I told you guys multiple times that it was a VOD. I was sitting here, I was answering questions and stuff, but I was running a little VOD while I went and ate, and then I kind of just sat here and hung out with everybody, watching myself talk about networking. That, by the way, if anybody needs that more, it's up on YouTube, right? So if you guys go over to the YouTube, you can find that. Go check over here. Nobody's talking on the YouTube side anyways, so that's fine. Okay, so we did this, right? And then I said, you want to push that up? And then I say SCP is always from to on the command line. So the syntax is SCP from here to there. And I say push the root message of the day over to node 01 at the location etcmotd. So if you do not know how to do that, let's figure it out right here. I am on this machine. I'm going to cd. I don't have to be in root, but I can be. And I have this motd. Messages day is cool, right? It's our big old dev. And I'm going to SCP from here, root motd, to node 01 at etcmotd. I'm going to copy it over there. Now when I SSH over to node 01, it's got a big old message of the day for me. That's pretty cool. But then, back on this same original control plane, I want to pull the etc cron tab from node 01, so I'm going to SCP node 01 etc cron tab over to my temp node 01 dot cron tab. So from that machine, I'm on my machine, I'm pulling it down from there to here. I'm still using a key, it's still got to have a key, and I'm pulling that over to here. So now, if I wanted to, I could do this very quickly. I could say chk sum temp node 01 cron tab. Oh, it's ck, guys, it's ck sum. My bad. I can checksum that file, and then I can SSH to node 01, and I can do a checksum on etc cron tab, and I can see that it is the exact same file by weight. You can also use a SHA-1 sum, And you could do the same thing here. Oops. SHA-1 some. And there's a whole bunch of different SHA things you can do. But the point is, with any of those tools, you can verify that they're the exact same weight. A hash will take any input that you want, and it will always put out a fixed length hash output. There's no data in that hash. The only thing the hash has done is weighed that thing to be exactly the same. You can also use rsync with pretty much the same syntax aside from a few flags. It can be hella faster. Yeah, it's definitely possible to use rsync. I never got into using rsync. I have a lot of guys I know that are big fans of rsync. Once I find one tool, I just use the one tool. But I do know that rsync can preserve archives, and it can only push the things it needs to. And I know rsync's got all kinds of powerful things that it can do for sure. So if you wanted to do the lab by the solution, you could just come down here and you can check the message of the day, copy it over. You can go see the message of the day and come back. Then you can go check the MOTD and see that it's exactly the same as it was. And then you could go and you can check the cron tab. You can pull it down over here and you can check it again and see that it's exactly the same. So you have all these tools, and it's very important as a systems engineer and a systems administrator, very important that you can push a file anywhere that you want to, and that you can pull a file back anywhere that you want to within Linux systems. It's also very important that you can push anything you want up from a Windows or a Mac. You need to be able to push things from the systems you're on. Newer versions of Windows have SSH built into them, and I used to use PSCP, which is the PuTTY SCP. But also you can, nowadays you can use SSH and SCP right native to Windows. Macs have SSH built right into them and SCP as well, so you can push files right up. But you just got to remember that it's that sender-receiver message, whether you're pushing or pulling, you're saying from here to there, from there to here, and that's the whole syntax. And that's the thing. Right here I said what additional information, so here's the parts of the lab. Obviously you had the questions in here to think about. Then over here we have some reflection questions. What additional information is added as you add more V's to the SSH command? It gets more verbose and gives you more debug information. And I said, when you see the identity file with a 0 or -1, what does that mean? And what is the identity file being used in this connection? Well, the only identity file that was found, the -1s mean they weren't found, was the SSH, it was the root.ssh ID_RSA. It was the only one that was found, and that was the one that was being used. I said, when pushing the MOTD, what was the source and what was the destination? Root MOTD was the source, and we were pushing it over to etc MOTD on the far side. When pulling down the etc cron tab file, what was the source and what was the destination? The source was, so we did an SCP. We said node01 : etc cron tab to temp dot, so /temp dot whatever it was /temp / node01 dot cron tab, right? Something like that. That's where we pulled it to. Yeah, there it is right there. And then I said, how are questions 3 and 4 similar? How are they different? Well, one is a push and one is a pull, but both of them are still SCP. So you can push and pull things as needed, right? Digging deeper, what are some package managers you can use to push or pull files from a Windows system into Linux? I use PSCP, but you can also just use SCP directly on the Linux command or on the Windows terminal now. And what are some other secure technologies to move files around your network? Why might rsync, SFTP, FTPS, or HTTP be a better use in this case? And where are others using those technologies? So rsync is really, really good when you want to keep two directories in sync and you want to only push the data that needs to change. That's really important. SCP will try to push everything even if it's all there already. It's it can be kind of annoying. But rsync can be smart about it. And SFTP and FTPS are a little bit different. SFTP is secure FTP, and one of them's over the secure. I think SFTP is over the SSH connection, and FTPS is just file transfer protocol secure. SCP has been deprecated for security vulnerabilities in open SSH implementation. Interesting. I didn't know that. I still use SCP all over the place, but yeah, that's interesting. And then HTTP, better use case. What are others using those technologies? I remember back even 10 plus years ago, whenever you wanted to send anything up to Red Hat, you always had to SFTP it up. But nowadays you can just drop it in HTTP. They just give you in the ticket, there's just, you can drop HTTP and you can throw files that are 10 gigs up there. They don't even care. So you can do all that over HTTPS nowadays. And then I said, use in the enterprise. Linux engineers also often find them pulling and pushing files up into Linux systems. They have to regularly pull log or system data to give to a vendor or third parties for compliance reasons. Knowing how to move data in and out of the system is a very valuable skill. So you gotta be able to pull or push data around in your network. That's pretty important as an engineer. All right, so this next one is going to be on screen commands. We might wait till, let's see what our time is. We might wait till tomorrow to do this one. We might not do this one right now. And the reason I say that is because I've been on for like 6.5 hours. By the way, this is my longest stream ever. Never been on anywhere near this long. I don't think I've ever been on over 5 hours even. So this is by far the longest I've ever been on. So what I might do, and only because we've been joking around and doing different stuff the whole stream here, is I might pull up, this game got an update the other day and I hadn't played it. So, yeah, this one. I might play this one a little bit. So we are in the Just Chatting channel, so we can do whatever we want, right? And I have been playing video games. So, let me, what's going on here? I'm going to drop this up here. You guys are welcome to, again, keep hanging out if you want. We were just hanging out, and if you got questions about Linux, let me know. But we've been kind of going back and forth all this whole stream between messing around and doing serious stuff. If you haven't played the Zombie Survivor game, this one's pretty fun. They just added this new character. He's mildly okay. I don't think he's great, but he's an alright character. What was I playing him on? I was playing him on one of these other ones. I prefer the Engineer, and we'll try Green Hell. And we'll try it on Endless. It says, can I survive 20 minutes on Endless? So let's see how that goes. And you guys are welcome to hang out. Again, ask me Linux questions. I'll leave that at the bottom so you guys can hear me talking. Or you guys can see the CC if you want. That's annoying. You're going to start me off like that? Jeez. These monsters are way higher level than normal. Alright, there's a thing that I really want, which is like a little shield. But we'll start with just upping my guns for now. That's fine too. So, if you look at this and go, man, Scott, that's pretty similar to Brotato. Yeah, I think I have a type of game I like to play. I find. This is the thing I really want with this guy, this little energy shield. So, anyway, we're here. By the way, guys, there's a pretty good storm going outside Phoenix right now. I thought this storm was mostly dissipated, but it is obviously not. It's kind of going. I'm not a fan of the spiders either. Alright, we're done. We got the energy shield all the way up. Now we can start working on getting. There's a bunch of other things we need to get, but this is a pretty good start. More tasers. We get the taser. The next thing's a Tesla coil. So that guy. Alright, we got an SOS somewhere, but I can't see it on the screen. What the heck? Oh, there it is. It's upper left. Alright. Here we go. We'll add the tank. The tank gives us some really useful kind of abilities. And he also has a shotgun, which is pretty cool. And while the shotgun is good, it's really good when he gets it upgraded, because he gets some machine gun, well, minigun. There's a rotating machining weapon. we got to pick up some kind of thing, which some of these are really terrible. We are going to get rid of. I don't care about that at all. We're going to take electric modifier for more damage, because this guy does all electric. So that works for me. And I always like this little Chemlight battery for a couple of reasons. One, Chemlights don't have batteries, that's hilarious. And two, it does an ability cooldown reduction, so I get that little dome up faster, and that dome is like, it's one of my best things for damage. So. It's actually taking a long time to come up right now. Alright, so this is why we get the tank right here. Saw blade through. Saw blade spinning around pretty good. And get a shot great. Yeah, this is not the answer to the tutorial, but it's true. We're enjoying Friday. Fridays are mess around days, so I am playing video games. This is called Yet Another. It's called Yet Another Zombie. I'm surprised I'm getting hit as much as I am. I very rarely get hit. I'll test this. That'll give me probably a level up. I thought that was more saw blade drones. More hit points. Update this little guy. We will take a SWAT guy. SWAT's, well, Ghost is pretty good too, but SWAT's probably the best in this case. This guy's super annoying. I don't know how wolves fit in with zombies, but or werewolves, lichen, right? What do you call them? I don't know how they fit in with zombies. Jumping around like that. So I guess we deal with what we deal with. Okay. We want his bullets to ricochet. We also want his bullets to be stronger. Like all boss poses. Come on, dude. Okay. That's weird. Don't know that crap. I think it's like a fourth wall break. So we know certain process running on. Alright, military training. We'll go with more experience. But I need to get my abilities to last longer, and I need the ability cooldowns as low as they can be. That's kind of important on this build, because then I get my little electricity shield up the whole time. And it's pretty strong. Yeah, see that little electricity shield is only up about 3/4 of the time. It's really up all the time. So, get a small place. Trying to grab that guy, so if you're wondering why I was standing right in front of something. Grab him with a shotgun. Now the gun can upgrade to pump action. Die. Blaster. I'll take the blaster. Blaster's a pretty strong little gun. Take Fury Unleash. Terrible. Alright, let's banish, I don't know, something. Oh, no, that's garbage. Okay, let's take that. It's all terrible, they're not giving me any good. It's almost like they know which ones are good ones, they're probably good. I've got a, there we go, just pump back. I swear it looks like something's up here. Oh, there it is. I've never seen that symbol like that before. Alright, come on, that's enough of that. Here's my ass kicked. More pump action time. Oh, we're almost dead. Nice. Okay, I can just stay away for a little bit. I do have a lot of extra kind of healing. Okay. Not like really fast healing, but I have a pretty good amount of almost dead. Minigun. That's a pretty good gun. I'm still alive. But keep running away. It's gonna be like Jerry. I just kept crawling and it kept working. Alright, we'll take more health regen, because I'm trying to keep us alive a little bit longer. More miniguns. Guys, I don't know how I'm still alive right now, but something's got to do. Oh god, they give me the worst shit. That's pretty good because it gives me a cooldown reduction on my abilities, so that little thing that triggers goes off more. There we go. Alright. So get the blast off. Screw it. I'd like to kill some of those bosses, but apparently that's not my fun. more electric modifiers. More electric statements. I haven't played this in a while, and there's a whole bunch of like updated things. Almost updated. I think I was playing this in early access. I don't even think I still like earlier today. I don't think I'd ever played this actually. I think I had only ever played the. Hold on. I don't want any of that crap. Jury. Minigun. By the way, I gotta survive another 10 minutes. I've only survived 10 minutes so far. That's not great. Alright. Bullet panel. Take a look at it. It's kind of like a shock that comes out in 1 second or so. That's pretty good. Ability duration. My abilities last as long as possible and do them as possible. Because if you can get that, you can have some pretty good little, like, overall abilities type things. SMG, and that SMG is bouncing off of stuff. So that's pretty good. More electrical damage. This little shield around me is electric. Doesn't help that I'm colorblind, so it kind of gives me a hard time picking up some of these things, picking up if they're good or bad. Always solar panels. Makes everything cool down. Really good. Look, man, my healed up the entire time. I'm almost 2. Not saying no, it's not bad. I don't know where that guy's at. Alright, this guy can have a sniper rifle. I don't think I've ever liked his sniper rifle though. We'll take Fury. And then we'll take more health regen. Get over here and take out everybody. I can see all the damage after shooting so much. I can see how much damage any one thing is. Actually pretty useful to tell how you want to build, who you want to use, you know, that kind of stuff. Ability damage, ability, nope. It's garbage. I know I've been following the arrows, but I can't tell the arrows color very well, so I sometimes I'm sometimes moving towards the wrong arrows, but the arrows also tell me where the bosses are. That's fine. Not what we call obstacles. Abilities are everything I have in the model. 4 more minutes on this round. All we gotta do is stay alive. I've been very close to dying quite a few times. I'm doing alright right now. more electrocutions. I don't know if I can track. We'll finish off the sniper rifle. I think all my guns are maxed on all my guys. Okay. Then all I gotta do is up the abilities, so we'll be done. Ability duration. We want our ability left. Done. We got like a minute left. All you gotta do is stay alive. Don't die, that's cool. Don't let something dumb kill me. Last 1 minute of the round. That's even worse. Hey. Especially if I keep getting those little things. Like the stars being the extra speed on my computer. Most useless thing in those games is that helicopter strike. I guess they'll take an EMP. More attack. But as long as I beat it, I will be there. actually falling asleep playing this. Yeah, I made 20 minutes. I think I thought that was ending it, but apparently this one, you know, I thought it said I only need to do it for 130. Okay, you'll keep playing if I still play. Ability duration. More ability. That one might do me in right there. Nothing even like that. Yeah, Gauntlet was pretty okay. Except in Gauntlet, I think your health always went down, and this one your health doesn't go down. This is a lot like Gauntlet, although you can't ever. You guys remember those Gauntlet Legends? You used to be able to go and knock out where the enemies were coming from. And I remember Gauntlet Legends from the this N64. Used to play it on there. All right, some of these are just terrible. Homing Pigeon's one of my favorite. The ability cooldown is lower, and the ability damage is higher. So we want pigeons because that'll give us that. I have this little shield, that little energy shield, and I want that up all the time. If that thing stays up all the time, then it really does stop most everything. Only the bosses do that. And what I've been doing is check for the 1, 2, and back up. It's only down for about 2 seconds. And give us time. That's really good. I'm dying right here. Oh, there we are. You got ran over by somebody. Yeah, this one's called. So let's see what was doing the most damage for me. The highest DPS I was getting was out of the electric turrets, and I didn't even want to take the electric turrets, so that's pretty funny. They were doing the most damage, but they only do good damage if you stay near them. These are 360 movement. Like yeah. These ones keep going. This game's called. The heck's this one called? This one's that's yet another zombie. That one, when it first came out, I think I got that one on early access too. It they had this one challenge. I had all the I had like all the challenges, But there was one challenge I could not get. So see, there's a bunch more. There was one challenge I could not get, and they took it out. They finally took it out. But it's you had to use the rocket launcher, and you had to bounce. You had to have like ragdoll physics of like 30 zombies at the same time. And I played with the rocket launcher. First of all, you had to get all the way to the rocket launcher. You had to have that picked as your, I think it's your SWAT guy that gets it. And then you have to get that many monsters around you. And the rocket only threw them in the air like half the time. And I don't know what determined when it threw them in the air or not. But that one was hard. I never had more than like 15 bouncing. And you had to have like 30. And I never got that one to work. I got some other ones, but you'll notice almost all of my games are that same style of game. I do not play a lot of games. If you were to see my son's library on Steam, he literally has so many damn games. But anyways, all right. Oh shoot, 7 hours. I've never been on 7 hours before. We're getting into some deep territory here. Here's what I'm gonna do. We'll find somebody to raid. I'll be back on tomorrow. We're gonna do more of the labs. And we'll do more of this stuff. We'll probably do less gaming tomorrow and more labs and more home lab stuff. I got to build some stuff out. So I definitely appreciate everybody that stopped by. Thank you guys for the follows. I think my alerts stopped working sometime in there. So I don't even know what follows happened lately. But I definitely appreciate everybody coming by. Let's go find somebody that is... let's go hit Running Man. Running Man's doing stuff. He's always fun to kind of hang out with. I think he's been on for like... I don't know, like 48 hours or something straight. So we'll go right over there. He's playing Dead by Daylight, so if you guys like his stuff, follow him. His stuff's always good. All right, take care, everybody. I will see some of you tomorrow.